wage simulator, which we can't afford, this poor little foundation school. And they're huge, those simulators. So what I've done is I've made an arrangement with IJmuiden, which is the nautical college at the harbour IJmuiden, Nova College, and I am allowed to teach you in class everything that you need to know theoretically. You have done plotting with me, XYZ plotting, so remember? Yes, look it up one time, because we'll continue on that. XYZ plotting, and we'll continue with that one. You have to be able to do all of that just like without thinking about it. And then you're going to play with this simulator for one full day. In the morning you will be playing exercises. The guy will be helping you. 2-on-1 simulator. I hope. I still haven't got an answer from them if they are allowed to do so. But I hope they still can, because those rooms are quite large. So I think the 1.5 meters shouldn't be a problem with mouth masks and anything. So you'll be going to IJmuiden for one day, playing with a radar simulator. At the end of the day, there will be one exercise which will be sort of assessment for the guy to see if you've got everything under control, which normally is the case. And then you'll get a certificate of attendance. And with our certificate, proof of proficiency, bekwaamheidsbewijs in Dutch, we state that you have the knowledge of the level radar navigator operational level, which is enough for our flag state. If you don't intend to become a first mate or second mate or captain on a sailing vessel, you don't have to take part in this extra class in IJmuiden. It's another €230, I hope, because if we're 15, I need 2 classes and we need to divide twice the sum with only 15 of you. So I still have to work out the finance. We don't have to earn anything, but it doesn't have to cost us anything either. So we sort of want to split the cost between the number of people taking part. For most of you, I've got a reaction, so I've made a list who wants to take part in radar. ECDIS is the other story. ECDIS you might have heard of. Electronic Chart Display Information System. Remember, I talked about it in the Kleine Zalvaart a little bit. On cargo ships and anything bigger than 3,000 tons and every passenger ship in the world, ECDIS nowadays is compulsory. That means there are no more paper charts. Those big yachts I was just showing you don't have paper charts. It's this big, just an oversized, I don't know what's it called, a large scale ocean chart. And 1 or 2 ports that are still not existing in ECDIS format, and all the rest is done electronically. But for this electronic chart you need an education. Also here I've made the same agreement with Dirk Redijk. He is the teacher, my colleague in IJmuiden. Very nice guy, by the way. He also wrote this beautiful book, which I was allowed to translate. What you have there is a uittreksel? Summary of what I thought was important for you guys out of this book. This is his book. If you're interested, if you do speak Dutch, I'll give you the ISBN number. I think it's on the first page of your book. And it's very handy to have it, this book. It's an excellent book. So he has given me his PowerPoints. I can do the PowerPoints with you guys in class on those ECDIS hours. And then you need 2 days. 1 day is not enough because ECDIS is quite complicated. You need 2 days of exercises with the simulator once again, but that will be the ECDIS simulator for which you have 12 in a classroom as well. So I have the same problem. I have to see how many I've got in one classroom, and then I can calculate the final price. Those are the hours that you see on your schedule called radar practical. Something on your schedule you see on a Friday, I think you see radar practical things, and sometimes on Friday you see ECDIS. So those hours are only for the ones that want to take part in those extra additional courses. Of course, you're very welcome to join me in class if you're interested, but you don't want to do the day at the nautical, at the institute in IJmuiden. If you're interested, just because you like it, feel free to join us, because we're only a small class anyway, so it doesn't bother if there's some people extra. Those are the ECDIS and radar practical exercises. I've also made you a schedule. Oh, I'm going to hand this out in a minute. I have a question for you first. And close the book. Close the book. Because you remember my first question in the Kleine Zaalbert indication fee, don't you? No, I gave you a present. First day of the Kleine Zaalbert, I gave you a present. I think it was a 35-meter schooner I gave you, in combination with the 35,000 euros and an empty bridge. And I asked you guys, what kind of instrument would you like in that bridge? And of course you all came up with a coffee machine, which is fine, because you need a coffee machine, but that's not a nautical instrument. So now I'm asking you, how many of you have been sailing, actually, the last few years on professional sailing ships? About half. Okay.
Overwhelming.
Overwhelming. So I'm asking those 5, which instruments did you really use? And you know what I want to hear, but I want to hear what you really used.
Compass.
You did? Ah, good. That's the first year that somebody starts with the compass. They all start with the Navionics and GPS. You did use the compass. Good. Which one, by the way? Who was it?
The wrong one.
Magnetic, gyro, GPS, or fluctuator? Magnetic. And we have different compasses, and in the Kleine Zaalbert we discussed the magnetic compass quite intensively. But of course we also have a gyro, and nowadays, I shouldn't call it GPS, I call it a satellite compass. And then you could have a flux gauge, which in fact is a magnetic compass. So those compasses we have. What else?
Radar.
Radar? Yes. AIS? Very important nowadays.
Yep. Depth sounding.
Yeah. And Lothar?
Here, Jeff. Lock.
I was hoping you wouldn't say that. I heard the word sounding. Lock, yes.
And some communication device.
Yeah, communication. I'll leave that out of my instrument lessons because that belongs to GMDSS, Marcom A, whatever you call it.
A good map.
Hmm?
A good map.
Yeah, maps, that's for AVE, navigation. Yeah, I will leave me out of AVE subject, you know. That's AVE's part. Come on. What's the last instrument we had in the Kleine Zaalbert? And I was hoping you would look more at that instrument than on the GPS, which I hopelessly failed.
Barometer.
Thank you. And I find myself teaching my new mates, stuurmannen, on sailing vessels every time again. That's one of our main instruments. That's the only instrument telling the truth. You can have as many apps on your phone as you like. This morning I got a warning for rain on my telephone app. I haven't seen any rain yet this morning, have you?
Yes.
Oh, you have?
Yeah.
Oh,
When I was not-
I've been inside too. But about wind, he is never lying. If Windfinder tells you you have 20 knots of wind and your barometer is dropping 2 millibars or 2 hectopascals an hour, you know it's going to be more than that. Whatever Windfinder tells you. So please don't forget the barometer and make an extra row in your logbook. I always do, because barometers are only given once every 4 hours, because normal merchant navy logbooks are divided in 4-hour blocks, and every 4 hours you're supposed to write down the weather. Well, the weather changes much faster than that. So I want a barometer reading every hour and not every 4 hours. But okay, we'll talk about it later. After this year, after AVE lessons, you will be using the sextant, I hope. Because despite all the progresses that are being made with I call it GNSS. We used to call it GPS, but by now there's many more systems than just GPS. We have Beidou, we have Galileo, and we have GLONASS, so global navigation satellite systems. And that in combination with a proper electronic chart makes an EGDIS. And the plotter you're talking about is nice for yachts, but absolutely forbidden for professional boats. You can get a major non-conformity if you get a, how do you call it, port state control. Don't know if you ever witnessed a port state control. Nobody has, some have. Port state control, foreign country, they come and visit your ship and see if everything is in order. Also procedures, ISM, engine room, everything, your exercises. They also come on the bridge. If they find no paper charts and one of those beautiful iPads with, what do you use?
No, radar, combi.
Radar combi plotter. Oh yeah, the beautiful design with radar and plotter combinations. I was looking for Navionics. Navionics or CMAP or OpenCVN. If they find that on your bridge, they are sort of okay, but where's the paper charts? If they find no paper charts, if they do find paper charts with no positions and no courses, you get a major non-conformity. It means you can't leave port. Huh? And I know myself how easy it is because I use OpenCVN. But please do use your paper charts. Do have positions in them. Do plan your voyage on the paper chart and make sure the paper chart is up to date. And because without an up-to-date paper chart, you're not complying to the SCCW. And they can, hoe noem je dat? Take away your safety, your vlagbrief. So, GNSS in combination with electronic charts makes an EGDIS with approved electronic charts. And otherwise, of course, you need paper charts for which you will need your sextant and your GPS and your bearing positions, which you've learned from AVE. So looking at this list, you'll find more or less the same list as we did when you did Kleinuzelvaart, I guess. So you're going to be wondering, what are we going to do then? We've all done that. Well, the basic knowledge you did with Kleinuzelvaart, I hope you still have your book from Kleinuzelvaart. Anybody doesn't? You don't? I'll get you one. Because that's, I assume that basic knowledge. Everything in the Kleinuzelvaart, I assume basic knowledge. And I know for some of you it might have been a few years that you did Kleinuzelvaart. Please dust it off and take it out of the cupboard once or twice and go look through it, because that's the basics and we'll continue from there on. I found myself fooled a couple of times in the last few years in the Grote Zeilvaart thinking that you would all know, so I will come back to it every now and then. Get it out of your memory again. So we build up from, not from scratch, but from somewhere. But yes, we'll continue on every instrument. Compass will continue a bit further. I'm going to look into the compensating a bit further than we did in the Kleinuzelvaart. Depth sounders and logs, I'm going to look into the calibration of those instruments and that kind of things. AIS, we're going to look a bit further than just the basics. So everything continued. Therefore, and I'm not allowed to walk through glass, so I'm going to hand it to you. Take one and pass it on. I don't know if that's corona proof, by the way.
Maybe not, because you poured the paper. That's the only way.
Yeah, touching is not a problem anymore. Huh? It's the aerosols. And then if you look at your nautical instruments PZV, you will find sort of similar sequence. The list I'm handing out is a schedule just as you were used to in the Kleinuzelvaart. For each lesson there's a grey block, and each grey block has a date, and it will tell you what instrument we're going to cover during that grey block. And for the guys at home, yes, I'll make it available on the website as well, so you'll have one in digital form.
Okay.
You got one.
I think I had 15, so yeah. Yep. So today you see magnetic compass and satellite compass. Then we'll have a Friday afternoon and a Saturday morning ECDIS, radar plotting, ECDIS, and another time radar plotting. Those are extra lessons for those courses. Then you see on the 7th of November, gyro compass, logs and sounders. On the 21st, radar, and then we go sextant, GPS, AIS, computers on board. That's an additional, that's not something you really need for your exam, but I know you're playing with them on board, so I'll give a little explanation about it. How to hook computers up to electronic navigation equipment and exam preparation. So that's what we're going to do in the 6 blocks. And the additional blocks are, of course, for the exercises, ECDIS and radar. So if you look in your book, you'll find the magnetic compass to start with. Who of you has done some kind of regular deviation check? 0, 1, 2. Some kind of regular deviation check, meaning stuurtafel checking it on a regular basis or
Twice a year.
twice a year. It's on the low side of some kind, but it is some kind, yes? Solving it?
Just some minor check when we're at anchor ring, checking the bearing from the top to the center.
But do you compare it with true
Yeah.
bearings? So you find out the deviation?
And we find out that we get a nice deviation.
Yeah.
It wasn't the same.
So I hope you remembered well that we had to make a deviation. Oh, what was it? Deviation. What was it?
Once a week.
No, but let's go back to what is deviation?
It's the compass error due to the compass being placed on the ship.
Exactly. The compass has an error because you put it on a steel ship or a ship with anything from steel. The compass will not point to the magnetic north pole of the Earth. The compass will point to the combination of those two. Ideally, you would want it to point to the magnetic north, which was the horizontal component of the total. Magnetic field lines surrounding the Earth, going from south to north. Yes, there's north, there's south. Going from south to north. And ideally, you would like your compass to point out that same direction, being H. Yeah, look up your KZV book once. You'll find it. The H as a horizontal component of the Earth's magnetic field. Ideally, your compass would point that direction. And on a wooden ship without any steel parts, it will. You know a lot of wooden ships, there's always steel on them, somewhere. The helm, the spray hood, the railing, an engine, maybe a generator. Everything from steel, everything electric will influence this horizontal component and will have a disturbing field. The disturbing field was made of 3 different kinds of magnetism. Being at 3 different magnetisms. Permanent, induced, and you can say it in Dutch if you want. Look in your book. Ja, maar look. We had 2 different kind of induced magnetism. Induced magnetism is the not permanent part. And the permanent part is in your steel permanently from the day it was built. The day the ship is built, all those magnetic parts in the steel get a certain direction and they stay in that direction. That's easy, that's permanent. But there's also weaker parts in steel, they can form themselves and shape themselves into a direction of an existing magnetic field, being the Earth's magnetic field. That can happen if the ship is sailing on a certain course for more than a couple of hours. So let's say you're going from Land's End to Cape Town, 11 days on a cargo ship, on a southerly course, with the vibrating engines. All those loose parts will direct themselves in that north-south line and will stay there for a while. And then you change course to the west, because you decide you're not going to Cape Town, you go to Brazil, or Argentina in that case, and you go to the west. The ship turns and all those little particles get confused and are still in that direction, and very slowly will start to turn in that new direction. That's the induced magnetic field. Altogether causing a disturbing magnetic field, which we call S, that's a Dutch word for storen, in English disturbing. So you call it a D or an S, but in the book I called it an S, so let's keep it an S. The combination of those two vectors, combining two vectors, you will do that a lot with Marijke this year, means just adding them, so putting this one here or putting that one there. So basically what you do, that was the H, and that's a copy of the S. That's the combination of the two vectors, meaning that you will end up, and I'm told not to do it in red because then it's hard to see on camera, so I'll try orange, which we called the directive force, H dash. The directive force is the north your compass will indicate. That's deviation. The angle between the magnetic north of the Earth and the magnetic north of your compass. And of course, Eve told you there's another one, variation. I'm not allowed to talk about variation because it doesn't belong to the instrument, the compass. So that's for Eve. So for the sake of this picture, let's just keep it to deviation. Magnetic north, compass north. That difference is deviation. The larger this S, the stronger, the bigger that angle. And now we had a rule for compensating your compass. Those deviation angles had to be
Within 5 degrees.
less than 5 degrees. If the deviation goes over 5 degrees, you need to recompensate your compass. If you can prove that the deviation didn't exceed 5 degrees for over a year, you're exempted from a recompensation, which saves you a lot of money, because a compensating guy usually charges around 500 to 700 euros. You do deviation yourself, or you had it done by somebody else?
No,
The compensating? No?
I haven't compensated.
Okay. Anybody's witnessed a true compensating compass?
Oh yeah, we witnessed on board.
You
When
witnessed?
we sailed to Rotterdam.
Yeah.
The, which was it? Which was the Stokkerman.
Stokkerman.
Yeah, we watched it.
You watched it?
We witnessed the guy doing it.
Okay.
Yeah.
Well, that guy costed him 500 euros.
Yeah.
So they witnessed him, and we'll talk about that in a minute. So this deviation can be different on each course because the S, the disturbing field, stays in the same direction relative to your ship, in this case port side stern. If your ship turns, that was the picture on your Kleinenzavat, if the ship turns it stays port side stern, so on a different course, let's say this course, the S is still port side stern. The S is still this direction. It's the same S, didn't change, only your course changed. The H didn't change, the horizontal component didn't change, so ideally this is what you want your compass to point to. Combination of the two, you will end up. Yeah. So now you have a deviation to the other side, and that's confusing. That is why you want to keep that less than 5 degrees. Because if you make a mistake between plus 12 and minus 15, you're 27 degrees off. Coming from Boston, that will mean Madeira or Morocco. There's quite a difference. So make sure that stays within the 5 degrees. How do we determine the deviation.
Compare it to a true.
Compare it to a true bearing. Where do you get true bearings?
With the lights
From a chart.
going at the board.
Lights? Yeah. Lichte line, leading line. Two lights, every port, every sea port. IJmuiden, Harlingen, even the Krabbersgat here in Huizen. It's got a leading light. You can find them on the chart. They've got a certain direction. I've showed you with the two lighthouses, I think, in classroom. If those two leading lights are for your vision in one line, you're on the leading line, and you can find the course of that leading line in your chart. So it's a very good habit every time you see a leading light in the chart or in the distance to go on it and check your compass, because that is called checking your deviation. Preferably on that same spot you do a few different courses. They won't always like you for it. In the Krabbersgat, please don't go turning around in circles because you get fined for it. But you can do it once coming in and you can do it once coming out. You can do it once crossing a harbour entrance. So you can do it on different moments. So leading lights, yes. A church tower and a harbour light. Everything that you can find on the chart, you can use as leading light. Anything else?
Sometimes you have the kind of deviation dolphin which are made for that you can hang around it and turn around it.
Deviation dolphin, kompaspaal in Dutch. They are in different ports. The advantage of that one is that the guy actually doing the deviation round knows from that pole to that church to that windmill to that. He knows all directions, so for him it's easier, it makes it faster, but it's still comparing a true course line from the chart with the one on your compass. So what more true course lines can we get? Geen idee?
Stars.
Stars? Yeah, quite difficult. With a compass and a star. But we have a better one, a better star.
Sun.
Sun. Sunrise, sunset. Sun comes up in the east and sets in the west, no? At least it looks like it. The earth is turning on. Of course, you learn from me. The Nautical Almanac will give you a table with a little calculation on every day of the year, on every latitude degree. You can find on how many degrees the sun will rise. So I told you in the Kleine Zeilvaart, from that moment onwards, if you see a sunrise, you don't run to your photo camera. Leave that to the guests. Guests run to the photo camera. You run to your compass and you take a bearing of the sun. Because that you can compare with the true bearing you should have had 50 degrees, 53 degrees northern latitude. The 17th of October, you can find in the table, very short calculation you will learn from Eve. Sunrise is at 84 degrees. Sunrise, check compass, 87, 84, 87, 3 degrees different, of course. We forgot about the variation, so we have the deviation of 3 degrees. Which is in fact true because on the isometer variation is 0.
There,
But
it's easier said than done. I've tried a couple of times, but it never worked because you're bouncing around with your boat and your compass is going everywhere. It's very difficult to do. I can
Okay,
do it
I don't know
myself.
what compass you have, but then it's not a stable reading.
No, it's a stable one, but it's moving around, so it's
Both
very
are small.
difficult to stabilize it. When
Okay,
you're bouncing around on a small sailboat.
yeah, small sailboats is difficult, that's right.
Yeah.
But the bigger sailboats goes, the less it bounces around.
Yeah.
And yeah, correct. Those round compasses on yachts is very difficult because it's difficult to take a bearing on such a round pole compass. On the flat compasses, the beautiful big ones on bigger ships, the ship is a lot more stable. It stays. You take a bearing with your notch and wire visor, and that really is not too difficult. So the sun is a good one, but we have more. So let's call it spheric bodies, moon, stars, sun, yes. But there's another way.
With gyro compass?
Of course, if you have a gyro compass, which we're going to talk about in the next lesson, the gyro compass has the big advantage, it's pointing to the geographical north at all times, as long as it's working. So a gyro compass, as long as it's running, will point to the true north, irrelevant of any magnetism. So you can put 5 magnets on top of the gyro compass, it doesn't care. It's only influenced by the rotation of the Earth. So as long as the Earth is rotating, we are living, gravity exists, the gyro compass will point to the north. So that's a good one. And nowadays, of course, we have satellite compasses also pointing to the north, which we'll discuss in a minute. So you compare your compass with this true bearing, either sun or church or leading lights or a true bearing. And what you get is a deviation table, which can be done as a list. Make it white for the camera. For every course, a deviation. And for every course, I mean all 4 main courses, north, south, east and west. All 4 in-between courses, intercardinale koersen, intercardinal courses. The cardinals are east, north, south and west. Intercardinal is all the ones in between, northeast, southeast, southwest, northwest. And preferably all the 8 in between those as well. Deviation, let's say it's -2. You go a couple of intercourses, you go 0.45, you go 0.90, you go and so on. And on each course you'll find a different deviation. That is your deviation table, and from that you could eventually make one of those beautiful graphs, which is on the bottom of page 6. On the right hand side you see a deviation table. Hey, you're looking in a time zone.
Ja.
Dat was al veel aantekenen met mij.
That's Kleinzaalbad. That's changed. Or do you have it?
Nee. Ik kijk even of de rest goed is. De rest is goed.
De rest is goed.
Ja.
Precies
Dat is wel
hetzelfde.
geslaagd.
Moet dan nog een kleine zelf doen.
Ja.
Je zit in het verkeerde lokaal. Okay, bottom of page 186, you'll find both the table and the graph. The graph is more exact because for every little distinguished course you can find your deviation, which is more exact. But then again, I always wonder, who cares if it's -0.5 or -1? I can't steer a -0.5 or -1, I don't care. But I do want to know if it's +3 or -2, because that's 5. So yes, you do look at your compass table every now and then, and you do know that if you take a bearing on easterly directions, you should sort of have in the back of your memory, if you're sailing with a certain ship for a longer time, you have in the back of your memory, all the easterly courses have some plus deviation, and the southwesterly courses some minus deviation. So you always know sort of, oh yeah, I have to add or subtract 1 or 2 degrees. On gyro compasses, on those yachts and autopilots, an autopilot will not be accepted if it exceeds 1 degree while steering. Those mega yachts, those guys, they pay a lot for those yachts, so they want their stuff to be working. Autopilot will not be accepted if the gyro exceeds the slangenlijn, the snake course of 1 degree. So there they do steer within a degree. You see each, I'll show you on the gyro compass. I have a gyro compass repeater in the next class, next lesson. Those go by 10th of degrees. There's an inner circle that goes every 10th of degrees. That's 10th of degrees. On sailing boats, as you all know, especially on the smaller yachts, you'll be happy if you steer within 10 degrees of your course, right? 5 degrees either side is quite acceptable. If you have guest steering, I always say you start with 30 and I'm happy if you end with 10 on either side. No? I think so. So then who cares about half a degree on 1 or 2 sides? But no, your compass should be pointing to the right direction, and you should be aware of your deviation table, because your other compass can fail. Your GPS compass or your gyro compass could fail at any given moment. If you have a power loss, they'll stop. So you're just sit there with your compass, and you should know. So even if you have those small compasses, make sure that you are aware of your deviation table. Fluxgate, we remember? We all do. Fluxgate electronic compass you have in your phone. Everybody's got one. Some of them even have them in their watch. I don't. My phone certainly has one. Fluxgate is an electronic coil creating a magnetic field. 90 degrees onto it you have another coil, so you have two coils. One creating a magnetic field, other one measuring the magnetic field, and as soon as that magnetic field changes you get a different power output. So you get an electrical output of your course, which you can use for different displays. Spread it around, display in captain's cabin, display on the guest's television screen, display for the autopilot, display for the radar, and so on. You can spread it around, which is very difficult on a magnetic compass. There are ways to get the reading of a magnetic compass converted into an electronic reading, but that also implies one of those coils, fluxgate compass.
And that is susceptible to magnetism. That
That would be my next question. Yes, thank you.
Oh, okay.
Is a fluxgate dependent on, or is there any deviation on a fluxgate compass?
Yes.
Yes, of course. It's a magnetic compass. A fluxgate compass is the electronic way of a magnetic compass. So you react on magnetism, so it will also react on the magnetism of the steel on board. So now looking at the steel on board, page 7 onwards, you'll find a couple of more fields than we've talked about in Lijmsaalheid. You will find a look now, which is in Dutch. I have to translate it on the spot, but I've translated it once, so I can do it again. On page 7 and onwards, you will find a longitudinal, a lateral, lateral I think. So this is fore and aft, longitudinal magnetic field, a lateral magnetic field, and a vertical magnetic field. They all exist on any ship, depending on the steel on board. The steel on board, as we said, permanent and the two induced magnetic fields, is there in the steel. Once the ship has been made, you weld the keel, you weld the hull plates onto it, you go hammering, grinding, welding and everything else on it. Once the ship is built, it's got a magnetic field, and this magnetic field has a vertical force, a longitudinal and a lateral force. All three of them exist. All three of them have to be calibrated. And that's what to do with compensating. So that's why we have those compensating material being, which materials did we have? Magnets. Weekijzeren bollen, the weak iron balls on either side, painted red and green. Did I tell you that story on Atlantis? I did, yeah, maybe not. Sometimes I skip this. I was doing this crossing with the Atlantis, the big blue Barkentine, 50 meters, 60 meters, I forgot. And we were doing an ocean crossing from the Caribbean back to the Netherlands, and I was coming on watch, and I didn't realize instantly. I was, morning, Mr. Mate, morning, Captain, and how are we? Yeah, we're good, we're on course, this and this, sales are set, such and so. Guess I happy breakfast just being served. Okay, I've got it. Wait, mate, something's wrong. I can't put my finger on it. Something's wrong here. What happened? Nothing, Captain. No, nothing. And then I saw those two balls were missing from the compass. Either side of the compass, you have this big, you've seen it in the hallway, there's one of those. The red and the green ball, they were missing. What happened to the balls? Oh, I asked the bosun to go clean them up, so he's grinding the paint off and he's painting them. So I found the bosun in the forepeak, having them in a vice grip with a big hakseslijper grinder, taking the paint off. Oh, that's compensating material for this induced magnetic field. This induced magnetic field is compensated by those balls. This position is very precise, and that was that kompassteller, compensating guy, is doing. Putting the precise position. So if you do take them off, I wouldn't personally, but if you do take them off, make a very careful mark where you took them off. And don't switch them. which was at that stage very difficult because even the bosun didn't know anymore which one he took from which side. They were both bare steel, and he had to paint them red and green, otherwise the mate would forget which side is port and which side is starboard. But he didn't care which one is what. So difficult. Don't do that. Leave your material in place. So we have magnets, we have weak iron balls, and we have one more.
And the bars in front. which you
The
can
bar in front.
turn upside down with
Yes,
the
the Flinders bar. Very good. Flinders bar being this. Do I have a picture on here? No. I think it's in your KZV book, which I just gave away. Oh yeah, I do have a picture. Maybe I can make it on the screen. The Flinders bar is that iron bar in front of your compass. I can't see. Compensating which one of the magnetism?
The vertical.
The vertical field. Yes. So the vertical field is compensated with the Flinders bar. The longitudinal, the latitudinal forces are compensated with magnets. Apparently random, but this guy pretty knows what he's doing. Put latitudinal and the longitude, the direction in the compass pole. We have one more magnet, which we didn't talk about in the Kleinzauber, because you might have seen it on the ship. The healing magnet. The healing magnet and now PowerPoint. Yeah, there we go. So here I've got my picture. The healing magnet is hanging on a chain right under the middle, under the pin, the compass pin, the pivot pin of your compass. Number 3 in this case. The healing magnet on a chain, a brass chain, not an iron chain, of course. Why not an iron chain? Iron has got magnetism inside. Think about everything you do with a compass, eh? Just as a side step. I've seen people putting their phones in the compass housing. I've seen people putting a portable VHF in the compass housing. Obviously they don't understand what the compass is doing, because the phone is full of magnetism. There's a speaker in there, there is electronics in there. You go watch your compass, if you put the phone next to it, it goes heap shit, at least 20 degrees. Let alone a portable VHF, same effect, or anything else. Compasses, keep them away from any steel and electric devices. Okay, back to the healing magnet. The healing magnet is underneath your compass. You can lower it, or you can lift it up. It's right under the center of your compass. As long as the ship is not healing, that's why it's called the healing magnet, nothing happens. You won't see the difference if you lower it or if you heighten it. But now imagine these Earth magnetic field lines, the green lines I've been drawing on the board. Running here, you can't see them, but these field lines are running from south to north. So they're running in this classroom. If I'm sailing here, let's say I'm sailing north, and I'm healing, what happens to my magnetic field on the ship compared to those field lines? Try to imagine a healing ship. Your vertical force goes this way, your latitudinal force, lateral force goes this way, the longitudinal force goes this way. So the longitude doesn't really matter, does it? This one matters quite a bit. This one matters a lot if you start healing, because that one will have a different influence on your compass than when you're still or healing the other way. That can be compensated with this magnet. So you need to heal one side, which is difficult if the compass guy is there, because you can't order a healing on a sailing boat. You can't create it on order, you can just create it on whatever course you're sailing. So if you're lucky this winter, you can sail on 2 tacks and you can do it. But then my question always is, will be, where do we have the maximum healing effect? On the north-south or an east-west course? You have 2 times the right answer. I was hoping, because I just did it here in class, that you would understand. East-west, the lines are going from south to north, so the green lines on the board are going this way, around the Earth. I'm sailing east-west. Does it matter? The vertical field with these lines? Almost nothing. Now does it matter? Look at the board lines here. If you see the lines from my boards on the floor, if I do this, it's completely different. So yes, on the north-south course, you have more influence from the healing correction than on the east-west course.
How do you do the compensation?
Difficult. Very difficult. Yes, just by experience. So that's why you try to compare your deviation table also when you're sailing. When you're sailing on starboard, and now we go into square riggers with steel yard arms. They exist. A lot of them have wooden yard arms, nothing happens. On steel yard arms, you'll find, Stad Amsterdam is a good example, if they brace around, they have a different deviation. Bracing around the yard arms gives a different deviation. That's why you need to do it on a regular base. So you find out, okay, on the starboard tack, north-south, we need to calculate ourselves with another 4 degrees deviation, and on the port tack it's almost 0. On the port tack not healing, it's -1. On the port tack healing, it's 0. Again, the difference is not that much, but it's good to know. It's good to realize that there is a difference. So do check your deviation on different courses under different conditions. That also brings me to your initial compensation. The initial compensation, the guy does with this table, you need to make your ship sounds ridiculous, magnetically ready for sea, meaning normal working conditions. As long as you're moored alongside the quay, forget about compensating. There's influences from the quay itself. There might be ballast, there might be cranes on the dock, there might be a car parked right next to your compass. Forget about it. So go out to sea. Funnel, big cargo ships, and even those yachts, we are not allowed to do the calibration on those yachts within the first half hour. The funnels, schoorstenen, are cold. When they're warm, they have a different magnetism than when they're cold. So they need to warm up. The funnels need to be warm. Your cranes, if you have cargo ships, or yards, if you have sailing ships, need to be in sea condition. Sea condition on a cargo ship is easy. Cranes in the holding position. Hatches closed. On sailing ships that's difficult, so that's why I tell you, realize that different bracing might result in different deviation. Your ship needs to be ready for sea, magnetically speaking. If you have been moored alongside the dock for over 3 months, 4, 5, 6 months, which is quite common for charter ships, 6 months in Heilingen, steel docks, steel plates, underwater, yachts in a big dry dock, how do you call it, hallway, hull, yachty hull. And they are in a different magnetic condition than once they go sailing. Don't do it right the first day, give it a couple of days, because of this induced magnetic field. This induced magnetic field will stay, if you've been alongside the dock for 6 months, this induced magnetic field will stay for a couple of days. So do your compensation after 3 or 4 days at sea, not straight away. Let your ship get magnetically ready for sea before you start. Oh yeah. The vertical component of the Earth's magnetic field. This is back to Kleiner Zauvert, for those who don't remember. This is your total intensity, meaning the magnetic North Pole being somewhere here. We are not looking at this angled vector, we're only looking at the horizontal vector because our compass is floating in this liquid. This compass card is floating in liquid. So we are looking at the horizontal component. This component can be divided into a vertical and a horizontal component. Now the vertical component in this case is just disturbing us. But what is the biggest advantage of a magnetic compass? If I go that way. What happens if my ship, oh this is on land. Let's say it's a ship. If my ship goes this way, what happens with the V, the T? What's steiler? It goes steeper, goes down. So what happens with the H when the T goes down? The H gets smaller and the V gets longer. The V is just disturbing me. The H is the one I want. The H is the green lines I'm drawing here. So the H is the one you want to. The closer you get to the pole, the shorter the H will go, the more influence the S will have. Because if one of the vectors goes smaller, the influence of the other vector will be bigger. That's what happened close to the equator. That's what will happen close to the poles. I didn't even know I had this moving in my
So you need a different deviation table if you move north.
Yes, yes. That is why on longer voyages you need to keep your deviation table and make corrections and note them in your logbook. Now there might be the occasion, especially if you go on ships like Stad Amsterdam, Oosterschelde, Europa, Gulden Leeuw, they travel worldwide, Wilde Swan, and they travel, I've personally done a trip with Oosterschelde from Rotterdam to Ushuaia. Ushuaia being 62 degrees south, Rotterdam being 53 degrees north. There's quite a difference. This is about 50 degrees north. Oh. That would be getting closer to the equator. On the equator it would be 0. But then going south, that total, and the north is down here, so the south would be down here, so if it would be going south, it would actually want to point upwards because it will be pushed away from the south magnetic pole. So the V goes the other way around, and the closer you get to the south, the larger the V gets and the smaller the H gets again. But on a different way. So that's why you need your Flinders bar for correcting that vertical force. So this is what we've done. Didn't know I had all this drawn. And this is one course, deviation. That's another course, deviation. This is good for yourself. I'll have this PowerPoint on the internet. What does the directive force on your ship depend on? Course of the ship, distance to the magnetic north, meaning the position on Earth, and your own disturbing field S. And your question is, which one can be changed? Which of those can you change? Well, of course you can change the course of the ship. In that way you get different deviations. You can change your position on Earth, yes, of course. But what we do with compensating is actually that disturbing field S. The two reasons, we had the 5 degrees, somebody said it has to be less than 5 degrees. There was another reason for compensating.
The H, there has to be around 1.
The H?
The H dash needs to be very similar to the H.
Yes, the ratio between H dash and H needs to be as close as possible to 1. Because I can imagine two courses where my deviation is 0 in this picture. On which course is the deviation 0?
You go in the same direction as your S.
Direction of S.
Yeah, if you go in the direction of S.
Yes, or opposite.
Or opposite. Yeah.
Yes. If the S is parallel to the north-south lines, so either northeast or entirely the opposite southwest direction. The S will be in the same direction, but either with or opposite the H. Your deviation will be 0. But then what will happen, you see some people looking at what is he saying? Hello? Hello? Yes. On the picture on that screen I had the S the other way, so let's do the S the other way. Those are green lines. If my ship would be heading northeast, and my S being starboard to stern, this would be S. This would be H. We'll do this with radar as well. How do you add two vectors in the same direction? Well, still just keep going the way we did. Take the S, put it on the top of the H. So that's the S subtracted from H. So you end up with the. I'll make it orange. Where's my orange chalk? That's H dash. So now the deviation is 0, so we comply with rule 1, less than 5 degrees. But the ratio H dash is about half. So the directive force, the strength of the field, is a lot less. So you still have disturbing field. Although you have a deviation of 0, it will be a very weak, so a very restless compass on this course. On the opposite course, the S added to the H will give an H dash 1.5 times H, means a big ratio, a very stable compass. So for this course, on this ship, on this position, this will be an excellent course. S, H, and I don't even have enough room for H dash, well just H dash. You with me so far? So both rules have to be complied to. Yes.
Would you, I mean, it's clear that you can calculate the S. Is that normally done, or is it only the deviation that is being taken?
You can't. You can't touch it, you can't feel it, you can't see it. So the only thing you really do is determine your deviation and construct it the other way.
Yes. So
that's what the compass adjuster does. He sees plus 5 degrees on one course and minus 6 degrees on another course. Then he says, okay, the S must be this way.
And I think it's good to know the S roughly of your ship.
Yes, because then you can start, okay, the S consists of a very strong longitudinal magnetism and very little latitude, or the other way around. Yeah. So that's what they basically do. They make your table to start with. Yeah, the guy goes round and round. Okay, he's got a table. He's got plus 5. He's got minus 10. He goes to plus 12. So then he says, okay, on this course plus 12, on that course minus 10. So the S must be that way.
So he deducts it from the table.
Yeah.
And then he takes it.
And then he starts taking.
That's also how it works in practice.
Well, he doesn't draw it for you. He knows it in his head.
Yeah, okay.
He does it because he knows, okay, on this course we had so he sort of figures this out in his head. He said, okay, the S is port side abeam. Okay, then we have a very strong latitudinal field and almost no longitudinal field. So we have to correct with a lot of latitudinal magnets. But now I'll start helping you because there is, okay, in your book, I don't have the book anymore, so there is a guidance for compensating your compass. Simple recompensation. The bottom of page 20.
10.
No?
Page 10.
Oh yeah, 10 and the top of page 11. And on the 16th of March, when you've done all your exams, or even in December, because that's my exam, when you're done the exam, you're allowed to cut this out of your book and to plastify it. because this might help you in some conditions to do an own recompensation. Always realize, if you start playing with your compass, make a proper drawing or picture or both to mark all positions of the present compensating materials. Where are the magnets? Not just 2 magnets, not longitudinal and 1 latitudinal, which hole? Because in this compass ball there's 15 holes for them. So make a picture or drawing, there's 1 magnet there, there's 1 magnet there. This is a long magnet, that's a short magnet, take a picture of the magnet and put them away. Before you start, because if you make a fuck up, you can always go back to your original position. I've personally done it, because I forgot one rule. I had my ship magnetically ready for sea. I was in Mauritius with Oosterschelde, and Oosterschelde came from Rotterdam, went to Rio, went to Cape Town, went to Mauritius. So that's quite a distance and quite a great difference. Yeah, here we go. So we were in Mauritius in a beautiful, beautiful bay. I'll show you a picture in a minute because I need to slow down myself because I see your reactions are getting slower. I'll show you a picture in a minute. It was beautiful. Beautiful bay, and we had a day because the voyage crew, the guests, took a long hike ashore, and we sort of had time. And Maarten, my first mate, he said, Bernd, we really have troubles with this compass. You're good at it, aren't you? Yes, of course. So let's just do a little compensation because it's getting hard to steer, especially for guests. We found that the compass would follow your course. You would slowly go 5 degrees to starboard, and your compass would just follow it. And as an experienced sailor, you think, hey, that's funny, the sun is there, now the sun is there, we have the same course. So we found that the compass was restless. So we said, okay, I took my own book, I said, let's do it. I did a full circle, lift up anchor, did a full circle, took a couple of bearings, and took proper pictures, took the magnets away. And on Oosterschelde we don't have a big compass pole, we just have a couple of magnets glued on the roof top, because the compass is sitting on the rooftop. So a couple of magnets on the rooftop, we took them away, we put them a little closer, a little further. I did the full round, I did it once, twice, 3 times. I said, Maarten, it doesn't work. So Maarten comes and he reads in the book, yeah, no, but it should work. So we did it again and again, it doesn't work. And okay, fuck it, let's put everything back the way it was. So luckily we made a picture, put everything back the way it was. The next day Maarten said, Bernd, I had anchor watch this night and I was sitting on the bridge and I was reading in the chart. Except from making your ship ready for sea, read the notes in your chart. Due to volcanic activities, the magnetism on this bay can be exceptional. Was a special note in the chart, exactly in that bay. Of course, that had to happen to me. I promise you.
You didn't tell to Eve.
Unfortunately, that was the same voyage that Henk died.
Oh.
Yeah, that was May 2013. That was exactly the same voyage Henk died. Come on, you can do this. Open with. That was this bay, I was together with Europa. I must admit, one of the most beautiful, just beside the instruments, just a short break. One of the most beautiful bays I've been in my life, and I later found out that both, what's this Portuguese discovery sailor?
Vasco da Gama.
Magellan. Vasco da Gama, yes, that's the one I was looking for. Both Vasco da Gama and the guy that went around Cape Town the first time, Hoorn, Good Hope, Schouten. Was it Schouten? I think it was Schouten.
Tasman?
No, it wasn't Tasman. Well, okay. Both discovered this bay I should have a picture because it's really amazing. We should have the chart somewhere. I hope. It was on the eastern side of the island. Mauritius, you probably know where it is. On the eastern side of the island there was a bay. The ocean comes from 3,000 meters. The entrance to the reef, I don't have the chart picture, but I have the reef entrance. Oh, no.
Google Maps.
Yeah, Google Maps will show it to you if we need to. This will work too. No one.
What was it?
So open to the east for 7,000 miles. Completely open ocean, 3,000 meter depth, a reef, an entrance, and a bay. Waterfalls coming down, fresh fruit, fresh water. Vasco da Gama discovered that. That was the place to stock up fresh water. And since every world traveler has been stocking up fresh water in this bay. The entrance, we sailed in, and I must still admit, I consider myself quite an experienced captain. I have GPS, I have charts, I have even electronic charts, I have an echo sounder, I have a very detailed overview of the situation. I almost shit myself getting in here. And I was wondering how the hell did the guys do this, not knowing what they were expecting. Because looking from up in the mast, this was the bay, this was anchored in the bay. Okay, now where is the picture from up in the mast? This is the entrance. Yeah, here I was up in the mast. This is the entrance. So this is Europa coming in. This was me, and the first mate Martin was on the helm. I was personally standing in the mast to find the little spot in the reef opening, because up in the mast you can see a lot better. Of course I knew where it was because I had an electronic chart, but realizing that it wasn't the best charted area in the world, I thought maybe it's a wise idea to stand up there. It was, because of course the chart wasn't too exact. And we could still see the opening, we knew how big the opening, how deep the opening was. And I thought, how the hell did they do that 400 years ago? They had no chart and no idea, and just a hand sounder to find the depth, which was 400 meters at this spot.
They probably did the same thing up in the mast.
Up in the mast and shit themselves. Probably what they did. But you can see Europa passing the reef at 400, 500 meters water depth. 0 water depth, just sailing by because we knew it. Here we go. Coming in. And once inside, you're fine. And we both beautiful. We had a full voyage crew. We sailed in and turned around under sail both almost simultaneously and dropped sails and dropped anchor. Beautiful moment, by the way. There you go. Backing the sails, taking them down one by one and dropping the anchor. And this was our view, looking to the east. This is one of those, I mean, I must admit it's not like in my life every day I have these moments. They're very rare, even in my life. But these are the moments that you really think, wow, this is what we're all doing it for, huh? Anchoring at such a spot, looking at this view, where discoverers would have been like 400 or 500 years ago. No, even more. 700 years ago. So yes, that was a short break. No, don't go. Okay, so you may use this table as a guidance, but please make a very careful note and a picture and a logbook before you start, and make a deviation table after you've done it. And still then, it would be wise into the next port to have an official guide, because he can stamp it off and you still fulfill your flag state demands, because officially you're not allowed to touch your compensating material, but if you have to, you have to. Because if you have a restless compass, you can't steer. So at some stage you just might not need to. So any questions about magnetic compass? Quite a talk. Fair enough. I'll continue with the satellite compass because the next one in your book I think is the gyro compass. For which I want you to do two things, because the gyro compass will cover in lesson, the next one being the 7th of November. We'll cover the gyroscope. I would like you to memorize, learn by heart, the two laws applying on a fast spinning top. De twee tolwetten in Dutch. Laws applying on a fast spinning top are two of them. One, a spinning top, a fast spinning top, without any influences from the outside, which is very hard, will keep its position in space. Will want to keep its position in space. What does it mean? If this is the axis of a fast spinning top, and next time I'll bring a bicycle wheel, and I'll bring one of those playing tol. Yeah, and tol is a fast spinning top. You probably know them, those gyroscope playthings. You can make them turn really fast and you can let them dance on the court and stuff. I'll bring them next time. So if this is the axis and this is the spinning direction, so this is the disc spinning around it, meaning if I would keep that fast spinning top into space, like this, no matter what happens, it will stay like this. If I would throw that fast spinning top into the classroom with the axis pointing like this to the other corner of the classroom, it won't go this, no, it will go just like that and will come down due to gravity. That's the force applying on it. If you apply a force, the second law of fast spinning tops, if you apply a force on a fast spinning top, it will always counter-react with a force 90 degrees to that force you are applying, which is in fact what you're doing daily. That's why you don't fall off a bike. Please, don't keep me on that. Don't try it at home.
Can you repeat that second law?
If you apply a force on a fast spinning top, it will counter-react, it will respond with a counter force 90 degrees to that force. It's in your book. They're both in your book. Oh. Ever had a grinder in your hands, a hakseslijper?
Yeah.
You know it. You want to turn the hakseslijper this way, the grinder, it will want to fall out your hands this way. If I'm sitting on
your wheel of your bicycle.
exactly, if I'm on my bike, and now I'm saying, remember the first one, if no other forces apply, which is not the case on the bike, so please don't try this at home, because on the road there's leaves, there's wet, there's ice, there's snow, then my story won't work. On the perfectly condition, if I'm riding my bike, as long as my bike is rolling, I can't fall off. I take my hands off the wheel and I try to fall off this way, it will immediately respond with the 90 degrees and it will pull the bike underneath me. I can't fall off this way. A fast spinning top, I'm not meaning like a rolling bike, I'm meaning like a cycling bike. That's why I can go into a corner hanging 45, 50 degrees and won't fall over, because we'll just continue putting that counter force onto it. Memorize those and think about them, because that's the whole rule the gyroscope works. We will continue with the satellite compass. I don't know why I turned it off. And satellite compass is then the next chapter, I think, in your book, after the gyro.
Hoe stel je de koers in met een vliegtuig?
Dat gaan we eens even nog even. He's asking how to apply your course correction on a gyro, or your course into a gyro. That's what we're going to do the second. Don't worry. Yeah, 20 more minutes. beste kant het. By the way, normally I'm not the kind of teacher that likes putting everything in PowerPoints, but since the situation with Corona, people might have to stay at home. If, and Cosmo will tell you as well, if at any stage during this lesson year you have family or roommates or housemates that have Corona, you might need to stay at home. That's why we have this possibility with the camera. I will put all my PowerPoints on the website and I will share them with you. I will also offer you once a week, 1 hour Teams meeting. Me and everybody who wants to can join me in a Teams meeting for questions you might have or are not clear during lessons. Might need to explain some Dutch words. Please do stop me in the lesson if you don't know the English word. Some of you are Dutch and maybe not too familiar in English. Please stop me. I'm sorry, I don't know them in French, but I'm quite good at German, so I can help in German, not in French. But I'm always willing to stop for a moment and do it in Dutch for a second, for the ones who are not too comfortable. But this Teams meeting once a week, I will try to organize. I have the Kleinersavond on Wednesday, so let's do it on Thursday. Thursday, 8 o'clock, evening. Or is it too late? Is that too close to your next day lesson? Would you rather have it on Sunday or Monday?
No, it's not right.
We can try it. I'll send you, please do send me a mail if you want to participate. My mail address, that's also for you guys at home. Berend@azs.nl is my mail address. Bvolmer works also, same address, doesn't matter. For those who don't have access to Teams, we have a educational license for the school and for everybody who wants for Office 365. So if you do want a temporary license for Office 365, please realize it will run through 1st of April 2021. That will cut you out. So don't save any private material online, because from the 1st of April 21 it will all be gone. But you can get a student license for free. I have an unlimited amount of licenses for students on Office 365, meaning online. You can't download your entire Office suite on your computer, but you can use it online. Excel, OneNote, PowerPoint, Word, all the parts of Office that exist in Office 365 you can use online. You get a student account with a student email, and so if you don't have access to Teams, I don't know, I mean it's Corona since March, so many of you must have had meetings on Teams before, but some of you might not have. Please send me a mail that you want one of those licenses, and then you can use it on your computer. It works on Mac or tablet or anything, because you're working online. You're not dependent of a system. Don't need a smart scan, just need this one. Neat. Actually, I think one of the good things of Corona is the development of this kind of things. I've been doing team meetings since March now, and I must say it saved me a lot of travel time. And if you have a proper organizer in a Teams meeting and everybody knows what he or she is doing, It is a very good meeting because you look at each other, you raise your hand if you want to say something. Please don't start talking all together because then it gets mixed up in your ears and microphones. Raise your hand if you want to say something. It really works nice, and I think that's a big advantage that we all got to work with this modern stuff. Some of you do probably due to your work. You can stay at home. And I do a lot from my home office. Just sit in my home office. Satellite compass. It's got nothing to do with the GPS positioning system. It's a different instrument. Your GPS, or I should call it GNSS due to the other systems that exist, but let's call it GPS for the sake of easiness. Your GPS always indicates a course over ground. Course over ground is not your heading. Course over the ground is your displacement over ground. If your ship is going sideways, that is my course over ground. That is my heading. A satellite compass indicates my heading. It's got nothing to do with course over ground. So it's a different instrument. Although it's a GPS receiver, it can also give you course over ground. But please, also when you're saying, do not mix up course over ground and heading. Your heading is the direction your bow is pointing. So if we're talking about compasses, we're talking about heading. Your heading can be true, your heading can be magnetic, your heading can be gyro. Gyro and true should be the same, although on the 7th of November I'm going to tell you it's not. There's always a little gyro correction. Satellite and true is the same heading. Heading over ground, which is not course over ground. Don't mix them up. Course over ground is a matter of displacement. It doesn't take into account where your bow is pointing at. So now we're talking about a compass. A satellite compass indicates your heading over ground. How do they work? They have a 3 or 2 antennas. 1, 2, 3 in this case. They also have satellite compasses, as you can see on this picture, with only 2 antennas. The Raytheon has 2 antennas, the Furuno has 3. I'll come to that later. The 2 antennas, sticky, yeah, are at a fixed distance from each other. 50 centimeters. The distance doesn't matter. Could be 40, could be 53. I don't care. As long as the instrument knows. The distance between A and B is exactly known, is as a fixed known number in the instrument. Now what the instrument does, due to the signals from one single satellite, the frequency of the satellite can be determined, and the frequency takes a certain time from the satellite to the antenna. That time is known. That's the basic principle of your GPS positioning system, but forget about it. The frequency difference between this one and this one. Received, because this one takes this much longer to get to that antenna. Now imagine, 36,000 kilometers, and then you would say 50 centimeter makes a difference. Yes, it does. And it can measure that difference. So the only thing the instrument does is measure the difference in time between reception of this one and that one. If this distance is known and this red line distance is measured, you're there. Because then it's algebra. This is 50 centimeters and this is measured, the red line between here and here. How do we know This angle, that's algebra. Cosinus, sinus, tangents. You get a lot about that from Rijke, but you probably know most of it already. So it just has to multiply it with the cosinus of the length, the delta d. How does it know the direction of the satellite? Well, that's very easy. In the information of the satellite, the position of the satellite is given. With your position and his position, you know the direction of the satellite from your position to his position. So it only needs this direction difference calculated here, added with the true north direction of the satellite, and there you go, you have a satellite position. Now that sounds very easy. It is in fact that easy, as long as the thing is standing still. Now we start rolling and pitching and yawing. So that whole thing starts moving, so now it needs to make corrections all over the place. One of the systems to make correction is add a third antenna and do the same calculation here, and here, and here. 3 directions, 3 calculations, add them, divide them by 3, it's done. You don't need to worry about it, the computer does it. So the one with 3 antennas makes its own correction. In your book you will find true bearing satellite, sorry, I'm one step back. True north, this direction. True bearing satellite, that is known, because you know the position of the satellite, you know your position, so you know the true bearing of the satellite. So that's where it adds this angle between A and B. That's one step back, it was too fast. Delta D is the difference in distance between the perpendicular line to this and this line. So that's how this is fixed, this is measured, this is calculated, and this is known. This one is for correction. The other system, and that's quite complicated, I'll go back to this slide in a second. What about the rolling? Mr. Einstein found out. De relativiteitstheorie van Einstein. If a light is sent from one direction and another direction at the same moment, it will travel at the same speed. If that object sending it is moving, it will still travel at the same speed from me, but this direction it will go faster than that direction, because I'm moving. This is the same speed, but I'm moving, so this one is faster than that one. So how can I measure that? Make a coil of 500 meters glass fiber. 500 meters glass. I don't have 500 meters on my ship. Yes, you do. In about this big. If you make a coil, you turn it around. Millions and millions and millions of times you can make a coil of 500 meter glass fiber. So let's say my left arm and my right arm are both a coil of 500 meters glass fiber. In the middle, exactly between my hands, I have a measuring tool. And in my bone, exactly between the middle of my arms, I have my sending tool. I send one signal this way, one signal the other way. It will arrive at this position exactly at the same time. Now this has to be measured exactly the speed of light at 300,000 kilometers per second, as we know. That's why we need 500 meters and not just 1 millimeter. Otherwise you can't measure. On 500 meters you can measure the difference in time from here to here and from here to here. That will be the same, except when I do this. When I do this signal will travel shorter than this signal, because this signal has to travel a longer distance, 500 meters plus this. You can measure it's amazing. You can measure the difference in movement over 500 meters plus 20 centimeters from here to here. So it measures the time difference this way, this way. That's for my coarse luring. It can also measure this way, same principle, my pitching, and it can also measure this way, my rolling. So 3 of those coils, 6 of those coils in fact, 2 this way, 2 this way, and 2 that way, give you a correction for every single movement you make. We call this the gyro optic fiber device. I've been telling it all, and here's the pictures. That's my arms, those two rings. That's the interferometer measuring the moment of arrival. The prism is sending the signal away. Interferometer is measuring the moment of arrival. In a coil 500 meter this way, and that's what the tool looks like. Literally, it's this big. The whole thing is this big. Gyro optic fiber. 6 times 500 meter of glass fiber in it. It's that big. To the computer processor of the instrument itself, it gets a signal from the antenna, the double antenna. It gets a correction for the fiber optic gyro, and it will give you the heading independent, of course, changes, rolling, pitching, and yawing. Quite impressive. And by now they are about €2,500. As for a gyro compass, €15,000. Choice is pretty easy, huh? Although the shipping law still is 10 years behind. Shipping law still prescribes for cargo ships over 3,000 tons and passenger ships a gyro compass. A lot of smaller ships, our kind of charter ships, are below 3,000 tons. They are currently stepping to a satellite compass because a gyro compass takes a lot of power, makes a lot of noise, and is a lot more expensive than a satellite compass. So on Europa, on Oosterschelde, on Eendracht, you'll find satellite compasses. On Stad Amsterdam, being an official passenger vessel, you'll find the gyro compass because the law prescribes it.
But also there's more maintenance on the gyro compass. Does this require maintenance?
0. The only thing it requires is satellite reception at all times. So this one doesn't work in between high buildings. Chicago is a beautiful example. I've been in Chicago. You're literally more in between the skyscrapers. You only have this much horizon. All GPSs and satellite compasses stop. Maybe 10 seconds a day you get a position, and all the other time you get nothing because the skyscrapers block your spherical view. But that's one of the exceptions. Out at sea, no problem. A big boom, above your antenna, can block the reception. Eh? So be careful where you put this antenna. Also be careful where you put your fiber optic gyro. You don't want that in the top of your mast because that's the most moving part of your ship. Put that somewhere in the meta center of your ship. Meta center, Marijke? Yeah, you still know? You will get to remember in another half hour. Okay, yeah? So this is basically the whole instrument. So either a correction by third antenna or a correction by the fiber optic gyro. The big advantage is you have digital output which you can send to multiple addresses. You can send it to your ACDIS, to your radar, to your autopilot, to whatever your AIS, display on the bridge, display in the captain's cabin, display in the guest cabin, whatever you like. You can multiply it as many times as you want. That's why this is endless. So it's actually quite an easy compass with a couple of advantages. No moving parts, accuracy less than half a degree. Very suitable for fast ships because its reaction speed is faster than the gyro. And fast ships, now I'm talking about 40 knots, but nowadays they're building even water jet driven ferries doing 35, 40 knots. If that thing is turning fast, the gyro can't follow it. The gyro is too slow for that thing, so your compass is always 2 seconds late. This one can have a reaction speed of 25 degrees per second, which is still, I mean, if you sail on one of those, count on them, the fast rescue boats, they're still turning faster than this, but it's more acceptable than a gyro and a magnetic compass. But disadvantage is also, it relies solely on, not GPS anymore, it's GNSS, it relies on satellite reception. And nowadays, of course, we have Russian, Chinese, Dutch, or European and American systems, so we have 4 systems at the same time. So the trouble between the countries doesn't matter too much, but the atmospherical suppression can still be done at any given moment. GPS jammers still exist. You can even put one there, that's what car thieves do. You have those tracker devices in your car to be able to find your car. Don't worry about it. If a thief wants your car, the first thing he does is a GPS jammer in your car, so the GPS tracker is rendered worthless and he can go wherever he likes with your car. And it doesn't matter if it's GPS because it blocks all satellite signals.
Aaron, which system is more accurate? The one with the 3 antennas or the one with the 2 antennas?
The one with the 2 antennas is more accurate because it responds faster to rolling and yawing than the 3rd antenna. But at the end, you won't notice the difference. The laser gyro compass, you have to read in your book because it's 40. I have to stop. I'll do next week. In your book, you'll find the laser gyro compass, which is basically the fiber optic gyro. If you tell that fiber optic gyro, this is north from now on, and he measures all your movements you're doing, he knows that's north because I'm moving this way, I'm moving this way, I'm moving this way. It can measure your movements comparing to north. So there is already a fiber optic gyro compass. We'll go into that the 7th of November. So please read through this chapter and make sure you have all answers. I will send the ones that send me a mail a Teams invitation. That will be not this week but then the week after because next week I don't have you. Or maybe we do the first try this week. I'll give you a date. Let's keep it on Thursday, 2000 hours. If you do want to participate, also you at home, send me a mail on this address. If you do want an office license, send me a mail on this address. We'll give it a try next Thursday. 7th of November we'll do gyro compass and the leftover of the fiber optic gyro compass, which is basically sort of the same thing. Yes.
The dates for the IJmuiden,
I don't have yet.
you don't have.
As soon as I have them, I'll communicate them to you. Sorry, I can't go any faster than they are still struggling with their schemes and everything.
Will it be on a working day or on a weekend day?
We'll be working. Yeah, it's a normal school. We're not. We're only weekends.
Okay, good.
And it's sure that it will be before December.
Yes, because I know that in December you have exams, and then so yes, I'll make sure that it's the end of November or maybe the first week of December. But before the not the week before the exams, because I know that the exams then you're busy. You can go to the toilet. I wish you a very pleasant day, and enjoy. Stay healthy. Stay safe. Thank you. Die extra lessen, dat is allemaal. Dat zijn wel die klassen die mails doet. Stuur hem nu meteen. Is dat wat? Ja, nou dat is
Dank je wel.
tot de volgende. Wat is jouw mening?
HP.
H-A-P.
Nee, gewoon HP.
H-P.
Waar zeg
Duits.
Heb je ook een soort, hoe noem je dat? adreslijst voor de grootste.
Ja, we zitten natuurlijk met de AVG en zo, en dat moet je voor bij Brigitte en Cosmo wezen.
Wanneer dat je zei dat je het zelf verstuurd had.
En via kantoor.
Oh, via, ja. Dus ik zal Brigitte even vragen of ze het
Meestal krijgen we ook al een lijst van degenen die in de klas zitten. Maar ik weet niet of jullie tegenwoordig kunnen krijgen.
Ja, dat mogen we niet meer vanwege
Mag niet
AVG,
meer.
hè?
Tenzij
dat moet-
iedereen toestemming geeft. toch?
ja.
Ja, dus
Tenzij
dat,
iedereen individueel toestemming geeft aan anderen.
het makkelijkste voor ons is als jullie dat onder elkaar regelen.
Ja.
Want dan hoeven wij ons niet de vingers aan te branden aan alle risico's. Op een gegeven moment kunnen jullie wel allemaal zeggen, oké, ik vind het niet erg voor mijn e-mailadres bekend is, dan gaan Brigitte het jullie doorsturen. Maar
Ja.
het makkelijkste is gewoon,
Gewoon even.
laat ons erbij. Het is echt heel moeilijk voor organisaties tegenwoordig om dat netjes te doen.
Bizar.
Maar dat weet je vast wel.
Dat is bizar. Ja.
Als het goed is, heb je hem.
Nee, want ik ben offline.
Nee, maar je hebt hem wel. Ik moet je opleiden.
Ik had een vraag. Die lessen extra, zeg maar, in IJmuiden. Voor de kamer, lijkt me nog altijd wel zinnig. Voor het totaal.
Ja.
Die ga ik dan niks mee.
Ja, dat is heel mooi. Nee, maar het is zo dat op dit moment heb ik er volgens mij 15. Dus we kunnen er 12 hebben, dus dat betekent dat ik een keer een groep van 7 en een groep van 8 net een iets dat wordt niet gedaan. Dat is niet anders.
Dat wordt niet duur.
Dat wordt niet moeilijk. Kijk, met 12 is de volle prijs gedeeld door 12. En nu is de volle prijs gedeeld door 7. Of de dubbele prijs gedeeld door 15. Ja.
Oké, dan denk ik er nog even over na.
Maar ik zit met hetzelfde, ik ga er ook niks mee doen. Dat lijkt me wel gaaf.
Het is hartstikke leuk.
Ook
Zo'n grote simulator, dus het is hartstikke leuk.
Hartstikke inzichtelijk.
Hè, dus het prijsverschil, nou ja, het is nu, heb ik hem op 230, dat is op een volle klas gebaseerd, dan wordt het misschien 320 euro of zo.
Ja, ja.
Je moet het even optellen en delen. Maar we ook communicated met je.
Ja.
Nee, ik heb van hun ook de officiële offerte.
Nee, ik heb wel naar
Dus,
Ja. Maar ik kom met name omdat die de...
Bakkie doen.
die ruimte, ja, die moet ik gewoon voor die uur.
Ja, dat zou heerlijk zijn.
Neem ik deze mee?
Oh ja, ja, ja. Je maskertje. Je moet je maskertje op, Roelof, als je naar buiten gaat.
Ja,
Ja, dat zit nog niet in het systeem. Hè? Dat heb ik ook niet moeten weten.
Ik ben al wel zo verder dat ik naar de supermarkt ga. Dat kan mee.
Weet je dat?
Maar dan kan je hem zelf dragen.
Koffie is contant hier.
koffie is contant nog steeds, ja. Never change the running system, dat gewoon. Oh, Pauline is terug in de kantine. Pauline is terug in de kantine. Capture terminal, ingebouwde microfoon. Doe maar wat, doe eens even kijken. Zo, ja. Dit moet lukken, hè?
Sound. All in the computer, I think.
Hallo Marijke.
Ja, dag Ben.
Hey, ik hoor je, maar ik zie je niet.
Oh, je bent verbonden van gisteren.
Nog ergens wat aanschakelen. Zie je mij wel?
Ja.
Oké, dan hebben we die vast goed. Speakers zoals iets achter zetten. Heb jij een balkje in je beeld met dat cameraatje of niet?
Ja.
Dan zet je hem een keer uit en weer aan. Ja, dus.
Goed zo. En dan moet ik ons ook nog hebben.
Zal maar fullscreen gooien. Nou moet je ons nog hebben, wil je?
Ja?
Nou moet je ons nog hebben.
Ja, ik ben er al aan. Ja, ik heb jullie.
Oké, nou.
Ik heb jullie, maar ik wil mezelf ook nog weer even zien. Ik zie mezelf als een heel klein in het hoekje.
Ik zie jou nog helemaal niet. Ik zie alleen coming soon. Ja, kijk, hallo dan.
Nee, ik wil mezelf wat groot maken. Dat is helemaal.
En nou wordt hij ineens onscherp, je camera.
Ja, hij gaat pas scherp worden als ik er weer in beeld sta.
Oh, oké. Autofoon. Ja. Ja, top. Levensecht, Marijke.
Maar ik heb enig idee, Ben, hoe ik mijn scherm groot. Ik heb 2 schermen.
Ja, ik ook.
Die andere.
Oh, nu heb je de camera gestoten.
Ja, dat is zo.
Oh ja.
Die andere kant.
Ja, zo is het goed. Oh ja, ik heb ook... Als jij in die puntjes klikt, die puntjes van meer acties. Dan moet je eerst volledig scherm afsluiten en dan kun je die andere volgens mij groter maken door te dubbelklikken. Moet ik even proberen hoor. Nee. Nee, ik kan mezelf ook niet groter maken joh.
Zie jij jezelf klein?
Ja, ik heb mezelf rechtsonder in de hoek heel klein. Maar dat schakel ik uit door op vol scherm over te schakelen. Maar jij hoeft jezelf toch niet te zien? Als wij je maar zien.
Ja, of ik zet de camera even aan en uit.
Levensgevaarlijk.
Nou ja, zie je mij nog steeds?
Ik zie nog steeds op dit bord coming soon. Hij staat nou iets te ver naar links ook, de camera. Ja, zo ziet het goed.
Ik wil mezelf zien.
Ja, zij wil zichzelf zien, maar dat lukt er nog niet. Maar we zien er goed. Dus,
Niet te veel willen, hè?
de klas komt binnen druppelen, maar
Ik doe je van man.
oh, ze is weg.
Hi. Willen jullie naar binnen? Of even wat?
Nee, ik wil er weer.
Oh, dat mag hoor.
Ja, mag.
Ben je er nog?
Ja.
Ja, ik ben er nog.
Oké.
Hoe werkt het?
Afrol blokken.
tuin maar wel een beetje veel.
Ik zou jou
Zijn jullie ook? Nee, nou, oké. Ja, inderdaad, een beetje eigenlijk.
Je zei net Friesland.
Je hoeft niet zo goed te lezen op zo'n dag.
Oh, hé. Lekker. Mooi.
Ja. Ja,
Waarbij er was meer
ja, dat waar. Ja, dat is het industrieterrein. Ja, dat is de korte overgang. Precies.
Ja, maar ik heb je ook gezien vorig jaar met de examens. Toen hebben we geholpen met de examens.
En jullie zijn een soort club die kwast die afmaken.
Ja, dat kwam wel. Een beetje lager.
Oké.
We zien jou helemaal niet.
Ja.
Nou ja, het is een minder goed beeld dan gisteren.
Wat is dit?
Ja, dit is online les, mensen.
Dat moet toch omgekeerd zijn?
Onze kinderen.
Marijke zal zelf een verklaring geven hoe en wat.
First question.
Now we get it.
Can you hear me?
Ja.
Yes?
Yes,
Or no?
yeah.
Nou, zij kan ons niet zien.
Can you see us?
Yes, she can through the webcam.
Ah, alright.
It's not that good. Okay, so it's a little while before I am in your classroom. Well, this is going to be an awkward year. It's the first time in 20 years I have to do my class without you physically present, and that feels kind of horrible. But there was, to me, actually not a real other option. Because I am now in Germany on a shipyard where I have been restoring Peking, probably you've heard of it. And that's almost finished. There are a few tiny little things to do. But we are going to start on a new restriction, on a new big sailing ship. So I actually had to stay here because when I come to Holland, I didn't have any option to come back. So then I have to be in quarantine and corona tests and the whole lot. So there was actually no option to do this every weekend. So we are going to try to do it like this. I hope so very much that you are comfortable.
Yes.
Yeah.
Yeah, okay, that's good. That's good. And I'm comfortable example too. I'm in my office, my own office, and I can show you. I see myself very, very small in the corner of the screen, but I can show you not only what we've made up here, but for instance, here. You can see here. This is the cell plan of Peking and some photos. But a few weeks ago, this office was full with all the drawings. So it's much quieter now, and I have a kind of blackboard or whiteboard to tell you all about stability, because that's what we are going to do. And I hope you still remember something of stability. Do you?
Yes, ma'am. Of course. Of course. Never forget it.
Of course, best just a little bit, a tiny bit, or etc. Because this is what we're going to do the next, I think, 9 times 2 hours. And it's going to be, well, I can't say if it's totally, but it's going to be different than the Kleine Zelvaart. Because what we're going to do now, Kleine Zelvaart was actually a kind of introduction to. What we're going to do now is the full, what's a nice word for it, I think, the full Monty. We're going to do the full Monty. You are going to do the full stability program they do in every nautical school in the world. And this full stability program, that comprises, let's start actually with the first and the second class. And we are going to do today Kleine Zelvaart. Today, when it's about 1750 or so, we have done the complete program of the Kleine Zelvaart. So then you can see that we are going to speed up. Next week, third lesson, third class. Can you see this properly?
Yes.
Yeah.
Yeah.
Yeah. Should you see this properly?
Yes.
Yeah.
Yeah? Third class is going to be a bit more spectacular. Because I think Kleine Zelvaart was kind of quiet. Most of you did very good. I think the 9th and the 10th and or the 8th, the 7th, but we did, anyway, it was sufficient. So that was maybe quite easy. But in third class, we are going to do something more dynamic. And this is dynamic stability. What we've done in Kleine Zelvaart was all static stability. It's a ship in the water, see what happens, and that's about it. But in the world, in our world of sailing, stuff is not definitely not static. So a ship is moving, it's spreading energy, it takes energy in, and this is all to do with stability. So we have to look at the dynamic part of stability to understand how a ship sails, how she behaves. So we start soon, next week. And then things are going to get rough. Things are going to get, because when you end up in a severe storm, a huge storm, and in a huge storm there are waves, and your ship is rolling, and then in these cases, and storm I mean with what's a storm? In your opinion, what's a storm? I can hear you. What's a storm?
Anything over 4.7?
8. Yeah. 30 knots and above.
4.7 is a storm. I think there are 4.7 is actually nice sailing, isn't it? You reach down a bit and it's nice sailing. So I would say a storm, a nice storm in stability ways, is 12, 13 up. So, and that's a good storm.
Paradigm shift.
Yeah.
Paradigm shift.
Paradigm shift, yeah.
That's when it's better to stay at the bar. Pretty much.
Sorry? A severe storm is a severe storm plus a rolling in huge waves. This is the fourth class we are going to do, and then we take a little break. We take a little break. The fifth class is yeah, that's a bit over maybe, but we have in this program of stability have to look into a little bit of container stuff, because actually I hope that you in some future, and I hope it's the near future, you are the new captains and crew of the next generation of sailing cargo ship. So then it's rather okay that you have some kind of knowledge on containers, because you probably are going to ship containers with a sailing ship. But we introduce then the fifth class, trim. We have at this very moment we only look at transfer stability. Okay, your ship heels with a little bit of wind, or something rolls over, or passengers blow over, and that's transfer stability. But the ship also has a longitudinal stability, like this. So, and this longitudinal stability, we do not work with this in the sense of stability itself, and what is the ship going to do forward and aft, but I call this trim, because you have a difference in a longitudinal sense between the draft fore and the draft aft. And we are going to start working on calculating trim, and it is important. Why would trim be important in a ship?
To be able to steer her correctly.
Vanwege?
To steer the ship correctly.
Steering?
Yeah, steering the ship. And I think in the sailing ship, it's very, very important for where the lateral center of resistance is, because of your balance in sailing ships. It might be important when you have to pass a bar. Then you trim your ship a little bit and then you pass the bar. Propeller racing, pitching, of course, pitching. In Dutch, I don't know how many Dutch are in the class, but in Dutch it's called, just big your ship comes out of the water and gets in. So this longitudinal stability with trim is very important, so we make another class, full and only on trim calculations. And we're going to go through the reader a little bit afterwards, when you will see that these formulas are a bit, they look a bit difficult. But I hope I can explain to you that they aren't, and that they are just there to be useful. The seventh class is maybe even more strange, but we're going to look into grain.
What's great?
And grain is not, it's not only a load of grain where you make bread from, but it's actually every load you have on board your ship that can shift while you are rolling. And that, of course, has a huge influence on the stability of your ship. And that's grain stability. So you can use this in any kind of coal or sacks of stuff or everything. That's the grain stability. And then we have a last one. And I must tell you, this last one, and then it's nearly Christmas or so, I think that's quite an important one. And that's the number 8. And that's damage stability. I don't know if you've ever any problem regarding damage stability, but sure, in sailing ships nowadays, it's a difficult subject, because a lot of our sailing ships, our older sailing ships, do not have bulkheads, or they have bulkheads in wrong places. Because the damage stability is that when one compartment of your ship gets damaged and it floods, then the rest of the ship has to save you. And that's why nowadays on almost all ships they have to have damage stability calculations. And that's why we are going to look into it, because I had the experience that when a ship owner and we had to do damage stability calculations, the ship has to stay afloat. That it's much more easy if someone knows a little bit about this subject, and you can find solutions to comply to the rules and regulations of damage stability. And I think there are only a few ships that are nowadays sailing without this compliance. But almost any, if you want to sail charter in day trips, for instance, with a lot more passengers than 36, you have to have this damage stability calculation. Of course, there's a ninth. The last lecture or anything. So that's yours, and we're going to do questions, an exam, or whatever. Here, and I had to print them at the very spot. When it's okay, you have 4 readers for stability. Is that correct? 4 readers.
3. Yeah. Oh, we also have one for the exam. Appendix
This
for
is the
the
first. Stability of ships, that's theory only. And the subject I mentioned, actually you can find them in that. So chapter 1, 2, 3, 4, 5, 6 is actually 1, 2, 3, 4, 5, 6. Because the first 2 I mentioned here are cancelled. Do you have it? Do you have this? Don't you?
Yeah.
Yeah, okay. Perfect. Then there is another one. Important one, and that's this one. Exercise book. Exercise book. And this exercise book, in all these last 20 years, was used in a way that from every class there are exercises in this book. So there must be 8 or 9 chapters. So when we do the first 2, you would be able to make the exercises of lesson 1 and 2. Formerly, we could make them during the week, and then the next week, following the theory lessons, like next week following this lesson, we could at Friday make the exercises in the classroom. But now, I have decided otherwise, and I hope you agree with me, because you are a small group. You are with 15, I believe. You are with 15.
And 3 online, so 18.
Okay. And I think it's better that in this case, communicating, I see now that we need to have a better computer out there, and we need to have a better sound system. But I want to make this work more individually. So I give you the exercises, and for instance, at Wednesday, I send you an email to ask how are you doing with your exercises. And you can at any time send them to me, and I will look at them personally. And I can stay in contact. We can contact also maybe with Skype or with a study group or whatever. And then we make it on a more personal level. We are going to check these exercises. I think it works better than when we do it in our classroom, because the contact is not. It's okay, but not perfect. I hope you agree, and that makes that you on Friday will have a little bit less hours to spend in school, and maybe in Corona, with this Corona stuff, that's also a little bit better, that you do not stay too long in an environment where there are too many people. Normally I have, of course, my own email address, but to do this, you can use this one. AZS.nl. Exercises are actually the most important, I think, because your exam, somewhere, I think, beginning of January, your exam is going to be exercises only. Probably 3 of them, or maybe 4. And there is one advantage of stability in a style part, is you have your reader, you have your exercises, but to do exercises you need data. And there you have this. When it's okay, you have this reader.
We don't really know what exercise.
It's probably in English, but it's an appendix for stability grote zeilvaart. And it's got all kinds of data on a specific ship. And this specific ship is the poor little ship, because this ship is called, always a little bit wrong, this ship is called, and I use the left one. The Samsung period, it's a multi-purpose ship, and I should actually say it was a multi-purpose ship, because she was put on the beach in Bangladesh 1 year ago, and she was taken apart, and that's a pity, because this ship was built in the 80s, and she still lasted long, and she lasted with many generations of students in multiple schools, because they all used the Samsung carrier. But this reader, where you find all kinds of data, I'm going to explain later, but you may take this reader into your exam. And that's nice, because some years ago something happened. We had an exam, people came in, and suddenly the director of the school mentioned, oh shit, I forgot to print the readers, because everyone got a fresh, empty reader to do your exams. An empty appendix I mean. And the only option we had at that day is to say, please, students, you have your reader with you, you have your appendix of the Samsung carrier with you, and take it into your exam. And from that day on, we said, take your own appendix, stability, grote zeilvaart into the exam, and you may write everything you want into it. Every note you need to make exercises, every formula, every whatever. And the first year, but mind you, the first year I said, please take your own appendix with you. I think almost 80% of the class failed the exam. They were, however, able to do the re-exam, so eventually most of them passed. But that was scary. I just said, take your own, and then they all failed, and I know why. Because you might think, well, I just write it all down. I put it here, everything. And I make my exam. It's going to be easy. But unfortunately, during the exam, making these 3 exercises, you will not have the time to study. There is no time to study. So this is what you write in here. What you write in here is only a reminder here and there. And some people have a real library of notes in it and stuff, and you please do so if it's helpful. But mind you, you do not have the time to check it all. You just have to do the exercises. I think, I'm not quite sure, but I think there's also, do you also have this one?
No.
No. No.
No?
No, ma'am. Still?
No, Swan, not reader in your pile of readers.
No.
If not, I'm going to make sure you get one. Because I think some exercises in the exercise book, the last ones, the bottom ones, they are on the sailing ship somewhere. This is obviously also a very old sailing ship because it's sold to Italy. It's not a Dutch sailing ship anymore. And what I plan to do is, what I would have liked to do, is to incorporate also a WASP into our classroom. And WASP is a wind-assisted ship propulsion. That's a ship that is wind-assisted. And I thought, well, what could be a WASP? There are, at this very moment, many WASPs on the drawing board, but no WASP is yet sailing, and none of the WASPs wanted to give the data to us to make exercises with. So I was kind of desperate, and I thought, haven't I worked on a WASP for the last 3 years? Peking, the four-masted part Peking, where I worked on the last 3 years, is actually a WASP. It's a wind-assisted ship. Actually, it's a WASP. It's a wind-only ship. And what I plan to do is, because Jeanette Peking is a little bit behind us here, that during our course, I'm going to make up some questions on the first, or actually the last WASP in the world, Peking. And I'm just going to give it to you, so you can play around with a WASP ship. So in that way, you are very much prepared to our beautiful, bright future with assisted ships. All readers. These are the subjects. This is the email address. You can email me anytime, day or night, doesn't matter. And we're going to communicate much more through Skype and stuff on an individual basis, and I think that's way better than just making some exercises here on the whiteboard. But we have to carry on. We have to, or I have to, actually, do I have a split have to check what you still know of the kleine zeilvaart. One question, and I hope I can hear the answer. Where
You can't repeat the question. Say it again.
You're freezing up at a crucial moment.
Are you there?
There's a connection there.
The connection is dropping out.
There he comes.
We're,
We have missed a question.
Yesterday, sharp as a knife, hè, die image.
yeah.
Ja.
We missed
Stop
it.
ze nu dan. Hij
We
stopt
missed
ze
the
nu dan.
question.
Ja. Marijke, 1 second. You have to pump up the internet
1
again.
second?
Yeah, you come in very broken now and then, and the class missed the question. Am I correct?
Yes.
Yeah.
Yeah.
Or with this question.
That will be filmed.
You will still there.
The one announced with this is the most important question.
Can you speed up your internet? Shall I wait? Shall we take a break or whatever?
No, no.
Niet te verstaan.
No, it's okay now.
It's okay.
Niet te verstaan.
Niet te verstaan?
Yeah, we have a question.
Yeah. What was the
Could you repeat the question, please?
Nou, dat wordt examen tegen jullie, denk ik.
Ik stuur je de link en als je het ook zelf een keer gaat zien.
The question. Where does that start? Where does it all start? It starts with barking.
Yeah.
It starts here. And during the course we are going to talk about a lot of laws and compliances with whatever stuff. But there is one law of nature we can't do without.
Archimedes laws.
Love Archimedes.
Yes, that guy. And how was this Archimedes law? How does it sound? What happens?
Displacement equal inert volume times water density. But
Well, this answer comes in with some breaks, but I gather it's okay.
it's going to be
Because I
difficult.
agree, when a ship floats, it has an immersed volume. And this immersed volume, this is so important, this immersed volume of the ship is subject to an upward thrust that is equal to the weight of that immersed volume. So you put something in the water, it has a certain weight, it floats. So there is a force down, and there is an equal force, an upward thrust. And this upward thrust, that's the most important one. That's what Archimedes found out. And this upward thrust is here. That's the one. That upward thrust is here. And how could we calculate this upward thrust?
Williams, like.
Moving water against soort gewicht.
The density of the water.
Something like it. It has to do with the sort of the density of the water, because this upward thrust, well, that volume times
Short liquid.
the density of the water is, and how do we call this? Do you remember?
Displacement.
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 Yes, the displacement of the ship. But then the triangle, actually the D, the Greek D, this is the displacement of a ship and then of the ship is the same as the volume times the density of the water. So a should at a certain draft. Suppose this is the draft. This is the draft. Suppose this ship, this is this ship is at a certain draft T in the water. When is the weight of the ship the largest? When the ship is in seawater or the ship is in freshwater?
The weight is fresh water.
It's the same. The draft is different, but the weight's the same.
Fresh?
The weight is.
What's
weight
the-
is-
what's the question?
The
What's-
same draft.
At the same
Oh, it's the same draft.
Then the
Fresh water.
Oh,
Right, the same.
it's
the weight is bigger in
salt
sea.
water, it's a lot heavier.
Yeah. And let's check. Let's check, for instance, take your appendix of the Samsung area. Somewhere on page, somewhere in the middle. Somewhere in the middle. I think it's hard to say, but it's page 19 or something. Like this.
What's the page? What do you have? What's the heading? What's the title?
Hydrostatic
What's the?
What is the title of that page?
The title of that page is Hydrostatic Particulars. So it's somewhere in the middle of the
Yep.
appendix, not in the reader, but in the appendix. Hydrostatic Particulars. Well,
Hydrostatic particulars. Page 18, or 13.
I think this is,
13.
here is the same page,
18.
18. And it looks like this.
13, right?
What is
Yes.
Yep. I think so.
the relationship between immersed volume, displacement, and density and draft can all be found of any ship in the world that is commercially sailing, that is, and that has these data, in the table for hydrostatic particulars. And here you see the one of the Samsung carrier. And in the first column, this column, you have the draft. And here we start at a draft of 2.80, and it goes on all the way till, let me see, you can find it fast, which goes all the way to 8.98. 8.98. And you have two columns here. Do you see this green lighted line? At a draft of 3.10, there are two displacements given. At the same draft, there are two displacements given. So my question to you is this, which one is the freshwater and which one is the sea?
First one is
The delta 2 and the delta 1.
The delta 2 is in seawater, the delta 1 is in freshwater.
Sounds like it.
yes.
The delta 2 is in
Salt water.
seawater and the delta 1 is in freshwater. It must be, because there is a certain volume of at this certain draft, 3 meter 10, and the first column is the volume times 1025, which is the density of the seawater, and the second column, the delta 1, is the column in freshwater. And it's actually the volume times 1. So my next question is, they make this for this ship, because this ship most of the time either sails in seawater, most of the time sails in seawater, and sometimes is in a freshwater harbor. But this freshwater number is important, that's there. Because what does this freshwater number say? At 3.10 we have 3036.1 ton displacement. But it is also, at this graph, 3036.1 cubic meters of immersed volume. And because this one is 336 times 1 is 3036. So this is a very important number, and every ship, maybe your own ship, has this hydrostatic table. For every draft, a displacement, either freshwater or seawater. Well, very, very nice. Who remembers this specific point? How did we call this in the Kleine Zeilvaart?
Okay.
Okay. Kilo.
Okay.
Okay. But there were more points very important in stability. What's the next one?
G.
G. Where shall I draw G? G is here.
Halfway up.
G. What was G?
Central gravity.
Center of gravity. So in the center of gravity is this other force. We have this one, the upper thrust, and in the center of gravity is actually the same one, but then pointing fully downwards. This smells awful. I think I'm going to be stunned after a few hours of teaching. This force points down is equal to this force, and a force is in stability in the world of stability actually always turns. So no newtons or kilos or whatever stuff, but actually tons. So ton displacement, and ton gravity force. Do you remember how you calculated this center of gravity? Because it moved. I don't know how many of you did the Dutch class and how many of you did the English Kleine Zeilvaart class, because then there's some difference in this word. But this is a very important figure. This the distance between K and G, and how did we calculate this?
You can use the table of moments.
Yes, because this lively G is liable to change all the time, and it changes with where you put weights or where you take out weights. So it changes And that has an enormous effect on your stability. If it changes downwards, so it goes down, this should be better for your stability. You are much more stable. When it comes up, then you are much less stable. So this distance between K and G is of utmost importance, and you could calculate this with the table of moments. Whoa. And I'm going to warn you, we're going to make a lot of table of moments. I'm so sorry. But the nice thing is of making a lot of table of moments is that you really get the hang of it. So maybe at this point in time you think, whoa, the table of moments, what? But in a few weeks you will just, they just come out easy. A table of moments. Because when you load the ship, when you put weight on, and that's with cargo ships the case, but it's with sailing ships also, when you get your passengers on board and their luggage and stuff, you have to make a table of moments to find the center of gravity. And the easiest way to make a table of moments is like this. You probably did it in the Kleine Zaalvaart too, but it always started with there were certain columns.
Wait.
Draws.
Sure. Actually, what you want to put in the first column is what you're talking about. So, is it tank you are filling? Is it a load you put on board? What load? Is it a container? Is it whatever? But you always start. So this is the data on the stuff you put on board. But you always start. Your first line in your table of moments is always your ship. It could be an empty ship. You start loading. It could be your ship. You are already on board. So you are on board your ship. And the first thing is weight. So if you have your ship and you want to start a table of moments, where can you find this one?
Yes. What is the question?
What's the question?
Can you repeat the question?
When you find the weight.
If you start a table of moments, you have your first line. In this column is what you're going to put in or you're going to take out. This column is the weight of the stuff you put on board before you take out. But you have to start with the ship. And the starting point is your ship in the water at a certain draft. You can see if it's given, or you just check it. You see it on the scale. And here, this one you can find in this book. So, for instance, the draft is 3 meter 80. And the ship is, that's always the next question, in what water does the ship float? The ship is in seawater. The ship starts loading, Samsung carrier, for instance, starts loading at 3 meter 80 in salt water. What should I put, which number should I put here?
3878.
Ruikamer, and 7, 8. Always your first level. And so check draft, check density, and you have your displacement to start your table of moments. And then the next is your load. That has a certain weight. Then you fill up tanks. That has a certain weight. What can we do more to end it? Crew plus the luggage that has a certain weight. And then you have a new total weight of the ship. Displacement. What was in the third column? What's in the third column?
kg. The distance kg.
Yeah. The kg in meters. If this is the weight in tons, the kg is in meters. Well, yeah, problem.
Should be given by constructor. We can find it in a document.
It's in the stability book as well.
I think it should be given. This is not, this figure is not something you will find in any list. The only figure you could find in a list is, because that's existing, there are existing figures of the empty ship ready to go for sea. Empty ship ready for sea means that she's like us, but without any clothes. Totally naked. That's your empty weight ready for whatever you plan to do. And in this case, ships have this too. And that's a few pages back from where we were at the hydrostatic particulars. And that's this page. Here it starts with the general arrangement and stuff of the ship. And here we have some general details of the Samsung period. And somewhere here, you can find it here. I've highlighted it. Empty ship ready for sea. Of course, such an empty ship has a draft, a mean draft, a draft forward, a draft aft. That's what we're going to check later on. But it also has, to our surprise, of course, not to our surprise, maybe, a kg, 5.84. So should it be and is it actually ready for sea? And you could take this kg, then this would be 5.84. Only these two do not match that word. Because the weight of the 150 has also here on given here 2,953 tons. Every load has a certain height. Every load has a certain height. Every tank has a certain height somewhere here. The crew is floating around. what's the big trick of a table of moments, you cannot just add all these heights, because then you are, with a lot of stuff on board, you are almost up to the moon. So I need a fourth column.
Moment.
I need four. I need a fourth column. And that's the column of the moment. And what's the moment? What's the moment in our case, in our table of moments?
Weight times kg.
Wait.
Weight times kg. So weight times kg is, so we do in every column this. And a moment here, a moment here, a moment here, and a moment there. And the nice thing about moments is you may add them all together. So in this column, you will finally have the sum of moments. And now the table of moments reveals itself, because this one, the K that we desperately need, is in the same way, displacement times the one that's the end situation, is sum of moments. So our very much needed kg, our kg is
Sum of moments, heel doen.
the sum of moments over I hope you remember doing this in the Cannes Southbound, and they were tiny, tiny little table of moments. But you can imagine that if you are making a new build, and you probably have a dream to make a new ship, but if you do so, if you do so, you make a new ship, you have a lines plan, you have the shape of the ship. And when you know the shape of the ship, you would make a table, a hydrostatic particular table. So at every draft you can recalculate the weight of the ship. That's nice. But if you launch the ship, and you probably remember my personal nightmares, and I can do this better than in class, because I can just disappear. And you have your new ship. You have your particular table. You knew at every draft what the weight was going to be. And you pre-calculate it with the table of moments, the total weight of the ship, match the one with the other, and it should be okay. But sometimes, in the internet, or on YouTube, or whatever, or in my personal nightmare, it's like this. She is launched, and she's launched, and she... Oh, shit! What does it mean when it happens? What does it
Overload
mean?
it.
What mistake did I make?
They overloaded, so the displacement of the ship was above the maximum volume she can handle.
Yeah, that's kind of shit, of course. Yeah. This one, much bigger, larger, than the ship could give you as inverse volume. So she's sick. And I personally, I haven't covered this, but I'm a little rock. there was a ship owner, and he came to me and he said, I had a beautiful, beautiful little boat. Such a beautiful, beautiful little boat. But I launched her, and she did not disappear, but she was like this, just a tiny little bit above the water. And when they stepped in, water poured in, the ship was gone. And he came to me and I said, I want to go. And I asked him, why? And he told me, well, they had this steel plate, it was a boat of only 6 meters or so. They had this steel plate of 16 millimeters lying around. And I thought, this is going to be a nice bottom for this little boat. So somewhere in this table of moments, there was a huge weight for the ship's bottom. And probably they didn't check, they didn't make a table of moments. But the end, this one was much bigger than this one. And that was a problem. I made the second design, and I can tell you, when she was launched, I was in it, and I thought maybe I need to go to the toilet or something, and I don't have to see it. But it went well. She had a nice, because what's left here is an important figure. What left here is the freeboard, and she had plenty of freeboard, so this was perfectly okay. We are going to heal the ship. I think it's about time, and see what happens then. But before this, we're going to take a small break. Is it? I will for you.
You are freezing, Marike.
We lost you, Marike.
The connection is breaking up again, Marike.
Marike, we lost you.
You have excellent timing, Cosmo.
Je hebt niks van gereisd.
Ja, ik zit mee te luisteren.
Oh.
We doen geen breaks meer, Marijke. Want anders lopen ze... Zie je dan.
She's taking a break.
The thing with the breaks is that at the moment...
Have to relax, maybe.
Yeah, do some yoga exercises.
Hey, that's not allowed in the
Oh, okay.
We can sing.
So?
Then I will try to restart Teams, Marijke, in between this little 5-minute break. Is that okay with you?
Okay.
Could you call me anew in 2 or 3 minutes? Maybe this helps with the image and the connection.
Ja, dat kan nog wel.
I have twice the same. Yeah, it's exactly the same.
Exercise.
Maybe exams
Helemaal goed.
Ja, is
Doe dan niet die andere potjes.
Het is gewoon besmeurd. Ja.
Yeah, but it's for every
Kijk, daar moet je een nieuwe
Ja, dat is eigenlijk hetzelfde hoor. Ik ben ook heel erg mee. En dus
Ja, doe maar.
This one, oh yeah, they just put an extra
ik heb het idee dat deze wel moeilijker wordt.
cost now.
Ik ben er even. Lijken?
I get very
Ik zie geen beeld.
Dat is mijn voormalige student.
Wat belangrijk is, stellingen living
Dus
station.
dat zijn altijd een opleiding van dat ging over een ijzer.
Ik heb nu een taal.
We hebben elkaar even weten.
Ik zie nog niet.
Ja,
We have found it.
helemaal voor.
Nog geen beeld.
Moet er niet om
Nou, niet heel veel, maar...
Osman, is het handig om een raampje op een kiertje te zetten?
Kun je gewoon doen, maar als je denkt,
Ja.
nou, als je hem helemaal open zet, wordt het snel koud.
Ja.
Maar als je hem een beetje te diep zet, en als je iets achtersteekt, we hebben een elektriek bijvoorbeeld, dan haalt hij hem op een kiertje. Dat is misschien wel een idee, dan haal ik wel even een wichtje.
Ja.
Een doosje kleintjes.
Een doosje. Oh, zit erin. Heeft mij eigenlijk toch niet nodig.
Dank u.
Maar we zitten nog op 0 hoor.
Wat zeg je?
We zitten nog op 0.
We hebben nog 0 ppm CO2. Mensen. Ook weer gadgets hier op. Ja.
Maar nu staat de deur ook open.
Well, let's see if Marijke can activate her camera.
Oh, weet het niet.
Could you activate your camera, Marijke?
Staat hier maar heel hard nodig.
Ja, ik weet het misschien wel.
Prachtig, just
Ik heb er fit van. Nee, die is heel stabiel. Heel prettig zitten.
Je zal wel stil zijn in huis.
Ik kan je niet horen, hè? I have no picture. No, no Yes, teacher, we know.
Good morning, teacher.
Zo
MJ, teacher MJ.
Nou, ik zal met Maarten en Remco en nog een vriend van mij zou ik die zijn artje gaan. Nee.
Moet je anders mij uitnodigen of pas je stond die wel open? Moet jij anders mij uitnodigen of stond die gewoon open?
More life tries to stand altijd.
Een heel MK nou.
Dus wij gaan je wel op
Zo, maar dat is schaatsen. Maar jij hebt het geschaatst. Ja, dat is een paar keer zo. Jij hebt hem ook geschaatst. Veel gevonden. Als hij toch gezegd? Ja, nee, ik hoop dat ik dat is wel een man dat ik overlaten.
Hoor je mij nog? Oké, ik zit er.
Ieder jaar.
Maar jij hebt een camera die achter mij aan zit.
En je moest hem draaien, dus die avond.
Van camera veranderen.
En hier elkaar praten.
Ja, natuurlijk. Uiteraard. Het valkjes.
Maar dat was wel één goed, ja.
Dus maar één keer te doen.
Hij zit zo vol, maar
Ja? Ik hang op. Tot zo.
Nou, die gasten gaan
ja, je gaat daar helemaal uit kunt zetten, vlakbij
in september. En die sprak ik hem eind juli. Toen had hij nog een blessure van het jaar ervoor, maar hij ging er wel niet van.
Ik ben er weer.
Maar weet je wel zelf, wat is het één vandaag?
Ik zie, nee, nog steeds NBA.
Een van de steeds.
Leuk hoor.
Moet je mij over je bent gaan. Krijg je dan nog
als de water zit, dan doen ze dat ding
krijg je dan een waterbalk in beeld. Met de optie. En als je zit dan op de camera uitschakelen.
Je hebt wel lopen van
Ergens in de stad. Links bij mij.
Ik zei dat aan de eerste
Nou, deactiveren als je deactiveren dan weer. En als je op die drie puntjes
En dan weet je ook dat het schuldig is.
meer acties.
Dan doe je filter en dan een blok. Ik kan me voorstellen met biodiesel dat
Ja, ik kwam met de video inschakelen, maar die heb ik ook al allebei geprobeerd. Die staat aan. Dat maakt geen verschil, die aan of uitzending. Maar ga eens naar apparaat instellingen. Die drie puntjes. Wat heb je dan voor een camera?
Dat is wel een beetje bij de versie. Dat is het beste.
Dat is de goede.
Heel veel masker, anders niet.
En hoeft hij een ziel bij. Nou, gewoon op maar.
Die zijn
Dat is Excel-school was. Oh.
Toen is die later geplaatst aan
Hoe heb je dat dan vanochtend gedaan?
Heeft u van de vloers af
En
kom je bij de andere
als je de teams even afsluit, dan heb je wat gezegd.
Ik heb mij anders kunnen zijn. Nee, ben geen anders. Bijna anders. Perfect. Veel heen.
Grote water zijn het sloten, maar dan wordt het
Ja, ja.
Eigenlijk
We hebben er één keer gehad, hadden we voor de winter vaak.
een huisje van de
Dus ik kwam er aanvaren. Smoot in elkaar.
Ja, wat loopt dan?
En als jij nog meer acties aan de instellingen neerleest, daar is ook weer een andere kamer. Nou, als je op een puntje zit, dan krijg je meer acties.
Altijd natuurlijk het huis
Dan apparaatinstellingen.
Hij is ontzettend leuk. Ja, heel plezier.
Bij mij ziet dat er zo uit.
Ja, afgelopen
En dan hier staat apparaatinstellingen.
is wel nergens naartoe.
En dan krijg je dit. Nee, dan ben je beneden naar camera's. En dan een andere camera.
Zo heel hard boei.
Oh ja.
Toen was het
En die staat geselecteerd.
we zaten we zaterdag nog op.
En
Maar zondags ging het niet waar.
die staat ook aan.
Uitgevers 8 en 9. Zo te geven.
Die ik nu laat zien. Waar mijn muis op staat.
Ja, zeker. Daar ben ik
En die is al een paar keer aan en uit gezet.
Daar ben ik minder gesnoerd.
Aan het begin is het missen.
Ik kan hier inkomen studio uitschakelen.
Aan de binnenkant.
Ja, maar aan de kant van de zee.
Maar dat verandert niks. En dan kan ik hier inschakelen en dat verandert.
Ja, maar dan ontstond er even. Bij Den Ossen.
Maar ook nog dingen dus natuurlijk, daar moet je dan staan.
En dan voel je nu op de toren.
Ja, nou, zo zien we het komt een moeite.
Hé, je wordt je zwart. Ja, daar ben je. Ik weet niet wat je gedaan hebt, maar ik ben er weer.
Hij heeft in Indonesië voor een hele open tap in.
Wat heb je nou gedaan?
Het staat daar. Het is allemaal af.
Ja,
we laten er een klein stukje zitten.
Jij bent hartstikke hier. Ik vind wat.
je moet zeggen, dit is wel leuk.
Oh, je ziet ons niet meer.
Het is allemaal oud.
Regelingen kan je al bijna niet
Ja,
zeggen.
dan
Nee, ze
moeten we maar op. Wat hebben we naam gehad?
En het is comfortabel ook.
Ik zie jou super.
Dat is een heel groot succes.
Ja, die groot wordt.
Je wordt ja.
Ja, dat is 3 keer zo scherp als net, hè?
Oké.
2 weken denk ik.
Nou, voilà.
Stalen vol.
Nee, de deksel.
Wat?
6 verschillende knopen.
Dat was nu een hoop dat hij kan gaan bewegen.
58 euro per motor. 3 weken tijd.
De grote cruise doen ze eigenlijk niet zo weer.
Maar het was goed voor de motor.
Dan staan we wel tegen de zee.
Still there?
Wat leuk.
Ik ben nog steeds.
Ik zie jouw huis over de bel staan.
Aanklikken.
Oh, je hebt zelf gevraagd.
En dan weer terugvaren, in de wagenpark de hand brengen, de volgende kraan.
Ja, nou ben je weg.
Nou, ik heb me helemaal alleen maar het rest
Ja, ik kan me voorstellen.
En toen kwam die baas zitten en we zeggen elkaar. En dan zoek maar iemand op.
Als jullie zijn.
Ja,
Nee,
maar dat
Hij
is
stond eraan staan.
ik ben er niet. Ik heb jezelf weggeklikt, ik kom niet meer zo.
Het lijkt me ook wel. Wat voor motor zit er? Ik bedoel, zeker nog zo'n duwbootje.
Dan moet je weer van de wal.
ongeveer als wij dus we weten precies wat we doen.
Meneer teacher. Oh ja, het wordt zwart. Ja, daar ben je weer.
Ja, en via
Ik bedoel, ja, heel goed. Super. Ja, super.
Hij doet het weer.
Hartstikke.
Okay, guys, and with a better image than this morning, our apologies. There was something with the internet settings which we made a little bit better. So at least the image should be better. Okay, good luck.
Kom maar, Marijke.
Succes, Marijke.
Oh, het is Marijke. What is that behind you?
Yeah, but the trouble is now that now I can see myself very clearly, and you probably can see me. But now I can't see you. Somewhere in the corner of the screen, I see a very, very tiny. I can't see it anymore, but I can hear you much better than before.
Very good.
Great.
Say something.
Yeah.
Hey. Okay, we're going to continue. Till what time do we have class? Because it is all being mixed up. So, till what time do we have?
10 to 1.
12.
Yeah.
12:50.
12:50.
Half an hour.
12:50.
Yeah.
Oh, okay. 12:50. Well, let's start. Did we agree? Do we agree on G?
Yes.
Yeah.
Yes.
Yeah.
Nice.
Yes.
Yeah.
Do we agree on the table of moments?
Yes.
Yes.
Okay. There is something else which we should agree on, and because we have G, but now we have this immersed volume. And in this immersed volume, we have defined between G and the force down is in G forever, ever. But this upward thrust, you will see that my ships are not they are not going to be more handsome than this. Center line K. Wait a minute. No, okay. K G. This one is defined. But not the upper thrust. Where in this case the direction is upward. But where does it look for? Where does this one look for? It looks up and it thinks, well, got you.
The meta center and
The buoyancy center.
Yeah?
COB, center of buoyancy.
Yeah, the center of buoyancy. And this is an easy one. Where is the center of buoyancy?
in the middle.
Middle of the immersed volume.
The center of the immersed volume.
2/3 of kg.
So in this case, it's just
It's a square.
with a little bit of luck, the center of buoyancy, I think we use this one, it's B for it. The center of buoyancy is there. So this upper thrust always looks for the center of buoyancy. And if it's a square shape like this, it's quite easy. It's approximately half the thrust. If it's a triangular shape, it's more downward or more upward?
More upward.
More upward, then it's more upward. This is the center of buoyancy, this is the center of gravity. Force down, force up. and you're still in the home. So this is the easy part of it. But something changes. Can I get rid of this? Can I put it down? I'm going to put it on the I need some space.
Wordt goed gedaan.
There he goes. Oh, well. I promised the yards that they would reuse this for their own education. I don't know if they want to do it. There we go. And almost reuse the drawing. Okay. B. G. Situation in the harbor. There she goes. You're going to leave harbor and the ship is going to heal a little bit. Oh yeah. There. Center line. Okay. G. There's G.
Moving to the right.
This is AG. Where is G in our next case? Where's G?
Still in the same place.
On the center line, KG stays the same. There.
Here.
Yeah, somewhere. Yeah.
Okay, stays the same. So this is KG. Next question. Where is B?
Shifting to the right side.
Yeah, on the right side. Because now our whole displacement, the shape of the ship, the emerged volume, it was like this. This is what it was. And now this part is at the lee side. So the whole shape of the ship is changed. So this center of buoyancy, which is the center of the inverse volume, has no other option than go with the flow. Well, and now it's up to you. Is this going to be a stable situation or is it not? So where is B? Here. Those two. Let's say it's here. B, phi. Phi is the angle of heel. Are we stable or are we always, without any exception. In the kleine zeilvaart, you were allowed to do it differently. So sometimes the upper thrust went like this, or out of the window, or maybe downwards, whatever. It's always up. But it goes like this. Always. Here's the upper thrust. And always through the center of buoyancy. And the sky is the wind. This one goes up, and this one goes down. What did you see happening? What did you see happen?
Corrects yourself.
A good thing happened or a bad thing happened?
Good thing.
Good. Very good.
In other words, do we have a a positive or a negative stability moment?
A positive one.
Positief. Weet je nog?
It must be this. Because these two forces are making a difference now. They are not in one line anymore, where it's easy, it's in the harbor, nothing happens. But as soon as the ship heels, this position, central point, shifts leeward, but also this force shifts leeward. And now they are not in one line anymore, so it's like a wheel turning, and your ship has a stability moment, upwards for sure in this case. And the stability moment, what we've seen in the table of moments, is always a force on one side and a distance on the other. And in our stability moment, what is the force? What's the force? What's the force that makes your ship return to its original position, upright in the harbor, in this case? What's the force?
Thrust.
Count the other, then the displacement in tons. But what's the distance? And the distance, like in the table of moments, the distance between k and some position of a load, here is the difference between the force down and the force up. So this distance. And this distance makes a moment. And you find this distance here from G, and you must remember from the kleine Zermatt, from G perpendicular to the line of the upward thrust to, what was this number? How did we call this?
L. I think.
We?
L.
L or Z?
Z.
I think it was Z, wasn't it?
Z. Yeah.
Z. Yeah, we are not at the end of our program, but obviously when they had to find some figure for this distance between these four forces, they thought they were tired, like we are maybe, and they said, well, we call this GZ. So our stability moment is displacement times the difference between G and Z, or the distance, and that's in meters. So always a moment, like in the table of moments, the stability moment is ton times meters or ton meters. kg was here. But you see, if you look very closely, I don't know if it's possible, if you look very closely, you see that the upward thrust goes up, goes up, goes up, goes up. Here we find the distance. Obviously, this distance is very, very important for a ship. It goes up, it goes up, it goes up, and here it has an intersection. Here it has an intersection, this upward thrust line, with the center line of the ship. How did we call this one? Do you remember? How did we call this one?
Meta center.
Oh, its M is nice, but what's the full word? What's the full word of this? Yeah?
It was said already.
Yeah, but I think that each time I talk, she don't hear me. Maybe I'm talking.
Shout it harder.
Shout it. Meta center. No, it's just me.
Meta center.
Mega center!
That's because I'm on the blind spot.
Yeah.
You cannot see
Dit
me.
is een beetje stift. Dit is het Röntgencenter. Betalia Center. And the funny thing is, this point M, so if you have this point M, it's in at that level, but that's coincidence. You can define this point to the line, the baseline of the ship, to the point K. And if you do it to K, then you have this distance Km. And that's so bloody important, this distance Km, because if should, let me say this in another way, this metacenter has always is for eternally married to this point B. Because this is always, the M and the B are always on the same line. Should it be impossible for a ship to get this center of buoyancy out because of the shape of the ship, then it comes a little bit more inward, and then your center is lower, but then also your GZ is less. Should it be a very triangular ship or whatever, and your center of buoyancy comes here, then in the upward line your metacenter will be here. And I think then you have a problem. But what I actually wanted to say now is that your metacenter, married to center of buoyancy, it would be an LBTD marriage. If you know this on forehand, because you have your lines plan, then maybe this point is also prescribed. And healing the ship at a certain displacement could this point M, this Km, be pre-calculated, and then we do not have to worry about this position, because this position is a difficult one. It's in 3 dimensions. It's hard to find. But what we like to have is this point, because if we know this point, we can easily do leadership. And again, I have something here. It should be here. Yeah. Center line. K. Graph. G. KG. And at this graph, when she was upright, a certain measure for M. K. M. And this one is obvious, eh? The force always goes straight down. But from M, we know, if we know this one, we only have to get the swing in your arm, and you know for sure that the upper thrust goes like this, and somewhere on this line is your center of buoyancy. And then you have your G set at a certain angle of heel. So this M, we want to know this M. And this M can be found, even if you are in hurry, if you do not plan any voyage, but in your hydrostatic particulars should be found the position for M, or otherwise this K M. And now I hope, if you still have your Samsung book, and somewhere in the hydrostatic particulars, at page, the page where we were before,
18.
Page 18, the first one, we were used to this table. We were getting used to this table. We have the draft. we have the displacement in seawater. We have the displacement in freshwater. And at the last column, you suddenly see something which is now familiar, from now on familiar, and that's Km. So for every draft of the ship and every circumstances, you can find the value for Km. And that's this one. And you, I think I told you this in the kleine zeilvaart, that Km is something you cannot change. It comes with the ship and it comes with the hydrostatic particulates. So, yeah, you can't help it. You have a certain value of Km. However, Kg is your responsibility. Because you may, this one is hard to manipulate, but this one is manipulative. So you can either, it can get higher or it can get lower. And if you look closely, you will see that it is a game between these two, your responsibility and the ship's responsibility. And the distance between the two is this distance is GM. G M, and I remember in the kleine zeilvaart, I think this GM that took us hours before we were in GM, because the first question you even were to ask your neighbor is what's your displacement? Well, there are not that many answers, so you can get hit or you get a proper answer, and the displacement is 30 tons or so. But asking your neighbor friend the GM of the ship, in other words, the distance between the center of gravity and the meta center, between the center of gravity and the center, really determines the stability of the ship. Because should this distance be larger, then the distance, the stability arm is much bigger. Should this be less, then the stability arm is much less. So this value of GM is of the utmost importance. And here you see it again. Everywhere and always. This one is from the draft of your ship. That's actually the end line for the table of moments, because you get a certain end displacement, and with this end displacement you find a certain draft. It's a game. It's quite a game. You find in this same table your center of gravity. With the new draft, you will find a Km in your list. You can find it for any ship. It's most of the time it's the last column of your hydrostatic particulates. And then you can find this value of GM. If your value of GM is positive, what you could do is GM, if you want to calculate it, you could just do Km minus this part minus this, Kg. And you have something in meters. If this value is positive, in other words, Km, your meta center, is above your center of gravity, then you may say the ship is stable. The ship is stable. Should this by accident be 0, so your Km from your list, from your hydrostatic particulates, and your Kg are equal. They are in the same point. So this is 0. What will happen?
And differential.
I have never experienced it. I challenge you to try, because I think the ship the ship cannot make a stability arm. This is not present anymore. So the ship will roll, even though it's upside down, I don't know, but strange. Should this one, and then the center be below the center of gravity. So your kg is larger than your km. Gm is negative. What will happen then?
We'll turn it upside down.
Upside.
It will turn upside down.
Yeah. I think there's only one option in this case. Because if your upper thrust is here, on this side of your G, then your weight is down, your upper thrust is up. But then the wheel turns. So here it's positive, they come close, it's 0, then nobody knows. And then when the center of points is not able to get more to the lee side, and then your ship actually has the wheel turned, and this will be your moment. And then you will, yoing. Excellent, yeah. And then you have a problem. That's obvious. So never ever try to get in this situation. But maybe you remember from Kleine Zeilvaart that because this figure had a distance between the center of gravity and the center is so important, they had kind of minimum to it, a minimum value, and it makes a difference what kind of ship you use. But there were for sailing ships and for cargo ships minimum values. Do you remember?
Yes.
50 centimeter. 0.5?
1.5.
45?
0.5. 50 centimeters.
0.5.
0.5. 0.5. GM. But, 0.5. So what kind of ships was this?
Cargo ships.
Sailing
Container ships.
This means that should I draw it and I take a rule or something, that the minimum distance of any sailing ship, huge, small, tiny, that this distance between this one and this one is approximately like this, 50 centimeters, no more. Do you remember? So this is sail. But Samsung Carrier is not a sailing ship, so she has other minimum values. What was this for cargo ships?
0.7.
0.7.
Yeah. 0.5.
1.7.
1.5.
0.7.
1 point.
Yes.
15. So, is this 15? Is this 15? Ja. 7, 8, 9, 10, 11, 12, 13, 14. No, 15. For cargo ships, the minimum value of GM is 0.15. It's about crazy. This is also for passenger ships. For every ship that carries no sail, the minimum distance between this G and M is 15 centimeters. And actually, that's what you're looking at here. But I have drawn the tiny little boat around it. But in the biggest freighter, the biggest container ship in the world, it has the center of gravity. And then at the center and around this, you have this huge ship. And it makes its stability moment through this distance making a GZ at a certain angle of heel and of course this figure. And that makes a hell of a difference. If you have a container ship with an immense displacement, then your stability moment is also enormous. And if you have then your GZ is it should be positive, of course, it should have a minimum value, but is of minor importance. But if you have a tiny little ship, a light ship which is big, for instance, then this one is smaller, and then you should rely on the GZ a little bit more. And actually, that's what you have on sailing ships. We add surface, we add wind area through our sails, and doing so, we need relatively more GM to count for this one, and then both, of course, to have a sufficient stability moment to counteract all this force 13, or normal wind force 5 to 6, or even 7. GM. Okay, is this
Slowly coming back.
is this somewhere? Does this bubble up in your memory?
Yes.
Yes. If so, because wait a minute, I'm back in a moment. It's 12:50. It's 12:50, and we have to be strict on time because of your breaks are very well regulated. So I suggest you take a break, and me too. And I see you again at 15 and a little bit.
15:30.
15:30.
No,
Because
50.
at 15:30,
50.
we're going to try to make a graph. This one. So we are going through life with big steps, stability steps. Well, I wish you a nice break, and I'll see you back in
15. Hours.
3 hours or so.
3 hours, correct. Onder de regels.
Nee, is dat
Ja. Ja?
2,9.
Dat hebben we nog niet
Dat is ook nog lager dan wat daar staat. Dus dat is ook dus dit kan niet zelfs rood zijn. Het zou rood zijn.
Nee, maar als je naar 2953 gaat,
In zo'n
nee, naar Zuidwater, dan klopt die wel.
ja, maar is het al in Zoutwater?
Dit is toch? Ja, maar dit is voor Zoutwater. Wat ze worden normaal gesproken voor Zoutwater.
Ik zou zeggen dat het is gewoon aan de haak gericht. Dat is hetzelfde als verplaatsing. Ik denk dat ze dit op basis van Zoutwater of zo.
Ja, daarom.
Nou, het zal wel.
Oh! Nou, als je het ziet, dan weet je het wel.
Dat we straks zijn.
Ik weet niet,
zal
wel.
wel.
Staat er eigenlijk wat er bedoeld wordt. Nou, dat was
Oh ja, nee, ik ben een klont thuis. Ik weet dat
Dit is aanvaring.
Nee, Bert, je bent mijn hoofdvraag. Bert heeft daar niets mee te maken, maar ik zal even kijken.
Wat is er niet mee?
Ja.
Hier. Dan houden de mensen allemaal op de hals. Wacht
Il est trop mignon.
Ja, het is...
Ja, die waren daar.
Nee, eerst een
Ga jij eerst? Ja.
Heb je ook wisselgeld genomen?
Nee. Nou, dus ik kan even vragen.
Machines? Ja, rekenmachine. Ja.
What are you doing the rest of the day? Stay around here?
I'm living there, so I will probably come on the library and myself study.
Yeah.
Outside of home, I don't have a computer and instruction.
Okay, you have a time then to study as well.
Yeah.
Good.
And like I'm living with two persons which are in the first year.
That's
So
an
that one I can
apartment.
help. No, I'm an apartment. It's about 10 minutes walk from here.
Very nice.
Al aflezen. Ja, en als het dan leeg gaat lopen, dan gaan we toch niet gaan over de problemen bij.
Nou, ik heb onze huisarts van vorig jaar.
Ja?
Die zat in het guesthouse. En daar had ik de rest van gedaan. Die heeft 1 kamer. En de vrouw die zei, ja, het is goed. Dus daarom was, voor de beginbedrijf was ik nog niet zo... Het is een vrij kleine boot.
Ja.
Tenminste, met corona niet zoveel zin. Misschien later. Ik heb eigenlijk gewoon een kamertje.
En zij heeft een kamer.
Nee, ze zei, ze had nog 1 of 1 kamer, maar dat zit haar zo. Dus ik kan nog vragen of die ook nog eens beschikbaar is. Dat ga ik doen.
Weet je ook niet meer leren.
Maar de Pelican, dat is schip.
In Londen, over de vaart is dat anders. Dat ligt nog onduur. Hij heeft geen dochter. Hè?
Heeft ze er niet van.
Zijn dochter met thuis uitgegaan.
Dat is meer gevraagd.
Ik niet, hè?
Thanks for sharing your
Ik heb geen nieuws. Deze kan programmeren, dan eerlijk zeggen, dat weet ik niet. Ik weet dat mijn eigen besloten dat deze daar meer of minder valsheid zit. Dus ik denk dat het probleem met choices.
Maar ik weet niet hoe groot het is.
Om eerlijk te
Ja,
zijn.
dan ga ik wel even kijken.
Dus je kunt het gewoon proberen met een beetje
Oriënteren.
Vanaf volgende week is het letterlijk...
Die vrijdagavond van
Ja, zoiets. Ja, mijn zoon heeft ook zoiets volgens mij. Die moet ik gewoon gebruiken.
Ik vraag een enkel even of deze gezien. Ja.
Ja, het gaat ook precies met een
I think that the standard
Nou, dat doen ze op een andere manier.
Het is zo leuk, er zit zo'n goed kwestie bij. Ja,
Ik wist het wel. Als ze nog even gaan.
Dat staat dus mee.
Ja. Ja, dat is, ja, ik kan hem ook langs brengen. Ik ben wel heel erg blij dat ik zie je uit dat ik niet kon
Totaal 5. Ik kan het
Hey, dankjewel. Super. Ja, helemaal goed. Merci. Okay, good afternoon everybody. I think we're going to start. 13:40 according to my schedule, which is very confusing, but I can't blame nobody with that because I made it myself. So how is everybody doing? How did the first day until now with all the technical problems?
But at the end it went okay.
Yeah, there was we had the wrong internet. Which was really bad. The first thing I saw when I came here was that it was really low, and now we have cabled internet, which is much more reliable. Did Marijke also talk with you about changes in the schedule?
No.
Not yet.
Well, maybe she did, but we didn't hear it.
Well, she made a proposition, maybe I can show later, to skip some Friday sessions. And because normally she would have 2 lessons and 1 lesson of calculation where she would help you, etc. She said something? Okay. So it means that some last blocks on Fridays and 1 last block on the Saturday will be skipped. I'm going to show the proposal later, but I have to make 1 change in order to avoid you having 1 block nothing and then again a block of marine engineering. So I'm going to try to trade that around so that you can go home and not have to stay here.
It's only one day.
Oh yeah, on the 14th of November.
It's only one day.
On November the 14th.
Yeah, November the 14th, yeah. And then she skipped some other lessons and she will contact you directly through mail and then you can send her the assignments that you have to make, your homework. Oh, I'm not envying you guys. So that is going okay. I will show the plan later and I will work on that this week, of course. Are there any questions organization-wise? Any questions about the way we handle Corona? Any clarities? Anything that I should elaborate on?
Yeah, when you want to log in at home, the link is then on the website in the school.
Well, this is the principle. The principle is like this. I'm going to give you the login of today, of course, because maybe then you have a chance to translate what Marijke was saying in the first hour. But the cameras and the online environment, in principle, and this is something I discussed with the board and the teachers, is for those who cannot come to the school. Yeah, so it's a necessity. We have, at the moment, hi guys, people in Germany watching the lessons, they cannot come here, or if they come here, then they have to go in quarantine for 10 days. You know the drill, and very difficult. But until now, they're pretty positive about the online possibilities that we offer, because we want to give the chance to everybody to see what is going on here.
When will Marijke comes here live again?
In person.
Yes?
Not.
Oh,
No.
totally.
No, no, not until either rules are being, or vaccine is ready or stuff like that. Because she has her work in Germany. And then it would mean if she comes here, she cannot work in Germany. Well, maybe in desking, isolation. Yeah, that's the difficulty now. And this came pretty unexpected, hence the technical stress that we had to arrange for everything. So my apologies, but we are doing our best. And give us feedback if you see that at any detail we can do better. I would appreciate that highly.
And I have another question.
Yeah.
Because I'm a little bit more curious, because I know no one, so I'm more curious, when did everyone the KZV? How many years ago? Because for me it's 10 years ago. I was
you
here.
work with 10 years ago?
Yes.
Oh, okay, okay.
So it's nice to a little bit know each other.
Okay, that's a very good plan actually. And as Colrex, you still know it from 10 years ago?
Yes,
of course. So here and there I can snap something away. But shall we do that a little bit more to the...
Okay.
Yeah, that would be a very good idea. Have just a very short introduction. I am, and that also makes it possible to form study groups, live or online. That would be a good idea. Okay, we're going to do that today. Okay. Can I go to Colrex? Everybody okay with that? The link?
Hoe je op internet...
The link is basically for those who are at home. So today I'm going to give you the link, but it's going to be at the end of the day. I will send it by email, or, no, better, I will put it online. If you go to our website, and then go to KZV, and then go to login.
The new password.
We change every 35 years, I told you.
Oh, yeah.
So it's in about 32 years you're going to have a new password. The password is student. Maybe I should change it.
Student 01.
Welcome 1, 2, 3. Yeah. If you, then you will see the YouTube link. You click on it, YouTube will open, and you will have the possibility to watch the whole day anew. So I'm not going to do this every week, because the basic principle is only for those that cannot attend here. Yeah? If there's anything during the coming months that will change my or our minds, I will let you know. Okay. I should not forget this, but that should be okay. College regulations. Everybody remember what that is about? The Colrex BVA.
Voorschriften voor wie wel of geen voorrang.
Yeah, that's, when do you have right of way? We do not speak of right of way in the Colrex, but this is a repetition of what you already had during the Kleine Zijlvaart. So why are we repeating the Colrex? Because this is one of the few subjects that you should have in your head ready to use and not look up in the book when the situation occurs. Red, coming closer, somebody angry shouting at the bridge. Okay, yeah? So dit paraatje is, we say in Dutch. So in order to motivate you, I'm going to give a little test to start with. But first, the setup. I used to have 4 lessons of Colrex, but I recognize that most of you already had the knowledge still from Kleine Zijlvaart, when it is not too long ago. So I reduced it to 3, and the second lesson is divided in 2 hours. Doesn't really matter, but in the schedule you will see that on November 21st and December 11th, one second, December 12th, I'm going to share 1 hour of Colrex with another subject.
December 19.
Yeah, December 19th. Yeah, so no 12th. And December 19th is a whole block of collision regulation. You also see that in the schedule on November 21st, I have combined Colrex with a so-called tutor Q&A. What I'm going to do then is give explanation about what you can achieve with your diploma and what you need to do more in order to become captain all 7 vessels. Yeah? So this is the setup. I'm going to do this little knowledge test. No pressure, no grade. I'm going to tell something about the exam demands, what is important, what is less important, and I'm going to discuss parts A and C. This presentation I'm going to put online the coming week. Yeah, so you do not need to make notes, but you can if you want to, but it's going to be on the internet. Parts A and C. Part A is the general overview of the Colrex, and C is the lights of the vessels. Lesson 2, divided in 2 blocks of 1 hour. I'm going to discuss part B, which is behavior of vessels inside of each other, but also during reduced visibility. We're going to shortly discuss use of the radar, but very shortly, because you will have Bernd explaining you much more into detail all you need to know about radar use. Lesson 3, we are going to work on a cases of the shipping transport board, board of shipping transport, the court cases concerning vessels that ran into each other. And then we're going to wrap it up, and if I have some time left, we are going to do some repetition.
Is it correct that we do not have a handout?
No, you only have the book. You still have the book from last year.
Yeah, it's the same.
It's the same, yeah. So the rules can be found free online. For those who did KZV in the last 9 years, you also have a book, which is a book is big like this, and 1/10 is the actual rules, and 9/10 is explanation. Yeah. If you do not have the book, please go to Brigitte today, and she will sell it to you. Yeah. But you do not really need it, because you can just get it from an online source. Although that is in royal language, yeah, so not very readable. Looking at this picture, what do we see? Anybody, any idea? Where to begin?
Ferry.
A ferry. Do we have special lights for ferries in the Colrex?
Fishing boat.
It's a fishing vessel?
Shooting nets.
Hey, that's very good. How can you see? First of all, what kind of fishing vessel?
Trawler.
The trawler. Because
Green over white.
green over white,
2 lights with shooting nets.
2 white lights, shooting nets.
Seen from port side.
Seen from port side. Very good.
So.
Hey, it's still there. Excellent.
Wow.
Zo helemaal.
Nee, van mij wordt het vorige plaatje.
Ik ga gewoon met jou laten gaan. Dit gaat de groene kant er net uitstaan.
Aan deze kant. This side. Deze kant. Ja, klopt. And also depicts on which side she has her nets out. Shooting her nets out. These 2 lights you will not find in part C of the Colrex. It's in an annex. Annex 2, all the way in the back, which is not really part of the Colrex, but part of the trawler agreement of the North Atlantic, but it's been adapted by the Colrex. Is she, oh, wait. Is he under engine? Is he making speed?
Yeah. Underway, not making way.
Underway, not making way? Anybody else? What does this mean? Yeah, she's sailing. Yes, she's making speed. Where is her masthead light?
It's green and white.
Yes, but if she's larger than 50 meters, she does have a masthead light. To make things complicated. Okay, another one. What shape is this dagmerk? Fishing vessel. Two cones, the points are tipping each other, and we call it diabolo. It means it's a fishing vessel. Here we have a sailing vessel. There is risk of collision. Which ship needs to give way? Sailing vessel, yeah? Very good. Again, we have avoided some future collisions. Yeah? First captain I sailed with was absolutely convinced that fishing vessels had to go away for sailing vessels. Yeah, not so nice.
Yeah, and most of the fishing vessels are also assuming that even if they are not fishing, they have right of way.
Yes, because they have their fishing lights on, so they have right of way.
Yeah, even if they're not fishing.
Even if they're not fishing. Yeah, Alexander von Humboldt made the mistake to proceed her course a couple of years ago. So this ship needs to give way. How should she give way? What does the Colrec say about the way the ship should give way?
Timely and clearly.
Timely, clearly.
And not passing.
Niet naar het schip toe.
Yeah, a good seamanship. Good seamanship. But which side should she go? Does the Colrec say anything about that?
Both sides and
Starboard.
She can. The skipper can decide by him or herself. It's not prescribed. Yeah. Need to give way, and the only rule that counts is that she has to do it timely. What was the other word? Clearly, and making use of good seamanship. Yeah.
Yeah, I get always wondering with a fishing vessel, you cannot really assume all length in the trail behind or the net. So, but we are not supposed to really pass in front of them. So sometimes we are just completely stuck there, and every choice is really bad.
Yes, it is true. The only thing that really helps is give a wide berth. Which I know, because and I was in the same situation where I wanted to pass behind a trawler, and then she stopped. And then I adjusted, I went back to my old course, and then she took up speed again. They're not looking at other traffic. They see a fish and they think, hey, you're mine. And then they take the fish and they continue, or something like that. So it's very unpredictable behavior. Yeah? But if you have a good fisherman, she will, during the night, she will switch off her stern light and her side lights when she stopped in the water. And she will keep up her fish lights. I'm calling them fish lights, but it's, I think, the only word you can use. Green over white or red over white. She will kill her side lights the moment she is dead in the water, so to speak. And as soon as she starts picking speed up again, then she has to put on these lights. So that you know what you should do. What would be the best maneuver for the sailing vessel in this situation?
The question is, what's the direction? It's his main direction. Waar wil hij naartoe?
Yeah, okay, depending on where she wants to end up. Okay, yeah, the safest way would be to pass at the stern, because...
Maar met een grote hektor loop je dan nog 100 meter net achter.
Yeah, you have to give a wide berth. Don't come too close. With a trawler, there's one thing for sure, the net is always in the back. With a non-trawler, it's not so sure. But we're coming to that later. Here we have two sailing vessels. A large one, the Sadov, and my Yachty, the Unsinkable 3. Who needs to give way in this situation where there is risk of collision?
Sadov.
Loefwijkvallei? Yeah. Loof, windward. Windward. I'm trying to find the English expression. Windward gives way to leeward. Yeah, because they are both on the same bow, same tack. Then the one closest to the wind has to give way. even if there is a difference in size between the two sailing vessels, it really doesn't matter.
The one closest to the wind has the right
Yeah.
way.
No, they have to give way.
Loefwijverlei.
Boewijverlei.
Vaak op scherp, hè?
Leefvaart scherp.
Leefvaart scherp.
Wat is nou
Ja, dus die heeft recht van de weg. Ja. Dus A mag wijken.
Closer
Ja,
to the wind.
A moet wijken. A has to give way.
So B is closer to the wind.
Uh,
You said the opposite.
no, it doesn't really matter if you the angle you have with the wind. That is not important. It is the position towards the source of the wind. If the one ship that is closer to the source of the wind, that has to give way.
It's the windward yacht.
Yeah. True, really.
The one which is going to take the wind away of the other one.
Yeah, basically, yeah, it comes to that. Yeah, the angle of the sail is not important here, but you're not completely wrong here because in racing, it's slightly different.
No,
But I'm no expert there.
We're not talking about racing.
It's right.
Okay, now the situation changes. Now this sail-off is sailing in a traffic separation scheme. Who needs to give way in this situation?
Same thing.
Same, I hear.
Which one is in?
B.
Which one?
See, the sail-off is in the traffic separation scheme,
But it's sailing.
and yeah, it's
It's
sailing.
not on the motor.
It's not under engine.
Even if it's under engine.
B moet wijken dan.
Which
Ja,
one
dat
is
is zal van varen.
It's immaterial whether sail of A is if you sail or under engine.
Not completely.
Nee.
When it's in
Niet als je in de VS zit.
Not completely.
Niet als je in de
So-
VS zit.
In this situation, A still has to give way.
Absolutely.
Yeah? On B rests the duty not to hamper a motor-driven vessel, a power-driven vessel, which is making use of the traffic lane.
Exactly.
And this is not a power-driven vessel.
No.
So this whole line can basically be forgotten. But B should not proceed like this. And then she will cross in a wrong angle. And the check will automatically be sent to the home address. Yeah? What kind of ship is A?
Oh, goed.
A towing vessel. Yeah? What can we tell about this towing vessel? Do we know anything about the size of the towing vessel? 50 meters plus? Do we know anything about the size of the tow itself?
Less than 100 meters.
Less than 200 meters. Yeah, very good. Lights in front and one in the back. Mind you, these lights are not visible all around. They're masthead lights. It's one of these strange things in the lights with Colrex. Okay, so this is a towing vessel. She by herself is larger than 50 meters, or 50 meters itself. She has a tow of less than 200 meters. There is risk of collision with power-driven vessel B. Which ship gives way? A. B.
E.
C.
C. No. A has to give way. The fact that she is a towing vessel does not give her any special status. Not at all. But when she has a tow which is not very maneuverable,
Exactly.
she will carry an extra set of lights, vessel restricted by its ability to maneuver. Yeah? But in this situation, she's just a normal, basically normal power-driven vessel, and the rules say that a power-driven vessel that sees another vessel coming from starboard, she has to give way. Is it also prescribed how she needs to give way? Except for those we mentioned before, timely
I
and...
think she cannot turn to port. Is the general rule.
In the practice that is how it will be, but it's described differently. She has to avoid passing in front of the vessel. Yeah? So in this case it is not wise to turn to port or to speed up, if at all possible. Yeah?
the basic thing that she will do, well in this case I would recommend slowing down a little bit or go to starboard. If you ever come into this situation, yeah, being a captain of this vessel, my recommendation would be to stay to already outside the 2 to 4 mile situation, already do something in order to have this ship be on her way properly. Yeah, that's good seamanship. But you have to do it outside of this 2 to 4 mile region, because if you're inside, you have to keep to the rules. And the rules say if one ship has to give way, the other one has to keep its speed and course.
Cosmo,
Yes.
if A would not have the maneuverability, what light would she carry?
She would have an extra red, white, red.
Red and white.
Yes. Yeah. Vessel restricted by its ability to maneuver. Yeah. And you see this a lot. So many of these vessels will have either the shapes or the lights in order to have other ships give way for them. Some general theoretical questions. How should a vessel proceed when following a narrow channel?
Starboard side.
Stick to starboard side. Yeah. Is it also the case when you are in a traffic separation scheme? No. But you have to avoid coming too close to the separation between the two traffic lanes. Yeah. Which type of vessels do not need to join in a TSS, a traffic separation scheme?
Not restricted by fishing.
A fishing vessel? What did you say?
Not restricted by depth.
No, they have to. And usually they use a specific area called deep water routes.
Sailing vessel and
Sailing vessel, fishing vessel, and
Ocean
pleasure craft is something you should think about, but it's officially called power-driven vessels under 20 meters. But keep in mind that's recreational vessels. They have no business in a traffic separation scheme, but you can make use of it. It's not that they forbid it.
If you go to another harbor, another harbor which is close by, then you don't have to go all the way to the traffic scheme and then
True.
back out again.
Yeah, there is one extra category, and that is the vessel that goes from one port to another port which is very nearby. She doesn't have to sail out 40 miles, go in the traffic separation for 5 miles and then go out again. Because if you go from Amsterdam to Scheveningen or something, then it's a little bit different. Or from Scheveningen to Rotterdam, even better. Then you don't need to go all the way in the traffic separation scheme. Yeah? On these vessels, also the duty of the non-hampering, which I mentioned before, niet belemmeren, is also applied to them, but we will discuss that later. Which horn signal do we give when we approach a fairway obscured by an obstruction?
One non-blast.
Ja, one non-blast. And if there's somebody at the other side, dan één lange stoot op te horen, als er een obstructie, ja, het aandacht zijn, obstructie naderen, waarachter zich verkeer kan bevinden, dat jou misschien ziet.
Something else. Is
Yeah.
it possible to open the window again?
Yes, it's very warm indeed.
Yes. Maybe a second.
If it gets too cold, all of you will give a shout. Yeah, do. Then you close it. Excellent. Okay, and if there's another vessel behind this obstruction, she will reply with one non-blast as well. It's a lot of words. At night you spot a red light and directly underneath a white light. At the right place lower you see a second white light. This could be
Fishing ship there. A non-trawler and anchor with an outline gear.
everybody agree? You have to deduce, huh? So a pilot is white over red. A non-trawler is red over white. We're coming close. A vessel not under command. Two reds. Yeah. So it has to be this one basically. And place lower, you see a second white light. That is what a non-trawler uses to point out the direction of her outlying gear when it's longer than 150 meters. Yeah? Sounds familiar? Very nice. A radar exercise. So I keep them simple with the Colrex. With that you will be, when you follow the course of radar, this is going to be peanuts. My speed is 8 knots. I am sailing. My own ship is at the center of the screen and the range is 12 miles. And we have to follow the rules of Rule 19. What is the basic rule of Rule 19? That is true. That's basic for everything. What is something you should keep in mind when dealing with a question or in practice with Rule 19? Everybody give way.
That's reduced visibility.
Reduced visibility? Yeah, Rule 19, I should have mentioned that, is reduced visibility. Yeah. Reduced visibility. In reduced visibility, if there is collision, everybody gives way. So no more talk about he's coming from starboard and I'm a sailing vessel or I'm a fishing vessel. Yeah? Everybody gives way. Because we can't see each other. I don't know if you're a fishing vessel. Yeah, they come very close and then they have a horn signal, which still doesn't give me that much information because it's for a wide range of ships. So, in this case, I am sailing, reduced visibility, and dots start appearing on my screen. It doesn't look like this, of course, every time it's like 5 minutes in between. What is my duty when a echo appears on my screen?
It's to monitor, to track it.
To plot it. Yeah, I have to plot it. Yeah? And if I see that the ship or object, there's no collision danger, what duty lies upon me when there is no risk of collision? Keep on plotting. Keep your eyes out. Yeah? Might be a fisherman. Okay, when there is a risk of collision, no matter how much the distance is, both parties have to give way. Yeah? But always assume that the other one does not know that rule. Then you're safe. How can I see if there is risk of collision? I will take a ruler, put it over the three, in this case, 3 dots, and where it crosses my line, I can see the distance in which it passes me. So this ship is going in front of me. True? Everybody see this? B, it's going awfully close. And the same for C. I can see that right away. During an exam, when you see that the ship is passing here or here, it's too close for comfort. So we assume that it is a risk of collision situation. So, do you still remember these 2 sets of rules for the different situation? Everything which is in my front, I have to give way, but avoid going to port. Keep that in mind. Everything that is, I don't like this word, but I'm going to use it anyway, athwart. Athwart. Somebody from England told me that. Athwart or aft of the athwart, I have to give way, but I have to avoid turning towards the vessel. So, if you find this question in the exam, and it's always there, usually the last one, first thing you do, you write on your piece of paper these 2 rules. Would be my advice. Because that's the set you're going to live by, and then everything is basically very easy. So, I have to give way to C. What would be my action?
Reduce speed.
Reduce speed is always good. The next echo of C will be here. Something else going a little bit up. Then I can make a new plot when I wait a little bit, and then I will see she will pass in front. If she also reduces speed, well, that's theoretical. Slow speed, low damage. If you bump into each other with 0.1 knots, there is hardly any damage. Okay. With B, what would be my action? Also reduce speed. The next plot of B will come up higher, and she will pass in my front. Would it be possible to also go to starboard in this case?
You're not allowed to do it.
No.
The rules do not say that specifically. Avoid going towards the ship. Avoid going to port.
Okay.
But you can go to starboard. But then you have to explain why.
First reduce speed.
Yeah, reduce speed would be in this case the best option. Yeah.
And Cosmo, on C, could you turn to starboard?
Yes.
Instead of reducing speed?
Yes, you can. But then you would need to explain how you handle B.
Oh, they're all coming at the same time.
Yeah, they're all coming.
Yeah.
Always, huh? But I take a maximum of 14 ships on the radar screen in the exam.
Only 14.
Only 14. Oh,
Yeah,
peanuts.
after you cannot read the screen. After you cannot really reading the screen.
No,
Try it.
because then it gets too much dust on the screen. Yes.
Maar als ik hier naar kijk, ik doe het even, want mijn Engels is niet zo geweldig.
Geen probleem. I hope it's not a problem.
Ik ga 8 knopen ga ik omhoog.
Ja.
Dan gaat B toch in verhouding 8 knopen naar beneden. Dus dan komt hij toch nooit. Hij gaat toch niet met mij mee.
De positie van B ten opzichte van mij is relatief.
Het is een relatieve positie.
Dit is niet een echte koers van B. Nee, B die vaart eigenlijk zo. Maar ik zie hem op mijn scherm als gaande zo.
Ja,
Ja.
Ik snap het.
Je weet hem weer. Dat is, ja.
As you now saying on the exam for I do nothing because they go for the other side.
If you do nothing, then
No,
the red pen is
A goes
patient.
out of the circle and B goes out of the circle.
Oh, well, yes, that would be the case if this one was the first and that one the last. That's, I give them X, Y, Z.
Okay.
Yeah, I give them names. No, I'm not falling for that. Okay, in this case, when there is no other circumstances interfering, then reducing speed would be an excellent solution. Yeah, and do not bother to say, well, if they reduce speed, then blah, 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 I'm going to call them on the VHF. You have already spent a lot of energy with your arm that whole day writing exams. Just say reduce speed, and B and C will pass in front of me. Okay? So, the exam in January. It's the first time in decades that we have a Christmas break. How do you like that? I'm already looking forward now.
You have a Christmas break.
You also, but you have to sort of, the learning will come after Christmas. I think you have to decide for yourself. Of course, there is still the pressure of the exams in January. I understand. Just an in-betweener. The reason we do that is that we want to have a Christmas recess from now on. Basically 1 week. This year it's 2 weeks because both Christmas and New Year's Eve are in the weekend. And I didn't want to call you here on Monday and Tuesday to do exams. I know that a lot of people will not come or have difficulties coming.
But that's why we have to learn now till the end of March. Normally a little bit earlier.
Yes, yeah. Normally we end a little bit earlier, but there is this tendency in the old days, not being too long ago, but it's in history. The normal sailing season would be from halfway March to halfway October. But I've been asking around for the last 8 years, that's dissolving. People are not getting on the ship. Well, some people are, and stay for like 7 months. So they have go to that ship, and then they have a break, and then go to that ship, etc. Okay, all of it will be on the website. Huh? This it will be on the website. This week it will be on the website. Just to show you, I started doing this because in one of my first years as a teacher of Colrex, I had this study group, and the way they were studying Colrex was doing a really inventive, creative game with cards with lights. So with all the lights, they were in perfect score, but the rest was not so good. So just to give you an idea, if you only learn the lights, it's 20 to 25%. Part B, section 3, that's rule 19. So you can score there if you remember this rule, 20 to 25%. It also depicts that if you dedicate one whole day on learning everything about the sound signals, then you have a 0.5 on the exam score. So this is also to sort of give you an instrument to choose, to pick what you want to focus on. Yeah? And for me personally, part B is the most important. Know what to do in a certain situation. Yeah? I will continue. This is the setup of the book. There is an extra, has been added a couple of years ago, F, but everything that is yellow, I'm not going to discuss that with you. It's theoretical, you're never going to use it when you are sailing. So everything else is going to be part of the exam. We concentrate mostly on this part, part B. What do you do in certain situations in encountering another vessel? And today I will do A and C. So the definitions, these are very important. We have basically two kinds of transport on the oceans. One is power driven and the other is driven by wind. Yeah? Of course, this is a very small percentage in relation to power driven. And the power driven we can divide in fishing vessels, towing vessels, not under command, vessel restricted by its ability to maneuver, and vessels constrained by draft. And when I use the sailing vessel, the engine on my sailing vessel, I'm just a normal power-driven vessel. I'm not a sailing vessel anymore. You can call yourself a sailing vessel, but according to the Colrex, you are a power-driven vessel.
Of course, well,
yes?
Not under command is different from being at anchor, right?
Yes. If you're at anchor, if your ship is not under command and you drop anchor, then you're not a ship which is not under command anymore. Yeah. But if the anchor starts dragging,
Anchor is not under command.
my anchor is not under command. Actually, I saved, in my career, I saved 2 ships which were drifting with a very large speed out of the bay. I even went to one with a speedboat. Yeah, there was one guy sleeping on board, and he was racing out of the bay. It was in what's the island in the Caribbean where they had this Montserrat, where they had this volcano eruption, and the holding ground, the anchoring bay is like this. So all the yachts are anchored here, and I'm anchored there. But if your anchor starts dragging as a yacht, and you only brought out like 1.5 or 2 shekels, off you go. And it was force 8 to 9. And then I went with the speedboat there and I woke this guy up, and he came up and went, "Where am I? Why is the sea so choppy?" Yeah, it was no fun because I think you can imagine. Power-driven vessel, basically every normal vessel that uses engine as its main power. I forgot to tell you, of course in the future on all these ships you will find different applications making use of the wind, which is going to be part of your lessons in the second half, wind assisted ship propulsion. How do you like that? We're going to discuss it then. But then there will still be power-driven vessels. In the Colrex we define two kinds of fishing vessels, the ones that are trawling and the ones that are not trawling. What is the difference? We are going to discuss that later. A vessel that is towing doesn't need to be a tug. I could be towing with my little boat, but of course I will not be showing the same lights as a tug, because I do not have them. Vessel not under command is a vessel which has come in a situation which he did not choose to be. Yeah? So, fire or containers dropping off. Can a vessel under command still be underway? Making way?
Yeah.
Yeah, she can.
Drifting.
Drifting, or for example, if there's a fire on board, the captain may decide to sail dead the wind, to go with the wind and to make optimum on deck that there's not too much suction of oxygen into the place where the fire is. This is a vessel which is built, designed, or has chosen to be in a situation where she is does not have that much control over her maneuvering than a normal vessel. We have this vessel who is laying buoys, this vessel which is dredging, and also an aircraft carrier is a vessel restricted in its ability to maneuver when planes are going off or coming down. It doesn't really make a difference because they will shoot you out of the water if you come too close anyway, if they have the American flag.
Then you are restricted.
Then you are restricted from coming too close.
Your
ability
To maneuver.
Yeah. A vessel constrained by its draft, that is not a vessel that is designed to be constrained by its draft, but if a large vessel, a large transport carrier enters a port or an area where it's much shallower, then she will be constrained by her draft. Who decides if she is constrained by her draft?
The captain.
Yeah, captain or the officer of the watch. Yeah? And they will put on the special lighting and the shape.
Yeah, where is the shape?
Yeah, it's 1 meter 20, huh? So you need binoculars to see it in the first you will see it in the fact that she's going very slow. Yeah, these ships are always going very slow because they create squat when they're going too fast, and they will suck themselves to the bottom. And they're usually very large for the sailing area they are in the moment. And in the waters there will be assistance of tugs. Constrained by draft. And the vessels we know very well, sailing vessels. Which of these sailing vessels did the authors of the Codex have in mind in the 70s of the last century when writing these rules? This one. Have to realize that, yes. All the rules concerning sailing ships are better explainable for yourself if you keep in mind that they were written for yachts.
Even Bavaria.
Yes, even Bavaria.
Ik had het niet willen zeggen.
German.
Is this the Bavaria?
Yeah.
It is, huh?
Yeah.
Oh, very sharp. Very sharp. So that explains some of the things that we will encounter in the coming hours, because they do not really make sense for a ship like the Europa or other larger vessels. So, for example, Stad Amsterdam, in practice, is never regarded a sailing vessel, even if she is sailing. Yeah. When she goes into the channel, the authorities know this is a large sailing vessel. She might be sailing, but we do regard her as a large motorized vessel, which also gives her some advantages, but mostly not, because if you go outside of the traffic separation scheme, because you are sailing, if you are on the Stad Amsterdam, they will back into the channel. Yeah. Because it's all written for this. Keep that in mind. We have two definitions of our movement on the water. We are either underway, which means we are not moored to the quay, we are not at anchoring, we are not aground, or we are making way. And making way is that we are developing a certain motion towards the water, not the ground. Yeah? Making way through the water. This is where we use our engine. Doesn't really have to do anything with sailing boats. Why and when is this important? One of the questions before, I said that if a fishing vessel spots a school of fish and wants to shoot out its nets, it will keep on its fishing lights, but it will shut off its side lights and stern light. And then she's underway, and then you can recognize that from a distance. As soon as she starts picking up speed, she will add these lights again, and then she is making way. There are some vessels for which this is important. Okay, we are going to rule 1. Where are the rules applicable and for whom? For all ships at sea, basically. Yeah? For everybody. Rule 1 mentions special rules. For example, in Holland we have the BPR, Binnenvaartpolitiereglement. And what does this rule say about these special rules?
Dat special rules gaan voor vaak
Ja.
de andere rules.
Special rules first, then the call regs. And if the special rules do not give an answer to your specific situation, then you can come to the go to the call regs. If I'm going to a country, to a port, and there is a lock and there is a river, oh, too big for the lock. Panamax. Do the call regs apply here?
Yes.
Yes, they do. Unless they have special rules. Then the special rules apply. And again, if the special rules do not answer the specific situation, then you can go to the call regs.
And Cosmo, what's typical in these situations? Are there special rules for rivers typically?
Yes,
Yeah.
typically yes. Yeah. I wouldn't know of any country that does not have special rules for her inner waters. Maybe you guys know of anything, but there's always something which, and that is always also a rule of the call regs. These special rules have to be, how do you say, close to the call reg rules. So you cannot say from here on you have to move your red side light to the starboard side and your green side light to the port side. No, that's not possible. It is possible, however, that you can deviate slightly from the call reg rules for special vessels. Like, for example, an aircraft carrier. The call regs say that all the masthead lights need to be in the line of keel. And an aircraft carrier, they're outside the line of keel. So then she will either have a special certificate, or there is some legislation which says for Navy vessels, this rule, they can deviate from that rule. And some vessels which show the BPR lights, but are working, for example, in the port of IJmuiden, There is a slight difference between vessels, working vessels from the inner waters and from the Colrec waters, so to speak. Then that is allowed because we have these special rules.
And when I go to another country, where can I find the special rules from?
That's why you hire a pilot.
Exactly. That's why you hire a pilot. Yes.
Okay.
Yeah? The pilot is the
I
one.
I don't take a pilot my whole holiday trip to
Of course you will.
France.
You always give him coffee of yesterday, he will go away by himself. No, on a small ship you do not need to take a pilot. In Holland the rule is 75 meters, for example. And in Spain it's 50 meters, because they want to make more money out of the ships coming in. Yeah? The only time when you are exempted, if you take a special exam, and then you get a pilot exemption certificate. And captains and mates that are on these vessels going from Vlaardingen to England 2 times per day, and they come in the same port 2 times per day. If they should take a pilot every time, it would be very expensive. So they save on that money. They take only mates, officers, or they give all their mates, officers, a PAC, pilot exemption certificate. Yeah? A pilot. Yeah. Not required every time before you reach a foreign port to take all the books which concern the local legislation. That would be impossible. What time do we have?
1 hour still.
Oh. I'm still confused by the discussion. Rule 2, very important, especially this one. Rule 2b says that you have to deviate from the rules during special circumstances and to avoid immediate danger. You have to. So if I ask for an example of Rule 2b, you should not give the answer which I always get 10 times every year. Dat was kleine zeilvaart usually, not from the grote zeilvaart. The other vessel that should give way is not giving way, so I'm doing everything I can to avoid collision. That is in the rules. It already says that you have to do that. But deviate from the rules is the example that I basically give every year. These are 2 power-driven vessels. They approach each other. There is risk of collision. Do you still know what they have to do?
I'm already starboard.
Both vessels have to go to starboard and pass each other port to port. But if there is a tropical island here and there is danger that you run aground, then you do not go to starboard. You have to use 2b. I'm going to deviate from the rule because following the rules would bring me in immediate danger. So, the simplest, if I ask this question during the exam, give that answer.
Well, in this case, what do you do? So in this case, what do you do?
In this case?
You can't turn to starboard.
No, I would communicate with the other vessel.
So you have to communicate.
Yeah, in this case, yes.
Yeah.
Or slow down and try to signal with lights or anything. But nowadays we have AIS, which makes it very simple. You know the name of the ship, you know everything.
Maar degene die daar op de brug staat, die ziet toch ook dat hij niet naar stuurboord komt.
Never assume that somebody knows your problem, so to speak. Huh? So always assume that there's somebody very stupid in this vessel. It's already some time ago when I worked on a guard vessel that was protecting a survey vessel, the coast of outside of Rio de Janeiro. Yeah, outside the coast of Rio de Janeiro. And this survey vessel, very big vessel, they had long cables, 6 of them, and they were, I'm not sure anymore, I think almost a kilometer long, and they cost 1 million per meter, the cable. Really expensive. You do not want people to sail over them. And we were on this guard vessel, and what we always did, I was with an English captain and we did 6 on, 6 off. Best days of my life, not. What we did was to protect this vessel and to call on other vessels that were approaching this vessel. And we did not have AIS yet. So I had to call a vessel which would come from this port. Vessel in approximate position, with approximate course and approximate speed. We had a good radar, so that would really be helpful. This is 7 Seas. Do you copy? Nothing. Approaching. Vessel in approximate blah, 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 blah. And then after 2 minutes, yes. Filipino mate. Not to generalize, but in this case it was true. Could you please alter course in order to avoid, and she was having full lights on, huh? Every light visible, red, white, red, lots more red. I even had a little blue, which is not prescribed in any rule, a little blue flashing light. And a gun with that. Okay, and I called the ship again and I said, could you please deviate your course and avoid crossing the course of this ship or crossing on the aft. Please take a wide berth, and I would give an advice. Do like this or whatever. And then in this specific case, the officer said, my captain does not allow me to change course. Well, better wake him up then. And about 2 minutes later, you would see the ship. No comment on radio, grumpy captain. And then she would deviate course. Yeah, exciting. And the other thing that you would encounter here, that was not Rio de Janeiro, but Vitoria. And it's the lee shore of the southeast trade winds. The whole coast of Brazil is a lee shore. So it's very choppy. Big waves, 4 or 5 meters up, 4 or 5 meters down. Not annoying, but very gradually. But you had these very, very small fishing vessels, usually without a light, and you would see them, and you wouldn't see them. You would see them, and then we would just park nearby, and then we would get this gun and then make a light, and then usually the fishermen would wake up. Yeah, big fun. No, can't recommend doing this work. Okay. Why was I saying this? I was deviating from my story. No problem. Okay, we are going to the lights. Lights and shapes. And I'm going to go through this pretty fast. Because most of you already... Can I go to the toilet? Yeah. Most of you already know this from your time on the Kleine Zeilvaart or from your other previous schooling. But some things deserve more attention. This is the basic setup. We have the masthead, which is shining over an angle of 225 degrees, and the rest of the 360 is filled up with the stern light. Yeah? And the front section is also divided by the red and the green side lights. If I'm approaching from this angle, what do I see?
White light.
Keep still. From this.
White and green.
White and green. True?
Yeah.
It is true. All the lights on seagoing vessels, they are shining outside the prescribed sectors. Yeah, so if I'm standing here, I will see white and green. If the course changes,
the white in the top, you can see also.
I can also see the masthead light. Sorry, yeah, this is true. I see the masthead light, the green light, and the stern light. And if I'm going to do this, for one reason or another, I see a fading in the white and green light from the front, and this light will grow stronger. This is a special light called a towing light. A tug will be equipped with that. It's situated above the stern light and has the same angle of 135 degrees. When we are talking about all-round lights, they should be visible on the whole spectrum, 360 degrees, and some occasions they are not. A flashing light is a light which shines 120 times per minute. This I already mentioned, and this as well, lights should be placed in the center line, except when they have permission not to have that. Rule 22. I wouldn't pay too much attention on this rule. The important thing to know is that masthead lights are always the brightest. It's the first thing you see. They're also placed higher than the other lights. And the bigger the ship, the more power they should supply. The more power they should use for the light. Yeah. Not going to go into this too deep. What should you know about a power-driven vessel is that they have the basic setup, no all-round lights, and if they are 50 meters plus, then they should have a second masthead light, which is handy because if a ship approaches you and changes course or you change course, the first thing that you see is that these lights will start getting out of each other's center line. Yeah?
If I have a petroleum lamp, how visible?
Sell it on Marktplaats. It's not very visible. You are allowed to use it. If you have a ship which is less than 7 meters and you're going maximum of 7 knots, you can wave your light around.
Okay.
Lady with the light. It is possible, but only for small ships.
Only for small.
Yeah. You can use it when you go anchoring, of course. Yeah, power-driven vessel. 2 situations. Are you allowed to have these double lights also when you have a ship of 40 meters? Yes. Basically, you're always allowed to use the lights which are meant for larger ships than the one you have. Basically. Some extras. If you see a hovercraft, I know they're sailing near the Isle of Wight. There's not much other places that I know where they are sailing. They have a flash, 120 times per minute, an extra yellow flash which is visible all round. And
only when in use, huh? When they're sailing.
Yes, yeah. Yeah, sometimes they leave it on when they're berthing if they move away quickly again. The wing in ground, you know what it is? If you see it, ignore it because there are hardly any wing in ground. It's sort of an airplane which uses a build-up of pressure between the sea surface and the underside of her wings. So she's flying very close to the water. It's one of the things that the Red Army wanted to use during the Cold War. And now they're used for tourists on the Caspian Sea. I haven't seen a wing in ground ever. You have?
Yeah, Black Sea.
Black Sea?
Yeah,
Okay.
in front of the Varna in Bulgaria.
Oh, okay. What did you do with tourists?
Yeah. Well, I haven't seen them at night, just during the day.
Okay, still cool. Yeah. Are they going fast?
Yes.
Really? Okay.
25 knots, but easy.
Okay.
They planes.
Yeah.
So, well, I don't
Okay.
care.
Okay. First time I meet somebody who actually saw a winging ground. Okay. Black Sea. Yeah.
Seriously.
What if my power-driven vessel goes at anchor? Yeah, depending on her size, she will have either 1 or 2 anchor lights. And the anchor lights are visible all round. And they're just the other way around as the masthead lights. If your ship is over 50 meters, you will have a masthead light and a second masthead light placed aft and higher than the first aft headlight. And when at anchor, it's basically the other way around. You have 1 light when you're less than 50 meters, and an extra all-round visible white light placed lower and more to the aft if you are over 50 meters. And if the ship is over 100 meters, you need to light your working lights or your gangway lights. Otherwise, some genius might think, hey, there are 2 ships at anchor, let's pass through the middle. Yeah? During the day, only one shape, which is a black ball. A power-driven vessel which is less than 7 meters, she doesn't need to have an anchor light if she is not in the way of any incoming or outgoing traffic, and the working lights I also already mentioned. When I'm towing and or pushing, I need this extra tow light, which is on the same angle as my stern light and is colored yellow. And depending on the length of the tow, I have either 2 masthead lights in line or 3 masthead lights in line. The first one in the situation where my tow is less than 200 meters or equal, and if it's more than 200 meters, I will have 3 masthead lights in line and a diamond shape during the day. Yeah. If the length of the tug itself is 50 meters or more, you will have an extra masthead light, just like a normal power-driven vessel would have. Here we have some pictures to make it more visual. The vessel is over 50 meters itself, but the tow is less than 200 meters. Yeah? In this situation, the tug itself is less than 50 meters, but the tow is more than 200 meters. And in this situation, both the ship is 50 meters or more, and the tow is 200 meters and more. What do you do when you are towing a vessel on the ocean that you found adrift? You think, ha, booty, bounty. It's mine. What do you have to show on your normal, between brackets, normal ship in order to let the world know that you are towing a vessel?
You don't have the light. You don't have the light.
You don't have the lights, but what you could do, or what I ask you to do, is to put a spotlight on the towing line. Yeah. If you can't show the regular lights, that would be a possibility. Of a lantaarnetje.
Piratenvlag.
Actually, I think there's still a rule if you encounter a vessel which carries a pirate flag in the middle of the ocean to shoot her out of the water. I never did. Here we see the situation from behind. The towed vessel does not show a masthead light, which would be not visible from here. So it does not show a masthead light. We also call it a steam light. Okay, keep that in mind. She doesn't steam, she's being towed, so no masthead / steam light. She does carry the stern light and the side lights. And this is from the front. And if the tow is over 200 meters, both the towing vessel and the towed ship will carry a diamond shape. I do not like this one, but
Cosmo, can
yes?
you go back to the previous one?
Of course I can.
If the tow is less than 200 meters, what's the difference with the diamonds?
I think it is on here.
Ja, these are the day marks, aren't they?
The day marks only. This one.
Look at the day marks.
So what happens if the tow is less than 200 meters? Do you take away one of the diamonds?
Yes,
The
you
big
do.
one?
Both.
Oh, both? You take both?
Yes.
Ah, okay.
Oh, now you're tricking me. Old information. We're going to look it up today. But my first guess would be both.
Okay.
I never towed, so I don't. When I would be towing inconspicuous, partly submerged objects. And if I'm towing, then on these pontoons or whatever platforms, I have to one in the front and one in the aft. Yeah? I'm not going to go too deep into this. And if she's longer than, or if the distance between the lights is more than 100 meters, you have to put an extra light. And if the breadth of the object is more than 25 meters, you also have to put white lights on the side. The message being, put a lot of lights on your object which is being towed. That should be okay. Oh yeah, and here you always have to have these diamonds. Yeah, I'm now sure, no diamond on the ship if she's being towed on a tow of less than 200 meters, because you see the ships together. But if it's longer than 200 meters, might even be 2 kilometers, then you have this diamond on the towed ship. But on the inconspicuous object, you have to put the diamond in front and also on the aft if the length of the tow is also in the front or in the length of the tow is over 200 meters. Dracone is a gas or air-filled hose, usually used in this case to clean up oil spills, and they usually have a very small light aft. A pushing vessel. She doesn't have this, extra stern light, this towing light, and the pushed vessel in this case will show her side lights. I'm not going to go too deep into this because this is not something you encounter a lot at sea, because towing is the solution when you want to transport an object to another place, because pushing or having a ship alongside, if there's any waves, it will create a lot of damage. But they will do it in areas close to the coast. I saw them in the United States. A lot of them, actually. Coming into well-known territory, the sailing vessels. And something that people sometimes forget is that the red over green is not obligatory. Basically, having the side lights and the stern light is enough. A sailing vessel does not use a masthead light, which we also aliased with steam light. Geen toplicht voor een zeilschip. Only when she's using engine. Yeah? The ship is less than 20 meters. She can use this combi light in the top of the mast, and can use a little white lantern when she's less than 7 meters. This is the combi light, and if you have a combi light, you cannot also put red over green, and it's too much light. Rowing boat, also not something we anchor a lot on the oceans, but they are usually treated as small sailing boats. Fishing vessels, we have these two types, the trawlers and everything that is not trawling. And as I said, trawlers, you know that they have their net on the aft. Non-trawlers, you do not know, but they will indicate if it's a very long line or net on which side they have it in the water. Trawlers use green over white, non-trawlers red over white. And they can only use that when they are being hampered by the fact that they are fishing. They are less maneuverable because they have their fishing gear out. So, if the fishermen would be very strict in the rules, which they are not, then they would be fishing, and then they would make a decision, is the fact that I am fishing now hampering my maneuverability? And if it's not, they should be treated, or they should regard themselves as a normal power-driven vessel. They have no special rights. But as everybody knows that at Sunday night, 12:01, the fishing lights go on in Urk, op Urk, sorry. They use it all the time. Yeah? Difference in underway and making way. I'm going to explain that right now. First we go to the trawlers. Trawlers has green over white, and she has a masthead light aft of that if the length is 50 meters or more. Yeah? So you can encounter trawlers without a masthead light. During the day, they will have this Diablo shape. I'm saying during the day, but from the build of the ship, they will put this in the rig, and when the ship is demolished, they try to get it out. Yeah? Oh yeah, when the ship is at anchor and still performing her work, no anchor lights, but only these. Yeah? So if you find a ship which does not have this light on and this light is also off, you do not know if it is dead in the water or at anchor. The non-trawlers. The non-trawlers will also use the Diablo. I forgot to draw it in here. But they have a different set of lights. They have red over white. Same as with the trawlers, they will kill pardon. They will kill their stern light and their side lights when they are not making way through the water, they are underway, or at anchor. But as soon as they make way, they will put on their side lights, their stern light, and no, they never have a masthead light. Why? I do not know. They never use a masthead light. They do have another feature, and that is something I asked in the beginning. The vessel that is the picture that we saw of the white light pointing in a direction. It was a question. If a non-trawler has a rig or a line over the side, either on the aft, the front, the port or the starboard side, and it's longer than 150 meters, at night she will show a white light in the direction of that rig, and during the day a conch apex upwards, so a triangle facing upwards. So then you know on which side you could pass safely. That's the basic idea. Do we see a lot of these vessels in Dutch waters, in the North Sea? Coming more and more, eh? Yeah. We get a lot more squid in our North Sea waters now, because everything is warming up. There's a lot of migration of more exotic species going northward, and now you see nowadays you see a lot of trawlers that are being rebuilt to fish for other fish, and they also have to change the lights. Once I was in the Sea of Thailand, the Bay of Thailand, and we were sailing at night, and then you had these squid fishers, and what they have is a jug machine. There's two rolls, and on these two rolls there's this line going with hooks. It's only hooks. Maybe sometimes bait, I'm not sure, depending on what they're fishing on and what kind of squid. And the thing is that these rolls, they make a sort of strange movement. They do like this. And they're going into the water, and this whole line is continuing, and the hooks are doing this all the time. And that attracts the curiosity of squid, plus the fact that they have very, very strong lights at the deck pointing into the sea. And they're fishing schools of squid by the tons. And there are so many boats in that bay during every night that you can read a book on deck. So much light. It's amazing. And that's so nice for the squid, of course. This is a pearl seiner. She has two extra yellow lights that alternately flash every second. Die gaat aan, die gaat aan, die gaat aan. Yeah? So if one goes on, the other one goes off. And the pearl seine visser, in Icelandic snudevaart, you know it? That makes a sort of a ring around the school of fish, and then with some wires, either from the mothership itself or for some small assisting ships. Have you ever been sailing on one of these boats? Really?
Not on the boat, but in between those boats.
Okay. How was that?
Bad.
Yeah.
Because they go 6-8, you've got really big sea.
Yeah.
And it was 6-8 vessels working together.
Yeah.
Nightmare.
Party.
Yeah. On the radio as well.
Again?
On the radio as well.
Yeah.
It is a body.
Oh yeah, okay. A ship which is not under command will show 2 red lights during the night and 2 black balls during the day. If she goes at anchor, the situation has changed. It's just a normal power-driven vessel at anchor. Oh yeah, if making way, she will of course have the stern and the side lights, not the masthead lights. Why would a ship be making way? We're not under command. Well, I told before, if for example, if they want to kill the wind which is going over the deck. A vessel restricted in its ability to maneuver has a red, white, red. During the day, replaced by ball, diamond, ball. And if she's making way, there's also a difference. If she's making way, she will use masthead light or lights depending on her size, and the side light and stern light. Some examples. This ship is over 50 meters, making way, seen from the port side. In some occasions, especially in port entrances, when they are dredging, they will appoint one side on which you can pass, and the other side you should not pass because they have their suction arm out or something, and there will be 2 red lights during the day replaced by 2 black balls. On the other side, the free side, 2 green lights during the day, 2 black diamonds.
Of course, wrong.
Yes?
On the right hand side, should there be a day mark for restricted ability to maneuver? On the right picture, should there be a
yes, they should.
ball?
Yeah, very good. Yeah. I didn't take it with me there. Yeah. And what is the shape?
A ball, square, or balls, diamond.
Ball, diamond, ball. Yeah. Yeah. Oh, it's not in there. It's the first time I noticed. I will draw it in.
Please, yeah, please do. And then take the.
If a ship is performing diving operations, they will get the only colored shape which is being used in the Colrex, and that's the alpha flag. Diving operations are being performed. Well, this is the Navy, so everything is a little bit different. If a ship is doing performing mine laying operations, she will have a Christmas tree with green lights during the night, a masthead light, and during the day she will have 3 black balls, where in the rest of the Colrex green is always a diamond. Yeah, Navy. Keep distance 1,000 meters. That says it all. Constrained by draft. 3 red lights. Yeah, 2 red lights for the NUC and 3 red lights for the ship constrained by its draft. Of course, for the rest, it's just a normal power-driven vessel. So you will have the normal lights depending on their size, masthead lights, etc., etc. And during the day, a black cylinder, which usually is not visible because the ships are much bigger than other vessels. And as we already mentioned, the officer of the watch or the captain will decide if the ship is constrained by her draft. During normal operation on the ocean, she will never be in this situation. But coming close to the coast, entering a fairway towards the port, she might use these lights. The pilot, white head, red nose. We always say white over red. And usually when she's at anchor or when she goes alongside to change pilots, she leaves on her lights because she's still in pilot duty. Yeah? And many countries have a shape for the pilot boats, but it differs per country. The last one, new record. The last one. When the vessel is aground, if a ship is over 12 meters, you need to show 2 red lights all around. So if you own a yacht of 12 meters and 1 centimeter, you have to have these on board. I know a skipper that got fined once when he was searched. Yeah. And you need to have 3 black balls on your yacht of 12 meters and 1 centimeter. Yeah. Yeah. I don't know if you know the story of the Dutch couple that was sailing in Germany, and they were going from, they were near Cuxhaven by the Elbe, and the police were hailing them because they were going into the fairway and out again, and the fairway and out again. There's also a lot of current there, of course. And point the offense on these guys, but when they went into the port of Cuxhaven, they went to the ship and they did a full search and gave fines for the fact that they didn't have 2 red lights. Yeah. Yeah. Okay, these are all the lights in the minimum amount of time given to explain this. Are there any questions?
I saw on the IJsselmeer something like a boat with 2 flags, red and white.
Ah, dus do not make a wake. Geen golfbeweging maken.
Okay.
Wit boven rood in het BPR.
Yeah.
Geen golfbeweging maken.
On both sides.
Ja. Then they are doing survey. Dus waarschijnlijk proberen ze plaatjes van de bodem te maken. That's only in the inner waters of Holland, not outside. Cannot carry it to the ocean. Please do not make a wake. Try to sleep. The ocean will make a wake anyway. Wake, golven. Yeah. More questions? No? As I said before, there are exceptions to the rule, but especially in inner waters. So this is the basic setup of the lights that you can encounter at sea. Okay, following your suggestion of a small introduction round, I do not have a name list. I would suggest if we just go like this, and that, and this, and that, and Roelof is last. Just shortly tell when did you do the Kleine Zeilvaart, where are you from? Maybe it might be nice to form a study group, maybe online, it's also possible. But also what you want to achieve.
Okay, I was doing the Kleine Zeilvaart last year, and I actually am living in Amsterdam, but I'm working in between the week now in Maastricht, in Belgium. So that's why I have to travel quite some time, but I have no time in the evening to study, so it's nice to do this course now. Yeah, and I'm looking forward for traveling around on a sailing ship, but in which way I don't know yet. But I will see. It will happen.
And your name?
Luc.
Luc. Best to start with. Yeah. But living in Amsterdam and...
Yeah, my house is in Amsterdam, but I have my work now in Liège Airport.
Oh, yeah.
And I have an apartment, and I live in Maastricht.
Okay.
Monday to Friday.
Okay.
The weekend I'm in Amsterdam.
Yeah.
Like that. It's first time.
It's doable. Yeah.
It's nice actually.
Thank you.
I'm Titouan. I'm coming from Toulouse in the south of France. I have done my class LV 3 years ago now, and I'm actually both on those ones, and I'm going to stay as an officer in some years with them, send me back to school. And for now I'm living here, so if you're looking for me I will probably be every day in the library. On the library.
In the library.
Yeah.
Yeah.
I'm Enki. I did my KZV also 3 years ago. I'm from France, but now I live on the Rippedam, just outside.
Oh yeah, the pier where the charter ships are laid up.
On the vending. I've been sailing since 3 years on the Tekla as a techie and then an officer.
Okay. Nice trips on the Tekla.
Yes.
Oh, did you also do the trip?
Yeah.
Okay. Interesting.
So in 15 months on board, the last 18 months.
Okay.
Something like
Yeah. Okay. Cool.
Yeah.
Thank you.
Mark de Klerk, live close to Rotterdam. En dit kleine zeilvaart toen in 2018?
17, 18.
17, 18. And I don't have existing plans now on sailing big vessels. Stick to small ones. Just here as a supporter, I think it's close to the school.
Yeah, the founding father called them sponsor, but I don't think it's really doing any right to your ambitions. No, but okay. Yeah. Verdieping.
Yes, yeah.
What's the English word?
Kunnen we gelijk een briefje op laten gaan, dat mensen hun naam op zijn telefoonnummer, e-mail en eventueel adres.
Ja, dat kan ik niet van jullie vragen, want dat doet ze met de privacywetgeving.
Dan zal ik zelfs goed in het algemeen vragen.
Yeah, what we could do is leave a list here, and those who want to can leave their contact. I would recommend only email address.
Yeah.
Or for a start.
Maybe telephone.
Maybe telephone number to make.
En je pincode is wel. Ja, pincode.
Pincode. Hi, Bob. Your sexual preferences. Okay. Thank you.
Yeah. My name is Andre. I'm living here in Enkhuizen, at the Kuipersdijk, and I'm married with Ingrid. And we did the KZ2 in 2010. And we have a small sailing vessel of 13 meters, and we sailed with guests around in Norway and Spitsbergen and Beren Islands.
Nice.
During the period from 2007 till 2015, and after that the ship was in maintenance and we had other studies.
It's the orange.
So we are planning to make a new trip next year, and we thought about, well, what is a good preparation that we thought about, and
let's go to the neighbors.
Let's get to go to the KZ2.
Yeah. Okay. Nice.
Yeah.
Thank you.
Yeah, so my story is almost the same. My name is Ingrid, and I did the KZ2 in 2010. I'm married with Andre, and sailing to Spitsbergen is, it was fantastic. So we planned for a few years to go to the south, but every time there is something in life that it won't work still. But now
and this year
we hope, this year, yes, Corona. So, but maybe in the future we want to sail further south.
Yeah. Okay. Nice.
So.
Thank you.
Okay, my name is Jaap, and I was also with Martin and Rudolf 2017 on the Kleine Zeilvaart. And I was many years sailing on scootjes, and now I like to go to the sea. Some years ago I went with the Twister, with the Swan, and this year there was less. I did some shutter pieces on the Waterzee and a little bit inside the Datrix.
And from Leeuwarden, don't forget to mention. You're from Leeuwarden.
Yeah, I'm from Leeuwarden.
Yeah, that's very important.
Yes.
Okay. Yeah, thank you very much.
Moet ik wel goed zeggen.
What?
Ja, wel goed zeggen, want jammer.
Yeah,
My name is Hans Peter. I did last year Kleine Zeilvaart. I used to own a shipyard specialized in wooden ships here in Enkhuizen. And now I know,
I know your name. Hans Peter Baars.
Yes. Okay. So I sailed all around the world privately, and now I'm living in Friesland. Just moved in there last week.
Okay.
Yeah.
We're neighbors now.
Yes.
Yeah.
And I have no objective here, just that I like it and very interesting.
Okay. Great. Thank you.
My name is Maarten. Maarten Beek, niet Maarten de Klerk. Ik heb I did the KZV last year.
Yeah.
together with Luc and with Martin. And I plan to do the GZV immediately after this, because when I grow up I want to be a captain of a sailing ship. That's my ambition. So we'll see how we get there, but we'll find a way. So I think first take the course and then we'll take it from there.
Okay. Yeah. Nice. Thank you.
And I'm Martin Pot. I live in Rotterdam. I live on a boat, which is a motor vessel. So I'm actually at the wrong school here, but did the Kleine Zouver last year. My ambition is to maybe do an Atlantic crossing end of next year, but that is due to Corona and investments maybe going to be a challenge. But anyway, I want to learn everything that I can possibly learn here this year. And try to get some sailing days.
Yeah. Yeah.
Who knows?
If at all possible during these
possible. Yeah.
weird times. Okay.
Yeah. And my view is the Oosterschelde.
Ah yeah.
Usually. Yeah. Now.
You look at the
Yeah,
Oosterschelde
you look
when
at the Oosterschelde almost
when you're
all the time.
looking
Yeah.
at the window. Okay.
Feeling very sad that it's not sailing.
Yeah. Yeah, I feel there too.
Oh.
Okay.
Yeah.
Thank you.
Okay. My name is Ron Bielsma. I was born in Enkhuizen, living in Termunterzijl in the province of Groningen. I did my Kleine Zuivaart in 1990. And that other building here, what is now
The Kuip.
destroyed.
Yeah. The Kuip still.
I've sailed on many ships. This year my intention was to sail a lot, but Corona came in. So my only voyage was 2 months on the Tres Hombres. And my achievement is to be a captain on the Tres Hombres in a couple of years.
Okay.
And the Nordlies.
And the Nordlies, yeah. Nice.
Yes.
Thank you.
Welcome.
Hi, I'm Connor, I'm from the UK, but I'm living in Holland at the moment. And I did the Kleine Zuivaart last year. Next year I'm going to be on Antigua, because I was supposed to be on there this year, but they cancelled.
Starting as deckhand or mate? Okay, yeah. Okay. Cheers, thank you.
Hugo Hansen, I'm 62. Just doing this for fun. My goal is to achieve, what I want to achieve is pass the exam. So it'd be nice. I've done the Kleine Zuivaart 2 years ago, with Jaap and Roland and Mike. And I'm sailing on a small 34-footer, but a fiberglass boat, so I'm not a square rigger at all. But I'm just here for fun.
Yeah.
And we've done just about everything the school has got to offer. Except for Pauline's cooking course. We're still waiting for that. But for the rest, we've just about done everything.
Are you sure? She pings up everything with the microwave. don't tell her.
You don't have any microwave.
Ik ben Roelof Grootvat, ik doe het gewoon in het Nederlands.
I will translate.
Engels is niet zo geweldig. Ik heb met andere mannen de Kleine Zuivaart gedaan en een heleboel andere opleidingen en ik doe dit om de geestenmassa in beweging te houden.
So Roelof is here to train his brains. Yeah.
It's like mind training.
Next year I can help you.
Yeah. Okay, thank you very much. 15:30, yeah, we have. Yeah. There's one announcement that I want to make. So this year I'm introducing, besides the fact that we have a tutor hour in the schedule, I also offer my services to all students, coming down to very specific questions coming from you. So you can mail me, and then we can make an appointment in during a break. And what we can discuss then is your goal and how to get there. I do not know everything, but I know a lot about certification. I can also answer questions, for example, about, hey, I want to get this certificate of competence, and I already have sailing time on this vessel, does that count, blah blah blah, etc., etc. What do I do to make it accountable? you can ask these questions during a personal session with me. Email me, and that's it. For the rest, I wanted to make an announcement about a course of wind-assisted ship propulsion starting in January, February, which is offered for free for you guys. As you might probably know, but I'm not sure, this wind-assisted ship propulsion is divided through the second half, usually on the Saturdays. We're going to add some extra students from abroad. They can follow the course separately. And the course is closed with a test. And I emphasize test because it's not an exam. So if you choose not to do the test, you can still get your Grote Zeilvaart paper. I would recommend, though, to do the test because it will give you our very new, brand new certificate of attendancy, or no, I have a different name for it, I will come to that, for the wind-assisted ship propulsion, and you will be, yes, the first generation of students ever achieving that, because it's the first year that we are going to start that. It's completely new for me, for us, but I'm very excited about it because this is a technology that will develop further. We have the wind in our backs, so to speak. As we speak, China is developing very large crude carriers with rigid sails on their decks, and more I hear sounds coming from companies, shipping companies, that say, hey, might it be possible that we ask sailors to come to our ship? And then I say yes, it might also be possible that we tell our sailors about the technologies that are at hand and are still under development, so that you can tell the owner how to dress the ship up. So that's the basic idea. Starting in January, we have 2 new teachers coming to this school. Both have a technical background and are graduated from the TU Delft. I'm trying to keep the level at the same level as the rest of the subjects of Grote Zeilvaart, not make it too academical, because basically I would like everybody to be able to know, to gather some knowledge about wind-assisted ship propulsion. It's all in the second half. You had a question first, Titouan?
Yeah, is that the program which is in link with TOWT from, and because I read something in the newspaper in France about something.
Yeah, I am in
rigid sail. TOWT
yeah.
wants a flexible sail.
Yeah, but then, it's not only about rigid sails. It's also about Flettner rotors. It's also about soft sails. So TOWT, I'm in communication with them. The problem being they are French, I am Dutch, and we are lost in translation sometimes in the English language. So sometimes we write emails to each other and we have to repeat ourselves. Maybe I can ask you to be a translator in the future, Titouan. But there is communication. There is communication. There's also communication with other initiatives that take wind-assisted ship propulsion.
You also have Neoline coming up. You have another project coming
up.
Yeah,
there's another project in France coming up, and France is really active now. Also getting some money from organizations or, from the government. So it's really going fast now. Yeah. Okay. I'm excited. Wait.
You're saying this is on Saturday, in February?
Yeah.
So does it coincide with GZV?
Yes. So it's in between. What I did do is skip something out of your curriculum, the subject of English. So English is moving to the Kleine Zeilvaart completely, and instead of that, you will have 1 exam less, only 11, but you will have 1 test, which is not obligatory, coming in that place, and you will get extra hours of lessons. Yes, you will. Yeah. It's going to be fun. Yeah, it's going to be interesting. And also, Fair Transport is going to have a big part of the program as well. Yeah,
very interesting developments.
Yeah, very interesting. And the thing is, what I really like, and that would be the last thing I say, almost, what I really like is that we start this movement coming from, not from the top, but from the people on the working floor. I want people that have come to this school go to the ship owner and say, hey, come on man, the deck is empty. Raise some mast. Yeah, I know everything about it and I will help you there. That would be fantastic. Yeah.
Maybe a question for everybody. In what time I need to get 180 sailing days?
That's something that we might discuss more personally. If it's okay with you, yeah. Otherwise, I do not know your situation completely, and if I give an answer now, that is not the complete answer to your question. Yeah, we were going to sit together.
All right, well, maybe interesting for everyone.
Yes and no. Okay. Anybody else? Any questions before we break up? And I will try to contact Marijke again. Yeah.
Calculators.
Oh yeah. Calculators. I have calculators. They are for sale. 60 euros.
Can you pay with price on top?
No, you cannot pin. You have to pay cash. And I have no change. So we can do it next week. Yeah? Good.
Dat is 65.
Cosmo?
Yeah.
Is that mandatory to use this one, or can we?
No, you can use your if you have another model which has the same possibilities, you can use that one. Please do.
What possibilities does it need?
I have no idea.
Oh.
1 plus 1.
It says
Programmable.
Oh,
Yeah.
not just design.
No, programmable. Yeah. Because I know that, for example, for astronavigation, you need to be able to put formulas inside of the little computer.
Well,
60. At Amazon they are for sale for 58. I just saw that. 58. But then I think everybody knows a little bit about the working circumstances in the warehouses of Amazon.
Wrong idea.
Okay.
Can we do it next week?
Yes, of course. They're not going anywhere. So come to me, bring your 60 euros, and you will get a beautiful Casio. It even has a telephone on it. Okay, you're entitled to a break, which lasts until 15:50.
Well, thank you very much.
Please put on your mouthpiece.
Zo'n ding heet een face mask.
Ja.
En wij hebben dus hebben wij in 2010 de kaas gekregen.
Van de Casio
I don't think what we're going to do after January is kick this door out. And then the same situation classes 6 and 7. We're going to come to these rooms. Oh, cheers, thank you. And there's going to be a group here and a group there. But of course, I want to fill it with people that do either the endorsement or the wind assisted ship assaults or both. But the thing is, which I realized later, the wind assisted ship assaults are also going to offer online. And I know that most people want to do that online. There are places anyway. But please let Brigitte know.
Another ship is sailing toward Portugal, and they are going to attempt to cross, but the secret, maybe they need to turn around or when arrive cross the side directly, depending on the
Yep. Okay, I understand. It's uncertain time. I don't see there's a problem, and I know there's only one student that wants to attend the second half because we are still in this place for room for one more anyway.
Ja.
Dus we moesten ook gelijk.
Ja?
Ja, ja.
Cool.
Wat zijn nou buren?
Ja, zeker. Ga je gang. Dankjewel. Kan ik weer pizza halen? Dankjewel.
Oh, je hebt helft van je werk. Hugo Iedereen? Ja, ja.
Ja. En hetzelfde uitzicht als bij Ventjes.
Oh, leuk.
Alleen
maar rijken.
Voor een goede club.
Ja, nou, lekker even naar buiten gelopen.
Dat is cool. Ja, van klachten over. Ja, dan moet je even door die deur gaan. Dan moet je even de schroefjes van het raam openmaken. Ja. Zie je buiten? Ja. Oké, fijn. Nou, dit is. Wat zijn ze meteen? Wat? Monique. Zie je? 25? Nee, dit is een 16. Nee, 1545 kan 5 minuten van de ja, ik heb zo. 1545. Mag jij jou wel op de manier even de deur klappen?
Marijke!
Ja.
Hey, daar ben je.
Beeld ook?
Nee, geen beeld.
Ah, ja, maar neem ik het leuk. Waarom doet hij dat niet? Ik moet jullie denk ik gewoon...
Nee, is jouw schuld.
Zo dan?
Nee, je hebt, ik zie wel jouw desktop, maar je hebt nu alles naar beneden gedaan.
Wat zie je?
Ik zie Marijke de Jong, NJ.
Je ziet niet, dus, niet het bord.
Nee, want jij bent nu in charge of de besturing. Ik zie hier eigenlijk helemaal niks, behalve NJ. Dankjewel.
Dag Marijke. Leidt er nou niet af?
Wat?
Ah!
Hallo?
Ik zie alleen mezelf.
Heel fijn. Ja, het is weer hetzelfde riedeltje als... En nu?
Nee, ik zie mezelf.
Ergens.
Ja, je moet tegen teilnemen volgens mij nog. Oh nee, is gestart.
Hartstikke fijn, nee. Ja, er zit namelijk onder mijn...
Er staat vrij hard over de luidsprekers op dat andere kant.
Ja, maakt niet uit, want er is geen les.
Maar is dat niet daarnaast?
Nee. Althans. Ja, Marijke.
Wat?
Er gebeurt iets. Ik zie het bord en dan moet dat nog even groter.
Oh ja, maar nou zit hij weer vast. Nu zit ik er zelf niet op. Ja, ik kan wel 125 knopjes indrukken, maar dat is nog niet goed doen. De rode streep om het beeld heen. En wat dat betekent heeft geen flauw idee.
Moeten we misschien even overnieuw beginnen?
Ja.
Of dat ik probeer jou eventjes, want jij bent, ik kan nu niks, want jij bent in command, om het zo maar te zeggen. Maar daar vraag ik even de besturing aan. En als je nou op teilneming drukt, teilnemen aan die nieuwe kanaalbespreking. Nee, hey, ik zie dat jij wel een schermpje hebt, rechtsonder. Eentje van jouw bord en eentje met mij. Yes, Marijke. Ja, nergens meer aankomen. Nergens meer aankomen. Ik zie het bord. Ik zie jou. Ja, ik zie je hand. Fantastisch.
Ja.
Ja.
Nu heb ik dus alleen weer niet het hele scherm, dus dan gaat het weer een beetje in het blauwe aan. Ik zie jullie dan wel heel groot.
Zie jij ons ook?
Ja.
Oké. Nou, ik zie er al een mooie hydrodynamisch schip.
Ik was nog bezig met dit.
Square.
Jullie zijn er nog niet.
Een blokcoëfficiënt van.
It's a partnership.
Kijk.
Jou daar.
Hartstikke goed, Marijke. De klas die komt met 3-4 minuutjes weer binnen en dan kun je gewoon starten.
Oké.
Ja, dat kan goed. Extra week even sanatorium straks. Ja. Contact met Duitsland. Mooi goed zo.
I think she's back to home. Definitely would be an interest to tape it on the computer and send it to her. Il est un peu bruyé. C'est le problème de ces grands trucs. Now we are talking about the quality of the coffee. It doesn't change.
Yes. So where are you staying now?
I'm staying. It's 10 minutes walking from here, and I think it's Zeider Aventexstraat. No, on a house.
Oh, you rented?
Yeah, we rent a house from Heath, the Nation teacher,
Of course.
who's to the student of which are on Friday.
Three?
No, with me and two Kazadi students from place 1A. Yeah,
Nice place.
nice place. We just need to keep it tidy because, like, she wants to sell it. We regularly have a potential buyer coming and visit it.
So you keep it clean.
Since last Tuesday, we already have 3 visits, 1 more next week. So we get an email saying Tuesday we will have a visit at this time. So when they come, we just need to go out and take a walk.
Maar je woont nog kort in.
Nog maar 2 weken. Nog 2 weken. Ja, wij kijk klein op de
we have it for sure until end of December. So like I'm going to transfer to stay in January. For me it's not a problem. But she said that if she said it for January, then I was to help them to find another way.
Ja, dat is ook niet druk.
We still have to look out more.
Yes.
And we can move.
Yeah.
I don't have 200K. I actually tried to buy something new, but my dad said, if you're rich, you cannot have more than 5K loan.
Ja, ik weet het. Ja.
Ik ben ook vrijwillig. Gewoon hier ook, maar daar is maar.
Ja, voor mij is de vrij echt club van Gerrit.
Ja, hallo.
Hallo. Ja, ik zit nu even achter de camera in plaats dat ik voor de camera sta. Want dan gaan we het beeld van jullie heel goed zien. Dus ik zie André. Ik daarvoor. Ik zie Maarten daarachter. En nog Maarten.
Ja, hij weet.
Ja.
Aanwezig. Bezet. Think.
Ja, waar is Klokker? Kom op. Oh ja, die zie je natuurlijk aanwantelijk. En Luc.
Ja, hier.
Kom op, hè. Oh, I can only see your arm.
Yeah, I'm still in the blind
Voor de camera staan we op. Echt op bed.
I see the one.
Yeah.
I think just in the back. So, that's way better than this morning. That's way better than this morning. Because then the image was kind of blur, and I heard voices, but I was speaking out into the blue, and that's a bit strange. But now it's way better. So we're going to try our best for these last 2 hours of your first day in school. Corona school. I just learned they found another 8,000 plus extra Corona patients. So it's still going up, but I hope in 2 weeks or so we are going down, and then it's way more relaxed to be in school. But I want to do, what I want to do with you in these last 2 hours is I have already made these 2 little drawings. These 2 little drawings are very, very important. If you can do them in the middle of the night, even at the end of your bar visits, no. No, there are no bar visits anymore, and no beer drinking in bars and stuff. Well, if you are at home, sitting in confinement or whatever, at any moment, at any time, you have to be looking at these drawings. If you do so, you are way ahead. What I have discussed before, I'm going to tell you how you have to make, or how you can make a stability curve. I have to discuss 2 other patterns, and I still remember. Do you remember this one? I know one of you does, for sure.
Oh, yes.
Yeah.
Yeah.
Free surface. Free surface moment.
The F of
Free service moment.
the F of free, the F of
Surface.
service, a special service, and the M of moment. Yeah. And free, it's in the word free, it's all about liquids in the tanks of your ship. And they can move, if you move or your ship moves, can move freely with it. So that's why it's free. The liquids are free to run around, so to say. Surface is that it's all about the surface of your tanks or wherever you have water. So if the surface is larger, and then especially in white, then the free surface moment will increase considerably. Moment is that it is one of the moments in your table of moments that you have to add. So this is actually a moment in total meters, and because this is a moment, you may add this at once in your table of moments, supposedly on the bottom, or where you have added your tanks. And you take into account the free surface moment. What do you remember what happened with this free surface moment? Shall I try to draw it once, because it's all in your reader of Kleine Zeilvaart. This is what happens. You have your ship, and it has a tank. Suppose this is the ship, and this is the tank. If it's completely full, will there be any problem?
No.
Don't think so. Because then it's a vast part of your ship. It will move with or without, but it will never change the center of gravity in your ship. If it's empty, same way. It doesn't, no way, change the center of gravity of your ship. But suppose in this case, we have our metacenter. Metacenter is what you've got. It's here. Under no circumstances is that going to change at a certain draft. And the draft is still, a little bit different to that one, but it's another ship. Center of gravity was here. And if you draw the center of gravity there, you know that this is the fourth down. And the upward thrust is always this one. Up. No, whatever, is no distinction. And this would, you did expect this to be your G set. But now you have calculated blood, sweat and tears. You have calculated your center of gravity with a certain load in your tank. But that certain load was this. Only this. So what happens if your ship heals, any ship with any tank, is this. Not too difficult to see that the center of gravity of your load is shifting to the lee side. And that's never a good sign. Because if the center of gravity shifts to the lee side, approximately with this triangle from here to there, you will find your center of gravity there instead of where you thought it was. And now your G set, and I do it in red, I do not have this many colors. I do it in red, maybe then you see it. This is the G set. You are left with it. Because now the center of gravity is here with the liquids in your tank on the lee side. This was your G set, and this is what is left. And if I draw this line upwards, then it actually looks like because that G is here, because the same green, the same, this G set feels like if you, that's the nice thing about stability, we all want to get it to the center line of the ship, because then these points are easy to find. When we changed or we used the position of the center of buoyancy on the center line in M. Now we use this not fictive but real center of gravity, and we move it upwards just as this is G set. So in the flow of your liquid to the lee side, your center of gravity changes. This is the G set left, and you can project this again on the center line. So you find a kind of, I think they call this the virtual rise of the center of gravity, G accent. And this was happened, and I think I told this in the Kleine Zeilvaart with the ship Herald.
Free Enterprise.
Free Enterprise, the Herald of Free Enterprise. At the Herald of Free Enterprise, there was not much water on the deck, just a tiny little bit, maybe a layer like this. And she was still upright with all this water, but at a great height and an enormous length. The whole deck was filled with water, and only this. And then she had to make a turn to Dover, and the ship heeled a little bit. That's what ships do when they turn, and all the water flows to one side. So the virtual rise of the center of gravity, the virtual rise of the center of gravity was such that it ended up above the center. So your center of gravity in reality went here. Then you go downwards. This is the upward thrust. So the ship is, capsizes. Actually, that's the only word for it. And that's only because when the center of gravity ends up here, this is the virtual center of gravity. It's above your metacenter, and then it's kind of obvious. Your ship cannot last, and she will capsize. This virtual rise of the center of gravity is G accent, Because if you calculate in a table of moments, supposedly kg, you may add your self-calculated GG accent, to get a kg accent, which means my kg, my preciously calculated kg, is corrected for the free surface moment. And you can do it yourself, you make a table of moments, and you add your correction, you virtualize the central voltage to get this one. And this GG accent can be calculated on its own. Do you remember how?
1/12 keer.
Using the free surface moment.
It's the 1/12 times something.
LB to the third.
Yes.
Something nice about this. This GG accent is actually nothing more, nothing less than the free surface moment over
Displacement.
displacement. Because then you have ton meters over ton, and you are left with meters. I remember in the Kleine Zelvaart that I asked, sometimes not, what's the definition of free surface moment? Well, it's free surface moment, of course. But it is, and that's actually good to know, because then you can calculate it yourself. It had everything to do with the dimension of the surface of the tank. It has nothing to do with the contents of the tank. Because the content of the tank, the weight of the stuff inside it, is in your moments. Okay, that's taken into account. Because if you have a tank like this, and this is the level in the tank, or this is the level in the tank, then here you have a free surface moment, and here you have a free surface moment. They are both equal, so no distinction. Or even here, you have the same free surface moment. It's all on the surface of the stuff in the tank. I think I heard it. I already heard it. Something with one something times.
Waarom? En de breedte tot de derde.
Cubic.
No, third.
To the power of 3.
Power of 3.
Power of 3, power of 3. That's it. That's it. So now you take into account the length of the tank, which is important but not so important. But you definitely take into account the width of the tank, this one. And that's the B, and that makes a hell of a difference. Because then the tank is much wider than this is the triangle going from one side to that side. So this B is enormously important, and this is why Herald of Free Enterprise didn't make it. Because the whole deck was from starboard to port, and they had a full wide of the ship to make themselves a free surface moment. And then this one is enormous. Of course, here times
What? The density of the liquid?
the density, of course. The density, because this is, I think, meters 4, and the density is
Tons
Per meter.
cubic meter.
tons per cubic meter. And then you are left with ton meters. So that's correct. That's correct. Free surface moments. Any ship has them. If not, then you have to calculate them. And I hope somewhere you have maybe a stability booklet of your own. At home, somewhere in a bottom drawer. But it's, unfortunately, it's made into scrap. But the Samsung Carry also carried tanks, quite a lot of them. And you can find these tanks on page, somewhere page 3. capacity above page 3. This is capacity of water tanks, but these are also, how do you call it, ballast tanks. To make ballast, if a ship sails empty, it really needs to get its center of gravity down, so they fill up their double bottom tanks and their ballast tanks. Here, though, you see the freshwater tanks. That's only 2. They only have 2 freshwater tanks. Probably they are already having a water maker. And on the other page, you find, this is something for a later date, this is the fuel and oil and gas oil tanks. These are these. So that's for the engines and generators and all kinds of stuff. But turn back again, we can look at these figures that in the second column, they give the frame numbers. Where can you find the tanks? These are the frame numbers. And you see that the 4-peak has a frame number of 111. And there should be an aft-peak tank. Oh yeah, here's the aft-peak, and that's -8. Where is 0? Where is 0?
The rudder.
Huh?
The rudder? The center of the
Yeah, rudder stop. Rudder stop is 0, so 4-peak is way forward, 111 frames further forward, and this is 8 frames further aft. So the aft-peak tank. Here is the capacity, and that's what you use in your table of moments. So they say maybe the tank is filled for 50% or for 100%. Most of the time tanks are filled for 89. This has a reason, because if you fill them for 89%, then you immediately take into account the free service moment. And I think that's wise, because when you start the engines or when you start taking a glass of water or make some tea, you will immediately have a free service moment. So you can take this into account. The only thing I could imagine that I do not do this with ballast tanks because it's very wide. It's no use to have ballast tanks not completely filled. But here you see the cubic meters, and depending on the can you see whether they fill them with seawater or freshwater?
Yeah. It's salt water.
It's all salt water. For instance, the 4-peak is 130 cubic meters and 133 tons. So obviously it's times 1.025. So this is filled with seawater. The next column, VGCG. No, not so difficult. That's probably
30% of gravity.
Should be the vertical center of gravity. Because the center of gravity of the 4 and the half-peak tank are quite high, but all the other ballast tanks are all in double bottom. And if you look closely, I would say that the double bottom is about 1.25 meters or something, because the center of gravity of the ballast tank, a deep bottom tank, DBT, is below the tank top. And 125 is not that much. I don't know if you have ever crawled in a double bottom, but it's no fun. Let me tell you. Vertical center of gravity. 1, 2, 3, 4, 5, 6 column is maybe of use during the exam. Because in a table of moments, you always have to multiply the weight times the distance, weight times the distance, weight times the distance. That's quite tiring. And I think in a few weeks you are fed up with table of moments, and that's a very good timing, because you need to get fed up with table of moments, because then you really grab it, then you are really into the table of moments and no worries at all. But here, in this column, vertical moments, they already have multiplied for you the weight times the vertical center of gravity. So you can just take this as a moment in your table of moments. You do not need your calculator anymore. These two, the last two, are for more 3 weeks or so. That's the longitudinal center of gravity, should be CG, LCG. And that's measured from the aft perpendicular, and they mix the Dutch and the English a little bit, because here is ALL, and that means achterloopt lijn, but it's the aft perpendicular, APP. So the distance from the forepeak tank, which is 82 meters forward of the rudder stock, and the aft peak tank is minus, it doesn't say, but it should be minus 1.87 meters from the aft perpendicular. But I actually, with all this stuff, I wanted to show you the last one. That's the most important one. And it says FSM, or free surface moment, in ton meters. And that's this part, the free surface moment. You can either use it to calculate your own GG accent, to add with your kg from your table of moments and have a kg accent. Or you take this FSM, you all add them up, because there might be more tanks having a free surface, and then you have a sum of free surface moments, and then you put this into your table of moments. But there is one thing to take into account. But if you have your table, like this, so here are the items, here the weights, here the kg, and here the moments. And what I said, you always start with, whoa, again something underneath it. We keep on crawling here. You always start with the ship. Suppose we do a tank now. The tank has a weight, has a kg, and has a moment. But on top of that, the tank has a free surface moment, and that's only additional. It has nothing to do with the amount of stuff in the tank or whatever. Here, this one is only here. So this one is enormous. This one has no weight, has no center of gravity, only a moment. And I see in exams, actually way too often, the fight with whether or not it's a weight, or it's a kg, or it's a FSM, or what stuff. But if you get used to it, I think you'll never be mistaken. And otherwise, you make in this book a kind note saying this is how a table of moment looks, and this is where I put my free surface moment. So here. So add the stuff to your tank on this side of the list, on this side of the list, and then see whether or not I should add a free surface moment to it. Which tank has the largest free surface moment?
Aft.
Yeah, the aft peak. Could you think of why? Why this particular tank probably has the largest free surface moment?
It's entirely above the waterline.
Yeah, it's of course in your ship it will not do. But if you have the aft peak of the ship, it's probably at the rudder, and it's probably looking like this. And here is the rudder and the propeller. So if in this part of the ship there is a tank aft of the perpendicular, you have a free surface moment, which is not that bad if it's not full, but if it's like this, it's a wide beyond belief, and then you have an enormous free surface moment. So in any ship, I know many ships, also sailing ships, that have tanks fore and aft. And please mind you that if you have these kind of tanks, when they are nearly full or 75% full, you really have a huge free surface moment. And if you get rid of this free surface moment, your center of gravity, virtual one, will come down and you increase your GZ, so you are more stable. So you are more stable to withstand a force 8 storm, or you are more stable to, in 2 weeks, to fight yourself through a severe wind and roll criterion. So this is the importance of free surface moment, but it should always be incorporated. And if you have a free surface moment like this, sometimes in the text you see this one. It was GM, but now it's G accent M. And I think in literature you often find a little zero here, but that's only, this is because this M is calculated at the moment the ship is at zero, has a zero U angle. So that's M0, and they call this the, I believe, what was it, the initial meta center height. G accent M, or K G accent. Adjusted for free surface moments, adjusted for free surface moments. And if you think you are mistaken or what, this is always higher than this one, no exceptions. And this is always smaller than the initial value for GM. This is free surface moment. Before we try to fight our way through making a stability curve, I recall another kind of moment formula, and that was like this. That was like this. It's also a GG axis, maybe you remember, and it had something to do with the heating test. It was also like this, the G accent is, and this has something to do actually a little bit the same with this moment, but it has to do with shifting stuff on board your ship. And you have a center of gravity, it's kind of static. But then you are starting to move around. Starting to move around. Or your passengers start to move around. What happens to your center of gravity?
Rising.
It has no option. Your center of gravity in this case will move with your passengers. Not that much. It's not that whoops, center of gravity is taken by the passengers and you lost it. Whoa, it's out. It's way out of my ship. That's not going to happen. So it's always relative. And the shift of the center of gravity, if you shift something up, it will go up. If you shift something sideways, it will go sideways. Down, it will go down. If it's going, if people stand here, for example, if people stand here, all in quarantine for corona, so they have to go down. Have to go into their cabins and you shut the door for 2 weeks. They go down. For instance, with this, they have to be here, confined in their cabins with corona. That was good. This is a certain rate. I call it P. The center of gravity thinks, wow, all these people are going down. I have to act. So the center of gravity goes down with it. They go down with a certain distance, call it A. Yeah, the only thing I can think of is a afstand, but that's Dutch, so it doesn't matter. It's supposed to be A. What the reaction of the center of gravity?
Go down, goes down.
It goes down, and the important thing is how much. And that has everything to do with the P. It is a moment, and the P is the weight. So you make a moment by multiplying it by the distance A. And the distance A is this distance from, in humans, in the center of gravity, I'm told this in the Kleine Zeilvaart, I'm sure. Center of gravity in humans is in your navel. And you may check afterwards, with a distance of 1.5 meters, you may check, because that from bottom, from deck to your navel is, the mean value is 1 meter for any person. So this is the distance A. So P times A is actually a moment in your ship, and the center of gravity has to react. But if P times A, it's only a small number of people going into quarantine, and on a huge ship, then the effect on the center of gravity is minor. But if there are many people, or all crews, and passengers, have to be quarantined down below, then, and on a small ship, then the effect could be great on the center of gravity. So this is to get a distance in meters over your displacement. And that's a tiny little formula to remember when you change your center of gravity. For instance, you made your calculations, you loaded your ship, and then something has to change. Yeah, GM is not enough. GM is 0.14. Oh shit, we have to bring something down to increase GM, so G has to be lower. So you take one, the load standing on deck, and you bring it down, and then you just need to know the weight. You need to know the distance where it comes down, the displacement of the ship you already have, because that does not change. And you have your GG accent, and it comes on top of your GM, so it will be larger, and maybe you can get it up to 1.16, and then you may leave. So this is how you could use this. But I hope you will not get stressed with all kinds of formulas, because I already said so. You may take everything you want in your exam. And if you find your reader and the reader stability shifts, and then the last page, page 60, page 60. Rule at the corner. So your stability reader on the last page, it says main stability formulas, and I believe they are all there. So this is what you're going to at the end of the term. So somewhere mid-December, you are familiar with all these formulas, and it's just like and they pop up, you know what to do, and you really know your way around. And I am always surprised to see you coming from the Kleine Zeilvaart being able in about 1 week to make at least beautiful stability curves. And then I know beforehand, I know what's the proper word in English?
What?
I know now that in a week or 1.5 weeks, I'm very proud of you, so that's nice.
Clairvoyant.
So I have to speak German all week, so now the only word comes to my mind is unterstützen. Lass das ich unterstützen. Yeah.
Doesn't help.
Support.
Let's support you.
So, so that's last. These formulas are there. They're of course in this book. I can also send them again on the PDF. You may copy them and put them in this book that you take in your class. And I was thinking this morning, why make life so difficult? And just let them take everything they want. Shall I do this?
Good plan.
Yes.
Yeah.
Sounds like a plan.
Sounds good?
Yes.
I know, I remember I did exam in the shipbuilding. I studied shipbuilding. And in physics and stuff, they also said, take what you want. Just take what you want. And what I told you this morning, it sounds wow, I can take what I want. But you do not have time to study during the exam. So that's a covered hole. You walk in very easily. So please take care. But for me now, at this very moment, just take it all. If it's of use, take it all. Because if you are later on on a ship, you also do not do it by head. And I neither. I do not make these calculations. Almost by head, but that's only because I do it so often. But the only thing what we want from you is during the exam is that you have a certain speed to it. So you get three, four exercises, and you have to make them in 2.5 hours. And that's the only thing. And now 3 exercises will take you 2 days. I can assure you. So that's a little bit the difference. But perfectly okay. Is it again, popped it up, this free surface moment and this P times A over displacement?
Yeah.
Can I, what time is it? 16:32. Can I continue in introducing you to the wonderful world of drawing a stability curve?
Yeah.
And that's the before. Because this is the last paper. And you see it's everywhere. So probably when we finish class at 5:30 or so, and the next moment I have to find a bottle of white paint and we do the whole. But it's all for knowledge, and they probably understand. I hope they probably understand. The stability. You know now the importance of the factor GZ. GZ is the stability arm. Funny thing is, GZ is 0 at 0 degrees of P. There is no stability arm. And it's actually because you do not need it. You only need it when you heal, because when you heal, you want there to be a moment to put yourself right again. That's stability. And instability is that something happens through which you do this. But you always hope that you will there somewhere, you will finally end up there. That's stability. That's the writing moment, so to say. The writing moment is the GZ, how is your displacement? Your displacement will stay the same, I presume will stay the same during this whole term. But the GZ changes all the time. It gets bigger, it has a kind of maximum, it hesitates a bit, and then it comes back again. And I think on the Kleine Zijlvaart I've drawn these curves. And that's the curve we're going to try to draw now. And it starts here. It starts with a larger healing angles. The first 5 degrees or so, we can speak of GM. And the value of GM is 0.5 or 1.2 or 2.3 or we did a healing test on baking at this huge 4-masted bark, and I was so curious to know what GM of such a ship is. And she's completely empty. She's empty. But the only thing is, she has no tank top. It's all open, the frames and such, and you see everything. But they fill her up with concrete. I think what I remember, so 1.5 meters of concrete from the bottom up. And that makes her pretty stable. In her old days, in her sailing career days, she didn't have this concrete. No, there's no way they did this because concrete doesn't pay. It's fixed. It's shouldn't be there. You should fill it with cargo, and cargo pays. So when they sailed in ballast, these ships, they took the stones or whatever they found. And when they were at anchor and bay to load, they unloaded the stones. And I think all over the world there are these tiny little mountains of stones left by these beautiful sailing ships. They did, of course, a healing test because I was a bit, I wouldn't say nervous, but at a certain point we had to step the masts. We had to come in. And they asked me whether I can make a table of moments for the rigging. Yes, of course, I can make a table of moments of the rigging. You can also, but I just need the numbers. But I made the drawings of the yards and of the mast and the topmast and the whole stuff. So I calculated. It was not such a long table of moments. But I came up to 170 ton of rigging. 170,000 kilo of rigging only. So mast and yards and running rigging, standing rigging, fuel kilometers, blocks and the whole stuff. But putting 170 tons on 20 meters just makes you a bit worried a bit. So they took a stability test before stepping on the mast and after. And they didn't tell me the results of the before. I think I was too busy to bother. But then they did a stability calculation at the end, and I saw that actually nothing happens with the ship. She felt really stiff. And she ended up with the GM of 2 meters and 30 centimeters. That's a lot. That's really, really, really a lot. And it was only due to the enormous amount of concrete that's in the bottom of the ship. So that's peaking. But if the ship heals, and it's above 5 degrees, then something happens. And suppose I draw a large healing angle. And this is the center line of the ship. Waterlike. The center of gravity. Yeah. KG. KG always measured along the center line. This is KG. In my first drawing, it's here now on the bottom, but TM was a little bit above the deck. Do you remember the former drawing? And TM was a little bit here. Here was M. But this doesn't work anymore. Because the definition of M was that the upward thrust equal to the displacement of the ship goes up, finds itself the center of buoyancy, and then crosses the center line of the ship. But if you do this here, no way you can find the center of buoyancy here, because the center of buoyancy is the center of this part. So something else must happen. And what happens is that after some 5 degrees or so, is that the center thinks, oh, I can't find the center of buoyancy anymore. Not at my position. So I have to go on the move. I have to walk through the ship and look down at the center of buoyancy again, where this upward thrust just so passes by. Now, in my case, in our case now, and she makes a healing angle of 60 degrees or so, where at this very moment is our center of buoyancy. And now it's actually your choice. Is this ship going to be stable or not?
No.
Is it a bit here or is it a bit here?
A bit more to the left.
Left.
On the left.
Yeah.
Because this is gravity. So if it's in this triangle, suppose it's here, center of buoyancy, then your upper thrust will go like this. Will she righten herself? Will she be upright again? If I choose the center of buoyancy here.
Yeah.
Yes.
Yeah.
Yes, yes, yes. But if it's really a not a triangle, but a square ship, and I choose the center of buoyancy, or it is just the case, and it's here. It's here. What will happen? Yeah, because then your upper thrust goes from here upwards, and then you have a negative stability moment. So, in other words, during the course of healing, at a certain moment in time, the center of buoyancy, which was all the time on the right side of G, passed underneath, no GZ, GZ0, and then passed through here, and you have a negative GZ. Because in this case, I'll just make the first one. In this case, chalks are way easier, but yeah, I have to do. In this case, it's like this. And then you find GZ
Marike?
here.
Marijke, beeld is heel slecht.
You're out of focus. Yeah, now you're back in focus.
Move slowly to.
Yeah, move slowly.
Perfect. Yeah, I know these cameras, they think they are intelligent and they focus on something, and when I wait on the side, it's obviously not working. But is it now better?
Yeah.
Yes, it's fine.
Okay, I stay here. And then you see that this upper thrust through this center of buoyancy finds its way and crosses the center line here. Not here in the original M, but here. And I bet you remember how they call this point.
N.
It's N. I think this is about where we ended, more or less ended in the Kleine Zeilvaart. It is point N. And when this is called the initial metacenter, this point is called the false metacenter. It's not a real one, it's not the one we are used to use because we know Km, but it's the one that you get when you increase your healing angles. No worries, because the n is always given. So it's not that you have to calculate it or do complicated things. It's always given because it has everything to do with, of course, your weight, so it's draft related, but then it has everything to do with the shape of your ship. I suppose this is a square ship, but your ship is more like this, then your central point is way more to the left. And then you have a bigger GZ. It takes longer to find this zero GZ. And maybe you remember, and we see it later on in the graph too, that there at a certain point it rises as its maximum, and then it drops down again, and then it crosses the zero. And they call this distance from zero to the point when it's zero again, the stability range. And to me, the stability range is very important. But we will see this later. Should however, your central point be here, then it's like this. And it goes up, and then you have a problem. Because then, this is your GZ. It's called GZ. That does count. It's called GZ. This one. But it's a negative one. It's on the false side of the line. And the fun thing is, it's an automatic negative one. So you will always find it. The only thing you have to do is follow the formulas that are in the back of your reader. This is the game that's played. You want to know how a stability curve starts. So what's the initial stability of a ship? Is it tender, so does it move quite easily? Like my own boat, he was with just a little wind, so I always have to prepare my coffee in advance. Or is he a very stiff ship? And stiff means I have a huge PM, and I resist heeling, and I'm very stable, so to say. But being very stable is not always an advantage. Because being very stable means also that at the same wind force, suppose you have two ships. One is tender and the other is stiff. That with a tender ship, when the wind blows, can do this. Whoa. Okay. But if a stiff ship, which is very stable with a high GM, really resists, then the forces on the rigging are equally high. So you would rather, certainly in sailing ships, have them a bit tender, so they move with the forces. They give way a little bit. But when you are really like this one, whoa, I am so strong, then you also have to be strong, because otherwise your rigging will be blown out. So it's always, the one has always very much to do with the other. So stability has all kinds of consequences for your sailing ship at least. How do we calculate one? Now, when we calculate one, I need to make a drawing that has not such an immense steering angle. So I make another one. Where is my blue one? Borderline. Center of gravity. K G. Center. I make it stable so we can really see the difference. Metacenter. No way, metacenter. The false metacenter. Our healing angle is larger than 5 degrees, so it's now from 5 to 180. This is upper thrust line. And displacement. K is here. Yeah. And this is the gear angle. And we want to find the corresponding GZ, for every healing angle there is. From 5, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and all the way 180, then above 180 it has no use, because if this is 0, then this is 180, so you are upside down. This is GM, KN. KN. And we find this one. GN, that's it. GN. I recall that we need to find some, we need some help. We need some help. Because this is the one we are looking for. And that one is actually the same as this one. This one with this angle here, minus this one. So actually, this one has to do with the shape of the ship, with Kn from here to the upper thrust line, and this one, the green one, has to do with the weight of the ship. This is this triangle, and that's what you have to subtract to get eventually blue, 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 blue. Can you still see it, or is it too far away? We need this one. This one and this one are the same. So it's the red one minus the green one minus your center of gravity. Should your center of gravity be high, then you have to subtract a lot. So your GZ, your stability arm, is much smaller. This one minus this one is the blue one. Well, I remember in the Kleine Zeilvaart, this is K. This point, I believe we called D, and this point is called E. But now I'm going too fast. Do you remember this one? Oh, sorry, this is the H in English. The Soka Toa. What does this have to do with stability?
Baseline? Coaching is het.
Aanliggende
hoofdstand aan.
Has everything to with triangles?
Yeah.
I remember this is the sinus. And it's a relationship of two sides of a triangle. This is the cosinus, which is a relationship between two sides of a triangle. And this is which is a relationship between two sides of a triangle. So the only thing we need to do is draw a triangle somewhere. Draw a triangle. I'm going to do it here. Draw a triangle. Can you still see it? And this is the angle. And if these are the sides of the angle, what is this? The O.
Opposite.
Opposite.
Opposite. That must be this one. Opposite. So at the other side. The H.
Hypotenuse.
It's a headline.
Hypotenuse.
In Dutch, I don't know how many in German, I don't know, but in Dutch it's the sos castoa. So the H is an S. And I believe the S is the schuine. But in English it's the so castoa. And the H is this one. Or the hypotenuse. Hypotenuse. You can forget it also, but it's the hypotenuse. And we are left with A.
Adjacent.
Yeah, in Dutch it's the aanliggende, it is the aanliggende,
At the
but in
same
English it's the adjacent.
Oh, that's very good.
It's the adjacent, and we have a 90 degrees angle here. So we have the sinus, which is nothing more and really also nothing less than the ratio between the opposite and the hypotenuse. The cosinus is the ratio between the adjacent and the hypotenuse, and the tangents is these two. It's just what in the world of mathematics they agree on calling it. But we have, and that's the nice thing, we have triangles. We are in the real art of triangles, and the biggest triangle is this triangle. The bottom, all the way up, to the fourth at the center, and down again. This is the 90 degrees angle, and this is the healing angle, so to say. Which one of those could we use if you look at this triangle? We want to know this one. Actually, KE, and we know this one. I think that's the hypotenuse.
Yeah, that's sinus.
Sinus, cosinus, or tangents?
Sinus.
Okay, sinus. Sinus of the angle. Up to you. Sinus of the angle. Tessie, hoe doen we nou de sinus of the angle? Is the ratio between the opposite and the hypotenuse. And the opposite is
KE.
KA. Yeah. Over KN. I'll give you another triangle, the smaller one. I hope you can see it. That's this triangle of the center of gravity down, and it's all in your. It's not in the new reader of the grote Zelvaart, but it's all in the reader of the kleine Zelvaart. This is the angle, and then it goes up again. The real triangle. If I do the same, because here we have. Well, up to you.
KD.
one should I start?
KD.
KD.
KD, yeah? Okay. Over
KG.
KG.
KG, yes. Hey. If I look closely, if we look closely, then KE minus KD is the GZ we are looking for. So this one minus this one, your weight and your calculation of annual moves, minus this one, oh sorry, this one minus this one is the blue one. So the blue one, GZ, and there she comes, GZ. At any angle of heel is KA, red, KA minus D. This one is this one minus this one. But I have these formulas, and I want to know what KD is. Maybe with a little bit of mathematics, I can figure this out. I know the size of the angle because I am calculating GZ at a certain angle. So suppose I want to know it at 10 degrees, then I only have to do sinus times the sinus of 10 degrees. It's in your calculator. I think I know Kn, because I know somewhere on this line is your center of occupancy, so they must know it. It's in a kind of table somewhere. So Ka, if I do this G, Ke is
Sinus keer
this one times this one, isn't it? Kn times the sinus of the angle. If I do the same in this one, I want to know Kd. So I rewrite a little bit of mathematics. You wouldn't be in the grote Zijlvaart if you were afraid of mathematics, I believe. I presume. Because at stability you probably need some calculator, but mind you, that's nothing in comparison what you're going to experience in any field class, so it's going to be okay. KD is
KG
times sine 5. And there she is, ladies and gentlemen. It's, you have time to make it good, but here she is, and now I need the right color. GZ is, and then I need the red one, KN, sine 5 minus sine 5. And there she is. There she is, there she is. In one day, in one single day, we come through the whole stability of Kleine Zijlvaart. GZ is Kn sine 5. Don't forget this one. Kn sine 5 minus Kg sine 5. And what it actually says, stability is every time it's it's acting on the shape of your ship. It's the shape of your ship that makes it start, and that's Kn sine phi, because Kn comes from the shape of the ship, or the ability of the central buoyancy to move to the leeward, and this one is yours. If you have to subtract a lot, then your GZ will be small. If you have to subtract a little, because Kg is nice and low, then subtract just a little and you have a tough GZ. But the fun thing is, this is not it's not linear. It doesn't rise. It doesn't rise like our corona numbers are in these days. So nothing exponential. But it starts your GZ, then it has a maximum. So this one has a certain maximum because at a certain point your buoyancy point cannot go further out because there's nothing there. So then it comes back to you. And when it comes back to you, this part will get smaller, and eventually these two are the same. So in this case, they are both in this line, so they do not have any distinction, they are both the same. Then this one is 0, and then it starts coming towards you, and actually it's kind of the center of, you could see it, you could feel it like this, that you have your ship out with the upward thrust, and here it's all right, but at a certain point, the center of gravity tumbles over your center of buoyancy, and then it starts to move at the wrong direction. So here it's still like this. If it's in this side, it's like this. Then actually this crawls over this one, they change places, and then suddenly you have this motion on your ship. And that point is what I said earlier, the stability range. And this one turns out to be 0 again. This is the one you're going to work with a lot. And I already said that this one is yours. This one is yours. This one is yours. That's your table of moments. That's your table of moments. This one is yours too, because it's your shape. But you need not calculate this, you just have to find it, like in any other quiz or something. You have to be able to find it, and you find this one in the so-called cross curves. If you have an English, stability booklet, it's called cross curves. If you have a Dutch stability booklet, it's called, I believe, Dwarskrommen. Und wenn es ein deutsches Stabilitätsbuch ist, dann ist das quer etwas. Also ich kann nicht noch nachsuchen, was es dann ist. Aber in the cross curves, and obviously, Samson Carey has them too. The cross curves of Samson Carey are to be found. And Samson Carey can be any other ship. It's actually only to make exercises, just to get your fingers relaxed to make stability calculations. It can be any other ship. But you have this hydrostatic particular table. There you find draft, displacement, and in the last column Km. Nice. Some other things, but that's for later date. But if you turn your pages, at some point it changes. And I think I see here page 25, 26, and it looks like this. This. Here says Kn sine phi. And I know some students, some colleagues of you just came to me very enthusiastic. Wow, I have a stability book of my ship. And it was a really nice stability book. But I failed the cost curves. And if you do not have the data for KN sin phi, so actually the data at every angle of yield of this one, for which you are able to subtract your center of gravity and then come up with your G's. And if you do not have this, you have nothing. So always check your stability book. Did they supply me with the KN sin phi values? Well, the only thing you need to do now is at a certain draft, I must say this, at a certain draft. Now suppose it's the draft is, I will highlight it, it makes it quite easier. The draft is 3 meters 30. Can you see it? 3 meters 30. They give a value for Km sin phi for 5 degrees. They give it for 10. They give it for 12. It's a strange number, but this 12 has a reason for cargo ships, because 12 degrees is, for instance, a number for which ships that carry cargo that can shift may not exceed. So they may not exceed an angle healing angle of 12 degrees. That's why Km sin phi 12 is in. And 15, 20, 30, 40, 50, 60 degrees healing angle. And so if you want to know G's at 60 degrees, at this particular draft, you take the Kn sin phi for 60 degrees, which is 6.229, and then you subtract your center of gravity multiplied by the sine of 60 degrees. And then you find your GZ. You can, I will say it's easy, but you can make a table like this. You can make a table like this. And I think it's in your Kleine Zouvaart also. You start with, of course, with the angle. Always start with 0. It might seem stupid at this very moment, but 0, it also gives some courage. But because if you start with 0 and then, for instance, 10 and 20 and etc., your second row is Kn sin phi, which you find in your table, in this table. The second is, or the third, sorry, is Kg sin phi. So it's Kg times the sine of 0. Kg of the sine of 10. Kg times the sine of 20. And here you have Gz. The first column, what I said, gives you some courage, because what is obviously the Kn sin phi of no healing angle, so healing angle is 0. There is no 0. 0. What is Kn sin of 0 degrees? Kg sin 0 degrees. What is sine? The sinus of an angle of 0 degrees. Maybe that's a better question.
Maybe 0.
Yeah. So this is 0, this is 0, and this is 0. But all the other ones have to be calculated. There is something stupid in this table. Because you are able to calculate the stability curve at every angle of heel, but it only goes up to 60 degrees. And if you have other drafts, you have more pages to look at. And that's annoys me, because I would always like to know what the stability range of a ship is. And if you only are given the KN sign values up to 60, you will never know. Because probably the stability range, where the curve hits the bottom again, is again 0, is in such a ship, I think, 90, 100 degrees or so. But you will never be able to calculate it. And why they do it like this has a reason. And I think a kind of strange reason, because this only anticipates on the rules and regulations. That's what we will see next week when we are going to do something new, dynamic stability. Then you will see that all the rules and regulations are actually only up till, I think, 40 degrees. And then it stops. There are no rules and regulations for cargo ships that exceed the 40 degrees. So no rules and regulations on stability range whatsoever. I must admit that for sailing ships, they also do not exist. So rest my case. But also, I think only in that's called in England, the Marine Coast Guard Agency. They also have rules and regulations for sailing ships, and they say that the stability range, where it is 0 again, for it later, should be at least 90 degrees. So this means that when this is upright, and this is upright, and your ship heels, then it must be a positive GZ up till 90 degrees. So up till 90 degrees, this one should be higher than this one, larger, or should exceed this one, up till 90. But a good ship, in my view, a good ship has a positive range up till a bit like this. Because if you have a knockdown on your ship, if you experience a knockdown, I think most of the times it's 60 degrees, and then you get scared. But it could happen that your ship knocks at 190 degrees, and then you still want, with all your sails and stuff in the water, you still want some force to get upright again. So that's why it would be nice if you still have a stability arm at 110 or 120 or whatever, 150. Like I believe the Blue Swan and Europa and this girl, I don't know, who's taking, I don't know what stability range is. I go to calculate it. So that's important, but I'm out of paper. But I know that just around the corner is some paper, additional paper, and I'm going to get it to draw you a stability curve, or how you should draw a stability curve. So you have 2 minutes break. See you soon.
Dat is maar goed, een klein cel.
Ja, dat is ik wil het ook in één dag kunnen doen.
Ja, al die tijden bestaan. Ja, voor niks.
I said this one. I will do the KZV. And he said, oh, then I will do the KZV. Now I'm sitting here.
En Jort zal er
Real chicken.
De KZV is voornaam. KZV between August and September.
Mag wel weer
Alright, and then I feel sorry for you, because while I'm there, and we can communicate obviously in a very, very much easier way. And I feel sad that I'm not there. But these are horrible times, and I think only that we are at this way together makes life a little bit easier. And a lot of people do not have those possibilities because they are in quarantine or whatever, sick. So it has to be like this, no option. But I feel sorry that you, after class, you can't go into a cafe and drink a beer together and this stuff, but you will find other ways to communicate. The last thing today, a stability group. It starts with the exits. Is it okay to do it here, or should I be more in the center?
Okay.
It's okay.
It's okay. That's okay, yeah.
One exit. And this is the GZ in meters. That's here. That's the Y. Then I will Papa. This is the healing angle for sure. Healing angle in degrees. And you will see that Samsung carrier never goes beyond 60 degrees. But let's just be bold and we do this one up to 180. 180. So here is 190. And here is 0. And it's 0.1, 0.2, 0.3, 0.4, 0.5. When you do, maybe at home, I don't know, but when you do this in your exam, you get this millimeter paper, these like tiny little squares, so that makes life a little bit easier. You always start your stability curve with incorporating GM. That's the easy bit. Because GM, you pre-calculated GM in VM KM minus
KG.
That's what you've pre-calculated. This one you start. And you do it like this, and it has also something to do with the sinus and triangle 3 or whatever. But I remember, do you remember this angle? It's nearly 60 degrees, but not quite. And it has something to do with 1 radian.
57.
57.3. 57.3 here. 57.3 degrees. And this is 1 radian. This means that along a circle, if you have a circle here, you have a circle here, and the circle has a radius r, radius, half half this one, and you put this here alongside. You can do this, I believe, just read it in your guidance article. You can do this 2 times our good old friend pi times r, and lay this around your mast. And if you do this 1 time, and this angle is 57.3 degrees. That's the origin of it. But I'm not going to ask them it, so you might just forget. But you calculated GM and 0, make it nice, and in accent. So this is also an accent. which means you have incorporated
Free surface moment.
yes. I have a GM of 0.45. 0.4. It's a cargo ship, it's not a sailing ship. And then you put on this line and this line. And you have a point here. And through this point and through 0, you draw a three-point line. And you need, I think when you do these drawings, you need a rule card, set patterns, which I do not have, so I just try. You made a tangent line from 0 to this point, 75.3 and 0.45. So GM, X and M is 0.45. You can write it down like this. What you now know is how your GZ curve will start. It's like a rocket. It sets off at 0 and then it goes, and it, like my little boat, has a very small GM and it starts like this. Or if you have a huge catamaran GM, your curve will start like this. But sometimes ships that are initially very stiff do this. And this ship will probably do this. My tiny little boat, and that was really a surprise to me, has a very small GM. A little bit stupid, she's very, very tender. But should I ever decide to cross the ocean with this ship, I think I'm reassured. Because it starts like this, but it ends here. So this means it's like a puppet. It will always, even if it has 180, it will always upright itself. But in our case, we are going to calculate GZ of 10 degrees. We know it starts like this. That's for sure. That's the first part of your work. Then at 10 degrees, it's, let's suppose you have calculated it here. It's something minus something, and you have a value here. Suppose it's here. 10. You do this for the next one. And 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 for the next one. For every following line, you calculate GZ for this value. And the only thing you need to do then is draw a curve along the way. But it must always end here at 0 because you are stable upside down. And this is not bad. It could be a stability curve of will the swan walk it's 150. But something way better, a little bit better than the Wilde Swan. And but this is how it's going to look like. Only when what you're going to check in the Samsung Galley just to practice, will stop here. So you will never draw this whole axis, but you go to the 60 and then it's done because you do not have other data on K and sine phi, so that's over. If you start with this one, you actually start with the situation, the loading condition, table of moments, you calculate it with Km at the second draft, the draft you get when you are loaded. This is the one from your table of moments. You have your Gm, You put it in the graph, it's 57.3, you know where you start, and then you make this table, because you know your graph, so you can find all these kn sine phi. Kg sine phi is to be calculated because you have kg from the table of moments, and there you are. Before you know it, at the end of the coming week, you have made yourselves a few beautiful stability curves. As if you have done it always, if it's part of your system. And of course, it's not so wildly important that you do this in a few minutes. What is most important to me is that if you find a stability booklet somewhere and you open it and you say, hey, I know this, I know how it's made, and I can read it. That's, to me, it's the most important. Because here you have your GM, it's always in such a graph. Here you have your G, Z, flux. Not unimportant where G, Z, flux is at a certain angle. And of course, in our case here, you have your stability range, which is maybe not important in the sense of rules and regulations, but I think important to you. If you all must have some ring, because otherwise you are not in the cell part. Either you just want to learn to get knowledge, or you want to go to fly away somewhere. And then it would be nice that you just have some kind of sense of what stability range is, and that how this might save you when you are in bad circumstances. And of course, we are going to calculate these bad circumstances because next week, what I said to you, this is the basis of it all. Here you find the shape of your ship together with the center of gravity of your ship. But in this graph is also hidden the dynamic behavior of the ship, and that's what we're going to look at next week. And that's where, if it's okay, that's where chapter 1 of the reader of the Float Sailor, dynamic stability. You may prepare yourself and read it, but I think you will be quite busy the next week in the exercises of lesson 1. Maybe you are first busy to check the Kleine Zaalvaart reader because you have to catch up. But we've gone through it all, so that goes fast, I think. But you might try with the Samsung K the exercises of lesson 1 and the 4th, because we are now in lesson 2. The exercises of lesson 2. The only thing I want to say to you is keep calm. That's fine. Don't panic. And I'm sure we will, at a certain point in time, we will disagree on the interpretation of the text. Yeah, but is it loaded? No, it's unloaded. No, it has to this, it has to that. I'm sure we're going to be there, but that's completely okay. Of course, what I try to do in the exam is say that we do not have these discussions, and it's clear. But these questions are very, in this exercise book, are the old questions of very old stability exams. So sometimes they are mad. But it will just help you to make your exercises. What I want to is that you try these exercises of lesson 1 and 2. It's going to be a hell. It takes some time. I don't know if it's allowed to make study groups. I think in Corona times you can only gather with 4 or 3 at your house, 1 per day or something. But it's also, I think, yeah, what I want to say is be careful, please. So I hope I see you in good health next week again. So don't exception. No?
Exaggerate. Don't exaggerate.
Exactly. Yeah, I know what I mean. And I have to. Because I have decided not to make the exercises like this, because I think then we lack communication, because in exercises you discuss a lot. So I would like you to send me your results, and send me your doubts, and send me your questions, and we can do it via Skype or whatever, also with a small group or via Microsoft Teams if you have this. But this is something we can discuss during the week. And yeah, it's different than in the old days, but maybe the contact is more personal. And I read in the paper that what I said earlier, maybe classes are not like normal, but the results are better. So that's where we go for the results. I think with me seeing you a little bit better, it works also a little bit better.
Yeah.
But if you have suggestions, or think maybe we should do it in quite another way, or whatever, I really like to hear it, because this is out of the ordinary. And I'm not sure, because it could be possible that in a week they decide to a complete lockdown. And if there is a complete lockdown, then we all have to go home. And then we probably do the same what we do now. But then we have contact, everybody has contact separately through the same program I am using now, and that's Microsoft Teams. And then I see a classroom full of people, but they're all sitting in different places. Let's hope that's not necessary. Yeah, it's out of our reach. I think the only thing what we can do is take care and stay healthy and drink a beer on the first day today. I wish you a lot.
Thank you.
Have a good weekend. Stay at home and we hear from each other through email or whatever means. We can certainly start with email and. Okay.
Okay.
I'm going to shed a tear that I'm not there.
Okay. Bye.
She was so nice to play. She has been promoted. She's now the dog of the yard. And when I had my contract negotiations, they said it's forbidden for dogs in the yard. And then I said, okay, that's my time. I'm not coming. And then I said, oh no, okay. Acceptable. But now she's been promoted as well. She's doing fine because the other thing is because they feed her all the time. But anyway, bye.
Bye. Bye.
So.
Quiet for a minute.
Alle antwoorden. Deze. Exercise. Al die antwoorden staan uit. Wat is dat nou? Hier.
Maar het zegt hoe het is. Ik ben er goed in telefoon maken. Precies. Hey Mark.
Ja. Je doet ook het worst. Ja, ik heb zo'n handen voor. Daar antwoord nog meer moeite gehad om het bij te brengen.
Ja, we zijn nou bezig om zo'n penningmeester te worden.
Zo. Het is mij niet helemaal duidelijk waarom we deze map kregen.
Nee, het is zelfs een beetje verspild.
Ja, ik krijg er wel volgens mij waarschijnlijk van over. Denk je?
Maar, en het enige wat we nodig hebben is het schema zat erin.
Ja. Het schema zat erin, toch?
Nee, niet van ons. Nee, niet voor mij.
Ja, niet vergeten.
Tot volgende week.
Ja, tot volgende week, hè?
Hoi, gezond.
Blijf gezond.
Ja, blijf gezond.
Ik ga het verder mee.
En de achterkant van de KZV? Oh, dat heb ik niet op de achterkant van de KZV staat de GZV. Bij mij. Dus hebben ze vergeten om jou te korteren.
Ik snap het.
Gaat iedereen nou zomaar weg?
Ja, ik ben niet ergens.
Ik heb niet ergens drinken. Nee. Dat is wel jammer. Zo. Dan vraag ik me toch af wanneer de KZV heeft gegeten. Hebben die al om 12 uur gegeten? Weer heel andere.
Die staat in het brood. Zal ik eens kijken?
Nou,
Die hebben eerst 3 lesuren. En dan hebben ze een pauze van
en dan hebben we 2 uur.
Ja,
Die zijn een uur voor ons gegeten. Ja.
Oké.
Denk ik. Dan. Ja, achternaam is
Morgen vrijdag.
Baars.
Oh, Baas. Ik ken namelijk ook een Hans-Peter Baart.
Nee.
Maar dan in Duitsland met B-A-R-T-H. Dus dat zal
Oké.
grappig geweest zijn.
Ja, nee.
Lopen wij gezellig naar
Ja,
de
we
parkeerplaats?
lopen gezellig terug. Alleen vind je het heel erg als ik nog even iets ga doen dat ik rustig weer in de auto zit?
Dat is mij ook verstandig.
Anders wordt die auto zo nat.
Of misschien doe ik dat ook even nog.
Anders wordt die auto erg nat. Zullen we dat doen?
Waarom spreken?
Ben je er nog? Zit je nog te kijken?
Oh ja, ik zat het allemaal nog te bekijken. Ja, ze zien jullie vertrekken.
Oké. Nou alleen zo kost Monique nog.
Ja.
Maar ik moet zeggen,
Ja,
het,
de postman zal de boel alweer uitzetten.
ja, maar ik doe nu even af, want ik zit.
Ja.
Maar het,
Hoe vond je het gaan, Hans?
ja, ik vond het was vanmiddag veel beter.
Ja, hè? Ja.
Ja, het was echt, en ja, ik wil niet zeggen als vanouds, maar ik vind Marijke, je deed het echt heel goed.
Nou, fijn.
Gewoon een beetje enthousiasme en ik snap, voor mij moet het ontzettend lastig zijn dat je, de interactie is toch lastig.
Ja.
Ik weet niet bijvoorbeeld of je de camera nog wat meer, of de camera wat meer kan inzoomen op de klas.
Nou, dan ben je de klas kwijt. Hè?
Want volgens mij is het voor jou heel... Want volgens mij is het voor jou, of zet hem bijvoorbeeld onder hier. Ik weet niet of dat kan, onder
Nee,
het
daar is het
scherm.
te kort voor. Ja, dat kunnen we nog wel eens even kijken. Of
Want dan kun jij ons beter zien, volgens mij.
Ja.
Ja, dat zei ik ook al, hè, dat scherm moet lager. Ik moet lager zo. Of niet?
Ja, voor jou nee, voor jou is het goed. Jij bent goed, maar volgens mij zie jij ons niet zo goed.
Wat zeg je?
Volgens mij zie jij ons niet zo goed.
Nou, ik zag jullie vanmorgen helemaal niet.
Nee, maar nu, maar...
En ik hoorde jullie ook niet. En het beeld blijft ook achterin staan. Dus...
Ik zal het kanaal even afsluiten.
Vanmiddag ging ik inderdaad met stukmetingen.
Ja. Ja. Nee,
Top. Mooi hoor.
Ja. Wordt dit ook opgenomen? Of, Dat kun je later nog weer terugzien?
Nee.
Dat niet.
Alleen voor de mensen die thuis zitten, die
Ja.
hier niet aanwezig
Ja, nee,
kunnen
dat
zijn.
was gestreamd, zeg maar het wordt niet...
Ja, het blijft ook gearchiveerd. Hey, tot volgende week.
Het is heel lastig met hoorapparaten en de geluid.
Hier kan ik niks aan. We hebben die speakers nieuw geïnstalleerd, maar misschien als je op een andere plek gaat zitten, dat het minder stoort op je gehoorapparaat. Kunnen we volgende week eens proberen? Ja, dat is het sowieso. Je gehoorapparaat geeft dan de juiste weergave. Het is echt blikkerig, ja.
Dus, maar goed. Ik heb Huub om het
Ik
ondersteunen.
heb alleen een nieuwe verwoest hier in mijn kantoor.
Oké.
Wat zeg je?
Alles erop.
Ja, ik vroeg me af, kun je niet gewoon twee, bijvoorbeeld, kun je niet twee whiteboards daar neerzetten?
Ja, maar die hebben we niet. Die hadden we niet natuurlijk. Dus dit hebben we maar opgehangen zo.
Ja.
Maar goed, maar komende week krijg ik een digibord.
Oh, dat is zo'n uitwisbaar elektronisch scherm of zo? Wat is het?
Ja, en dan kan ik ook met mijn vingers tekenen.
Ja.
Dus ik heb geen idee. Ik weet niet hoe dat dan moet werken met de interactie. Maar we gaan het gewoon proberen. Ze hebben een speciaal.
Dat doet de werk voor je. Ja, ze doen echt alles om met je naar de zin te maken, hè?
Ja, maar ik moet nu wel een pot witte verf kopen om die vlekken eraf te krijgen.
Ja.
Want het ziet er wel stom uit.
Ja.